Hello team, welcome to my session on Coffee with Prab, and today we're going to discuss about some of the foundation topics on network security. It is part of my new series which is called Network Security Foundation Masterclass. Agenda of introducing these videos is to give you the context of the network security topics completely from scratch, talking about networks, type of network, OSI, protocols, and these topics not only useful for the network security team, it can be useful for the GRC team, it can be useful for the people who are preparing for a certification, any certification which can be CompTIA, IC2, ISACA. My name is Prab, and without wasting a time, let's start with the first part. Thank you so much. Okay, so let's get started with the module 1, which is called networking groundwork. Before we jump into the core topics, let's first understand what is computer network. Computer network is a two or more devices linked together so they can exchange data, whether it with the help of wireless or with the help of wire. Let's take an example. We have a system A. Okay, it has a C drive, it has a D drive, it has a E drive. And then we have a computer B. Okay, now computer B want to access the data from A. So he need a media. Now this media can be my wired media, or this media can be my wireless media. So we have a mechanism by which we can able to move data from A to B. So when they are working together through this media, this representation is called as a computer network. So today what you see, the network is completely different before 1970. So computer network, that's why I said two or more devices linked together so they can exchange the data. And those devices might be the PCs, it can be server, it can be phone, it can be sensors, it can be cloud instance. And the link can be a wired, which is a copper cable or fiber, or it is a Wi-Fi, which is called as a Wi-Fi, cellular, microwave, or satellite, which we're going to discuss in the further slides. Now, it was not like that what you see today computer networks. Okay, so if you take an example of the computer network perspective, in 1969, earlier the computer used sneak net. Okay, so what is sneak net is, it refer to a practice of transferring data between computers by physically moving a storage medias. We used to have a floppy drives. So rather than using a network connections or internet connection, we use a floppy disk, we use tape drives, and we move data physically from one location to the other location. And that actually wasted a lot of time and also have a risk of data loss, and it stopped the real-time collaborations. And networks basically solve those pain points by letting device share with the help of link. And that's something we need to discuss now. Okay, so next topic, in the computer network, we have a two-way of transmitting data. So we have a two type of signals we called as a nature of signal. One is called as analog. Okay, one is called as analog, and one is called as a digital. So we have a two type of signal, and the signals can be traveled by two type of media, wired media and wireless media. Let me repeat again. When computer A sending a data to B, there's a two way to send the data. There's a two type of signals we have. We have a two type of nature of signals we have. One is called analog, and one is basically called as a digital. Okay, so first let's understand the analog. Analog is more like a continuous, okay, it is smooth. Okay, so that is called as analog. So your old AM FM radios, you hear continuous signal through airwaves, right? So that is basically called as an analog. Analog means continuous signal. Now how to understand that? Let me explain you. So if you take example, this is basically called as analog. It is same like you're talking directly to someone face to face, and your voice flows smoothly and continuously, not broken up into the pieces. Is it clear? So question is, where you find your analogs? Your traditional radios, which is your AM and FM, are basically using the analog. Your old fashioned telephone calls, landlines, this is the landline you have, this is the phone you have, there's a cable is there. So data which is transferred through this cable is direct end to end. Okay, so that is basically called as an analog. But problem is that your computer understands digital. So digital mean information is turned into a separate pieces. So in this section, if you can see, Let me show you that. So let's take example. We have a system A and we have a system B. So data is divided into ones and zeros. So it is not sending a continuous, okay? It turn the data into separate piece, which is called ones and zero, and it is precise and organized. It is same like when you're sending hi on WhatsApp, right? H, then hi. So each letter you type is distinct and separate, not flowing continuously. So your computer and smartphones, your streaming videos, your internet calls, all are the perfect example of the digital. So in more layman term, analog is just like your clock with hands smoothly moving around. It never jump from 1 second to other. And digital is like a digital clock, changing numbers clearly and distinctly every second. Now question is, Prab, if analog digital, what is the role of wireless? See, wireless is not about analog digital. It describes how the signal need to be traveled. Is it clear? So wireless is like a road, which talk about how the signal basically move. And vehicles are the analog and digital. So analog use continuous wave, where varies, which is about amplitude frequencies used in broadcast, radio, TV. And digital transmission send pulses that represent bits 0, 1, 0. And today it is used in Ethernet, DSL and all that. So if you see the traditional landline, so we have a landline, the cable comes. Okay, so the cable is connected with your landline phone. But when you remove that cable, you use the modem, remember? And then from modem, there is a one cable is going to the computer. So converting the analog to digital. This is the role of a modem. Okay, so modem is a device which work on the physical layer of OSI model, which convert your analog to digital. Understood? That is why traditionally what happened, if you want to use internet, the phone will not work. And if you're using a phone, internet will not work. Today, we have a shared connection. Okay. So today your telephone line, whatever is coming is basically analog only. And modem is a device which convert analog to digital. Okay. So analog is listening to your traditional radio, and digital wireless is watching like Netflix via Wi-Fi at home. That something is there. Now next topic is basically called as a networking devices. Okay, because definitely computers connected via media and media connected by the devices by which we transfer the data. So we have a different type of devices. We have a hub, we have a switch, we have a router, we have a modem, and we have a firewall. And each and every topic we're going to discuss in detail. Okay, so first we're going to discuss about the repeater. Now what is repeater? Repeater is like a device which is used to amplify the signal. Let me explain you. We have a system A and we have a system B. Now let's say example, this is a cable. You're sending a data from A to B. Now signal is like that, but here what happens, signal is basically dip. So what we did, we installed the repeater which is used to amplify the signal. Now repeater is two type, wired and wireless. And the best example of wireless is the Wi-Fi that you use in the house. Let's say example, there is a ISP line is coming to your house. This is your house. Okay. Now you have a first floor, you have a second floor, and you have a third floor. The modem is installed on the first floor, ground floor. That Wi-Fi signal cannot go on a second floor. So in the second floor, we install the wireless extender. So what it does, it extend this device signal to other network, other locations. Is it clear? Because the Wi-Fi that you use in the house, okay, it can basically cover a particular frequency range. Or let's say example, you have only one floor and you install the modem here. So the wireless frequency can work till this part, but I want a wireless signal here also. So here we install the extender which extend his signal to there also. So that is the example of wireless repeater. Same like we have wired repeater we install on the cables to extend the signals. So ultimate goal of repeater is to amplify the signals. Next is basically called as a hub. Hub is a device. Hub is a word mean a group of ship. You know ship, group of ship. Hub is like that only. Hub is called as a non-intelligent device. We don't use today. So let's say example, this is my hub. We have a system A, we have a system B, we have a system C, and we have a system D. So we have a system A, we have a system B, we have a system C, and we have a system D. If A so hub is a device which is used to connect all the systems which is connected with the same port. Now if A want to send data to C, A send data to hub. What hub does it? Hub broadcasts the data to all the ports. Even the data is not, the D doesn't want the data, he will receive also the data. So if someone initiate the sniffing tools and all that, he can able to intercept the other data also. Now just imagine if A sending the data, B also sending a data, C also sending data, they're broadcasting the data to all the ports. So what happened? It create a collusion. And that lead to the data loss. What is collusion? From here also data is coming, from here also data is sending. So there is a possibility of accident, and accident lead to the data loss. So hub is a device used to connect multiple systems together on a same network. But one problem is that it broadcasts data to all the ports. Even it gives the data to the desired system, which is not authorized for that. Is it clear? Modem we already covered. So whatever the connection is coming to our house, let's say example of India, we have a Reliance, we have a MTNL, we have a BSNL, we have a Airtel. They are basically sending me a telephone line. This telephone line basically carry the analog, but your computer or laptop understand digital. So we install the device, which is called as a modem. So modem is a device which convert analog to digital, and digital data convert to analog. So it is just act like a multiplexer. It is act like a translator who convert the analog to digital and digital to analog. Let's move to the other device, and all are basically work on the physical layer of the OSI model. So we have a different type of computer networks. Okay, so first is called as a PAN, personal area network. Let me give an example. This is your phone 1 and this is your smartphone 2. We're using a Bluetooth. I'm sure in your phone you have a Bluetooth option, and through the Bluetooth you exchanging a file. Before we use WhatsApp, so today we use WhatsApp, right, to exchange the messages and image, but it was not like that before 2015 or 2012. So we used to enable the Bluetooth connection both side. We used to create a peer-to-peer connection, and through that we basically exchange the images, files from one mobile device to other device, and the distance is very less. And that group of device which is communicating by Bluetooth and exchange the data, that kind of a network is called as a personal area network. Okay, then we have a LAN. LAN is what? So we have an office. Within the office we have a switch. We're going to discuss in the further slide. And we have a systems which is connected within that switch. So system A can only communicate within that systems of the networks, and it cannot able to communicate outside the organization. So that network is called as a LAN. It is same like when you go to the hotel. So you dial the extension number, right? You have an extension to call reception. You have an extension to call the peer room members. But you cannot do the calls from that landline to your friend's phone number or your home. So they give you extension numbers, you can call them, it is free. So same like we create a network within the office. We have a group of systems which communicate within that office, and that is basically called as a LAN, local area networks, which can be one building or campus. We need a high-speed internal sharing. We can use Ethernet and all that. Then we have a Wi-Fi. The same within the organization, instead of computers are connecting via wire, they connected over the wireless. The Wi-Fi that you use at home, right? So you are sharing the access point with your family member. If any guest come, he want to connect the Wi-Fi. Definitely you will not the person who going to give him a cable. This is the cable connect and access. Then no. You give them a password, and by that you can able to connect with the Wi-Fi, and that is basically called as a wireless LAN. It means we have one access point and all systems within the house can able to connect with the access point. But if someone is sitting 100 kilometers from the house, can he able to connect? No. So the access point will only work, which is basically cover a particular frequency. If in that house the access point cover that frequency range, any device in that particular radar can able to connect with that, and all will basically get a same LAN network IP, and they can able to communicate together. But if we have another apartment and they have an access point and they want to communicate, they cannot able to, because they are in different network. So this is basically one apartment, they have access point. This is a one apartment, they have access point. Whatever the computer part of that network, they can able to communicate within that, but they cannot able to communicate with these systems because they might configure on a different IP with different network. Then another network we called as a CAN, corporate area network. So let's say example, we have a building 1 and we have a building 2. Okay, so they already have a one LAN. All systems are communicating with that. We have a dedicated LAN and all systems are basically communicate with it. Now what you need, you want this building to communicate with this building and this building to communicate with this building. So they want all these buildings to communicate with each other. And that is basically called as a campus area network, where the several buildings in one location can connect. We can consolidate multiple LAN and we can have a university campus with the fiber rings and all that. So summary is that mobile to mobile, peer-to-peer connectivity is the PAN, distance is less. Then within the office, you're communicating with any system within the office, that is a LAN. Same you're doing over the Wi-Fi, which is called LAN. And within the one building, you're communicating, that is basically, or between the two different buildings within the same locations, you have a multiple branch within the same locations and communicating, that is basically called as a CAN. So next topic is called as a metropolitan area network. Now metropolitan area network is called the net. So what we discuss is, let's say example, this is a Dubai. This is Dubai. Okay. Now in Dubai, we have an office here one, and within a Dubai we have another office, and here we have an office. It's not in Abu Dhabi. Within a Dubai, okay, we have a 3 office. Is it clear? We connecting that office. Okay, within the Dubai we have a 3 office. We connecting that. That is basically called as a metropolitan area network, which connects site without long haul circuits. Or second use case is in Dubai we have a CCTV cameras. Within Dubai, not Abu Dhabi or other part of the city. Within Dubai, we have a CCTV cameras and all are basically connecting with the one panel. And through that panel, I can able to see the entire visibility about the city. So all these cameras are connected with one network. That is basically called as a MAN. Now what happened is, we're taking a same use case. Now in this use case, what happened is we have a second is called as a WAN, a country or globe. Now we have a UAE. Now you have a one branch in Dubai. You have one branch in Abu Dhabi. You have one branch in Ras Al Khaimah. And you have one branch in Sharjah. All are basically want to connect together to share the data and all that. And that is basically called as a WAN, wide area network. So with the help of internet connection, they can able to use that. But now they have an office in India. They have an office in Africa. So you are working with Emirates Airline and you want to track the flights which is going across the multiple cities or multiple countries. So for that, we need to have one network which is called as a GAN. Now, you might be thinking, Prav, WAN and GAN look like a same. See, WAN is a network connecting office or branch across the geographic region or country. Okay. But on the other side, when I say GAN, okay, when I say GAN is a global scale network connecting, and they're using a satellite or global internet infrastructure. Okay, like as I said, we have a Emirates airline system. They link the offices, airports, airplanes across all the countries. Is it clear? So they can able to track their Emirates flights. Okay, that something is there. So thin line difference is that the WAN like a national courier which deliver the package across cities within your country, and GAN is like an international courier service that ship package globally connecting to the whole world. And the last is basically called as a, like you seen the right now this the Tesla CEO, right? Okay, so he providing a satellite internet connections which you can use in the flights also. How they providing that? With the help of satellite. So when you travel across the globe and all that through the satellite, you can get access of internet from anywhere. Okay, so that is basically a live example of that. Now next is basically called as a SAN, storage area network. So storage network is like, it's not a network. It's like we have a multiple storages. Here we have a storages and each storage has a IP, and through that particular IP you can able to access storage. So that is basically called as a storage area network, which is used for data center rows, high speed block storage transfers and all that. Okay, so same like we have a computer with IP, same like we install a storage which store the files and everything. It is configured with the IP, and through that particular IP you can access the storage from anywhere. Okay, so it is just configured like a computer IP. It has their own channel, and through that channel you basically access those storages. You access through the IPs, and that is called as a SAN. What is topology. Now, when you're talking about topology is called as a layout of the network. Okay, it is called as a layout of network. Same like when you construct a house, right? So before constructing a house, what you do? You design the layout of the house, which give you visibility about where and what you need to place. The same like when you building a computer network, before that you need to design the layout of the network, and that is called as a topology. So we have a different type of topology. The first topology is called as a bus topology. Now bus topology is what? We have one cable and all systems are basically connect with that cable. It is your traditional computer network cable. So it is used to be called as a coaxial cable, which we discussed in the previous video, and all systems are connected with this particular cable. The problem is that if the cable is down, everything is down. So that is a one concern about this topology. That is called as a bus topology. Second is called as a ring topology. In ring topology, it is introduced in an IBM token ring network. In my next video, I'm going to discuss that token ring network, which is used by the IBM. So in this, what happened? We have a token. Token is moved in a clockwise and anti-clockwise. So if someone want to send the data, let's say example, we have a system A, we have a system B, we have a system C, and we have a system D. If A want to send data to C, A will attach the token, grab the token, attach the data to the token, and token go by the B to C. C will grab the token, copy the data and release the token. So that is called as a token ring. The problem is that if this is down, the token will not able to pass. If C is down, the token will not able to pass. So that is basically called as a ring topology. Okay, it is used in the IBM token ring concept. Next is basically called as a mesh topology. One of the secure topology is called as a mesh topology. We have a system A, which is directly connect with the system B. We have a system A, there is a direct cable connected with the C. We have a system A directly connected with the D. B is directly connect with the C. B is directly connect with the D. So if you add more and more system, it brings the scalability issue. So if you ask me, one of the most secure topology is mesh, because in computer networking security principle, we follow one very simple thing, is that make sure we should have very limited device between the two systems, because more device mean more chance we have to intercept the data. Next is called as a but one problem is that it's scalability issue, because more system you add, more challenge will be there. Then we have a star topology. Let me draw it again. One of the most popular topology is star topology. How? Let's say example, this is my switch. Then we have a system A. Then we have a system B, and then we have a system C, and then we have a system D. All four systems connect with the switch. If the B is down, it doesn't impact the network. But if the switch is down, it impacts the entire network. One more topology which is missing here is called as a tree topology. Tree topology. In that, what happened? We have a media, and from that media we connect one switch. We have a system here, and then we have a system A, then we have a system B, then we have a system C, we have a D. So all data is basically going through that only. So here we have a star also, here we have a bus also. When you combine, it is called as a tree topology. Okay, so topology is nothing, it is a layout of the network. Now next topic in this module we called as a media. Media is a mechanism by which we send the data, and we have a two type of media, wired media and wireless media. So under the wired media, we have a coaxial cable, twisted pair cable, fiber optic cable. It means there is a wire. So we have a system A and we have a system B. So there is a dedicated wire through which we transfer the data. So whether it's analog and digital. But wireless is basically not using a wire. We're using a wireless frequency by which we send the data. So data is more intercept in the case of wireless, because we don't know who intercepting. See, if anyone coming with the cable and connecting, I can see that. But in the Wi-Fi, okay, anyone can able to intercept the data. So data communication become biggest concern in the case of wireless. And in this module, we're going to discuss about the different type of media in details. So first, let's get started with the wired media. Okay, and the wired media, the first point we're going to discuss about is this one called as a coaxial cable. Do you remember your old when you're talking to TV? Okay, and TV channels will run. The backbone of the cable from which the channel, your TV you running, or the cable what you see, the channels what you see, it is basically using a coaxial cable. So coaxial cable actually used in your cable TV network. So now if you can see this picture, this part is actually the one which carry the frequency and carry the data. This is called as an inner conductor. Then this is basically called as a dielectrical insulator, okay, which maintaining a space. Then we have a outer conductor, a braid or foil serve as a ground shield. And then this is basically called as a PVC jackets. So coaxial cable is, so if the question talking about which is the most strongest, the answer is coaxial cable. It is difficult to break and all that. It's a very, very strong cable. But problem is that it generating lot of current attenuation, which lead to the data loss. So one of your traditional computer network, the cable that we use was the coaxial cable. Your TV network, when they broadcasting a channels to all the TVs, they using the coaxial cable only, the black cable that you can see in the house. Okay, so that something is there. Now here what happen is the signal propagate as electromagnetic waves between the inner conductor and shield prevent the external EMI. What is EMI? Electromagnetic interference, which can lead to the data loss. But yes, we have a higher chance of data loss in a coaxial cable because of current in nature. Second is basically called as a twisted pair cable. Twisted pair cable are structure and signal. We have a 2 and we have a 4 twisted pair cables, copper conductors. The twisted pair cables are providing a better functionality in terms of data loss, less data loss compared to the coaxial cable. And it offer two type of twisted pair cable, shield and unshield. Now here you can see this is called as a shield, and they are twisted. Why they are twisted? Because of the cable attenuation. Okay, so because of data, so data attenuation. What is data attenuation? This is called data attenuation. Attenuation mean the loss of data. So, remember when you want to protect yourself from your dad. Now let's say example, dad is coming with the belt. So you try to twist your body so that the impact should be less. Same like here, the cables are twisted together, so we have a less data loss. So this twisted is basically used to reduce the EMI and reduce the attenuation, which lead to the reduce of data loss. But we have a two type of cable, shield twisted, and there is a called as a shield. There's an extra shield is there which provide the extra protection. So which one is more expensive shield? Which one is difficult to install shield? Which one is difficult to bend a shield? Which one is cost effective? Which is called as a unshield twisted pair cable. Okay, so next is basically called as a fiber optic cable. We discuss about twisted pair, we discuss about coaxial cable. Now we're going to discuss about fiber optic. So if you talk about a cable which provide you the highest speed of data sending parameter, or the cable which is more immune to any EMI or data attenuations, the answer is basically fiber optic cable, because it uses light as a frequency to exchange the data. And light is considered as one of the fastest frequency to send the data. So today, if you see nowadays, Jio, Airtel in India, they're using a fiber optic cable, and because of the reason, the speed is basically high. So what has happened here is we have a system A and we have a system B. Now they have a fiber optic cable under which we have a glass tube. The light frequency goes through that particular tube. But problem is that if someone tried to tap this cable, the frequency is gone. That is why we say if you want to send sensitive data and you don't, and you're very confirm about if someone tried to tap the cable, the signal is lost, you're okay with that, then you will use fiber optic cable, because in fiber optic cable, it immune to any kind of EMI, it immune to data attenuation and provide the highest speed of the data transfer. Now fiber optic cable is two types, single mode and multi-mode. Single mode, we are having a single frequencies by which we send the data. Multi-mode, we are using a multi-frequency by which we send the data. Multi-mode basically carrying the, nowadays multi-mode is basically used to carry the data. So they basically transmit the electrical signal into light signals, and receiver convert the light back to electrical signals, and it is immune to EMI and offers extremely highly bandwidth functions. So far what we covered was more like a wired concept, And now we are going for the wireless. Now, one more important thing you need to understand here is in wired fiber optic cable single mode, we use in a campus, data center trunks and all that. In multi-mode, we are using metro, long haul carriers and all that. So that something is basically part of the wired. Now we're going to discuss about the wireless. So far we discussed about 3 type of wire. Now we're going to discuss about the wireless. And the first, which is a very common use everywhere, is radio wave. It occupies the lower frequency and the spectrum. Now what is spectrum here? It's a very good thing. What is spectrum? Spectrum refer to the range of electromagnetic frequencies over which signal can travel. I repeat again, spectrum is referred to the range. It is basically called as a range over which signal can travel. So think of it like a giant musical keyboard where each key is a different frequency. And just like a notes, different frequency behave differently and carry different tune of data. So when you're talking about radio wave, it offers 2 type of frequencies. One is called as a lower frequency and one is basically called as a higher frequency. It is only for knowledge. Lower frequency mean longer wavelength and higher frequency is basically called as a shorter wavelength. So when I say longer frequency, okay, it basically bend around all the obstacles and travel farther but carry less data. But on the case of higher frequencies, it pack more data but need a clear path and don't reach as far. So if you're looking for the bigger distance and all that, we go for the longer frequencies. And if you're looking for the higher frequency, it can carry short data. So now question is basically where we use this. You know, today the Wi-Fi that you use, the Bluetooth that you use, they all are example of the radio wave. That's why when you're connecting a Bluetooth headphones and all that, you move around your house and all that, different walls are there, right? From one distance to other distance, you can able to listen to the songs over the Bluetooth connection without any interruptions. That is the best example we have. Second thing is that there is one statement we are using is 3 kHz to the few gigahertz. Now what is the meaning of that? Let me explain. So what happened is, as I said, spectrums are the range of electromagnetic frequencies over which signal can travel. So lower frequency bend around the obstacles and higher frequency pack more data because we have a bigger frequencies, parameter frequency. Now question is, what is the frequency units? Okay, so you need to understand one thing. Spectrum is really like a long invisible highway. And this highway used to send all sort of wireless signals like your phone calls, Wi-Fi, and even signal from satellites. So if you take an example of the lower frequencies, is it clear? So it is just like the slow, steady truck. I repeat, slow, steady trucks, the trucks that you can see on the highway, right? So we have a big and slow trucks on the highway. They can go a really long way and even go around the obstacles like building, hills without much trouble. On the other side, we have a higher frequencies, which is a shorter videos, which pack more data. So these are like a sleek, fast sports cars, and they can carry massive amount of data very quickly, but they need a clear open road. So when we're talking about these frequencies, the frequencies are measured in a hertz, which is called a cycle per second. And to handle the huge range in the frequency, we have a 3 type of hertz. One is called kilohertz, 1000 hertz. One is called megahertz, and when we have a gigahertz. So these are basically called as a frequency range. Hope it is clear now. So the previous frequencies we're talking about, the radio waves mostly used within LAN and all that. But if you're connecting the multiple branches, you're sending data over the different locations. So we use a microwave, which sit higher up and roughly starting from 1 gigahertz to 100 gigahertz. Is it clear? And they require the line of sight between the antennas. So it means if I take an example, let me explain you with the example. So here we have a office 1 and here we have a office 2. So both have a dish and they have a line of sight by which we can send the data. In the radio wave, what happen is we have a frequency range like that. Anyone can use any of the frequency and send the data, but here we have a line of sight. Now, one thing you need to understand here is we have a different type of microwave setup. One is called point-to-point link. It means we have a 2 rooftop dishes like this way. They are connecting. Second is called as a cellular black hole. Airtel providers, internet providers, they're basically using that. They have this kind of a towers by which that send the signals and all that. And today the Starlink, if you see the Elon Musk company who providing a Wi-Fi across the world, okay, how you getting a Wi-Fi in your flights, that is basically a new thing called satellite uplinks. So they're using a geo and LEO satellites. These satellites are basically through which they basically provide the internet connections. Okay, so that is basically the new modern architecture we have that you can see in the future. I repeat, this is the example of geo and LEO satellite, which is on the satellites on the Earth orbits, and that basically provide the wireless frequencies. So geo and LEO are called as a low Earth orbit and geostationary Earth orbit, and they are close to the Earth. So this Tesla and Starlink and all that, they're planning to introduce Wi-Fi in India through that only. So in that case, what happened? The satellites are there on the Earth. So this is the Earth and this is the satellite. From there, they're basically providing signals to the Earth, and by which you can able to access the Wi-Fi from anywhere. So one of the powerful frequency range we can see in the satellite uplinks. That is called as a microwave. Next is called as a infrared. One of the shortest frequencies offered by infrared. You notice when you're sending data from one phone to other phone, we need to keep a phone very close together. That is called as a infrared, which is a line of sight. So they have a two type of example of infrared. One is called IRDA port, which is early laptop exchange small files by pointing them at each other over the few meters. Line of sight is required. And today, second example is remote controls, which is using for TVs and all that, which can be used for the things. So if you ask me, the radio wave used in LAN, the microwave used in WAN, and infrared is smaller part of the LAN, which is very close to the communication. Now the question is, how you select, I want to go for fiber, I want to go for twisted, I want to go for coaxial, or I want to go for wireless frequency. What is the parameter based on which you select the media? The first criteria is bandwidth. Same like, when you buy a bike, what is the first thing you ask? Mileage and speed. Same like when you buy a media, you need to understand what is the capacity of the media to carry the speed. So bandwidth is the first thing. Second is throughput, actual data received or achieved. That is called as a throughput. We have to look for the media which have a limited latencies, because more latency lead to the more delay. And next is called as a bandwidth delay products, amount of data in a flight. Okay, so bandwidth and latency determine the needed buffer size. And last is called as a jitter. Jitter is basically variations in a packet delays. It is, you can see in the voice and videos where there's a latencies and all that. So when you're looking for any kind of a media, you look for this. Bandwidth is a maximum raw data. Throughput is the actual data it sent. More. So let's say example, you want to send more heavy data for a longer distance, then you will use fiber optic cable, because fiber optic cable definitely offer the higher bandwidth with the throughput. Okay, then latency. Latency is basically time for a one bit to travel end to end. So we look for the maximum thing. So we'll have a limited impact. Again, fiber optic is best for that. Then bandwidth delay products, and then jitter. Jitter is basically variations. We have to see which media will have a less variations, because more variation lead to the performance will be less. So these are basically the parameter we have that we consider when you select the media. The question is now how we are sending a data from one system to the system. So we have a three type of casting. One is called unicast. Unicast is basically one-to-one. Example, we have a system A and he's directly sending to B. The best example is switch. In switch, what happens? System A directly sending to the destination port, which is called one-to-one. Okay, so you use a single path per recipient and fine for one-to-one, but costly to maintain, because now if you're setting up the dedicated connection between the multiple system point to point, it will be more expensive. So that is basically called as a one-to-one. One more example is like we have a system A and I want to manage this firewall. So we have a point-to-point connection direct, and through which he will manage a firewall. That is also one example we have. Or you access a particular web page of a particular server that is actually provided for the particular system, which is basically called point to point. It means the data is going from A to the B. It will not go to everyone. So that is basically called as a unicast. Second is basically called as a broadcast. Broadcast means one to all. So we have a system A. He send the data, but it will go to the A. It will go to B, go to C and D. Is it clear? So one sender, all the host. The best example was the hub. You send to hub, hub will broadcast to all the ports. Problem is that when you start sending to all, it become more overwhelming and every device must process or drop every packet frame. So that is something is concern we have. And third is basically called multicast. Multicast is called one to many, not to all. So let's say example, this is my TV1, TV2, TV3. This is the camera who capturing the live match. And then from there, it only going to these three systems. So these three systems producing the match to everyone. It's not going to all, but it going to three only computers. So that is basically called as a multicast. So today we are using this in a cable TV networks and all that. We are using this in a, not cable TV network. It is used in a broadcasting match and all that. We call it as a broadcast, but we have a limited device to which you want to telecast that match. So that is called as a multicast. Multicast mean one to many, not all. Okay, so let's say example, I'm taking a CISSP students of 40. So that is a multicast. I'm going LinkedIn live, that is a broadcast. I'm teaching one-to-one, that is a unicast. So multicast required explicit group management and it making safer than broadcast for large or segmented network. Okay, so next point is called as a next device is called as a NIC, network interface card. Now it is, see, you have a laptop. Okay, in that laptop, you can see this section, a card by which the media is connect with the switch, a media connect with the hub, or media connect with the router. So the device which is installed on your motherboard and by which your computer or laptop connect with the network, that is called as a NIC card. Nowadays in some laptops, they don't have this card because your motherboard has an inbuilt wireless access point, wireless device, wireless NIC, which is used to connect with the Wi-Fi. But you can see the NIC card in your laptop, you know, this portion you can see, okay, by which you can use a cable, and by that cable you can connect with your switch or with the hub. Next is called as a bridge. The bridge is a device which is used to connect to different topology. So today, if you take example, your access point also have a feature of bridge. How? The Wi-Fi that you use in the house, okay, it has a Ethernet port, this kind of a port they have, so that a cable which is coming from a landline can connect, okay, or you can use that Ethernet port to connect with your wired switch, and then that wired switch is basically connect with the wired computers. Now we also have a Wi-Fi users. So now this Wi-Fi user sending a signal to this, from there this wired network port can send the data to this. So by this way, my wired system can communicate with my wireless systems. Okay, and that is a best example of using access point as a bridge. So ultimate goal of the bridge is used to link two different LAN segments. It here in this case we use Wi-Fi and wired. Okay, then the next device we called as a switch. Now switch is called as an intelligent device. Switch is actually two type. One is called as a manageable switch, manageable switch, and one is called as a unmanageable. So what is switch? So switch does the unicasting. In my next slide, I'm going to cover that. So we have a system A, we have a system B, and we have a system C. So what we learned in the past, in the case of hub, if A want to send data to C, according to hub, it will send to B also. But in the case of switch, if A want to send data to C only, we send the data to switch. Switch will check what is the destination MAC address, because physical address of a LAN card is called as a MAC address, and they will check in the memory table. They have a memory table which is called as a CAM table. Okay, we called as a CAM table. So CAM table basically store the information about the list of MAC. So according to that CAM table, it basically send the request to the particular port only. So what is CAM? CAM stand for content addressable memory. It's a special memory used in the network switch to store and look up the MAC address quickly. So you can say like that CAM table is nothing. It is just like your contact list. Okay. So your network switch used to know where to send the data. So now the use case is when A sending a data, it attached the MAC address of the C. So it's sent to the port. It's sent to the switch. Switch will check into CAM table that this MAC address is basically on which port. It on port number C. So it send the data directly to the C. This is how the unicasting works. So this is how it provides the security. Is it clear? So the difference in hub and switch: hub broadcast the data, switch unicast the data. First time when you open the switch, when you start the switch, it send the broadcast request to all the ports. You see the light is bling in all the ports. Why? Because he want to learn how many systems are connected on each port, and then fetch the memory address, MAC address, and store in the CAM table. So next time when A sending data to C, according to MAC address only, it send the data. Okay, and one more important information is that the CAM table entries can expire if the device goes quiet for 5 minutes. That's why the entry in the CAM table is dynamic in nature. Is it clear? So now this is the feature I talk about, the unmanageable. But in the manageable switch, what happen is we have option to map that. Okay, we have a switch here. We have a port 1. We have a system B. We have a system C. FF is the MAC address of system A. AB is the MAC address of system B, and CC is the MAC address is a physical address. You can't change it. Okay, it's a manufacturer address. So first time when it pick, you can make it static. So now if any new system want to connect with this port, the link will not up, because we manually map that this MAC address always connect on the port 1, on 2 and 3. This is only possible in the manageable switch. Second thing is that in a manageable switch, we have option that, okay, we can communicate A and B only. Even all three are part of a same network, but logical segmentation, all we can create in the switch. So switch is a device which used to unicast data. Access point we already discussed. It's the same thing what we have covered. Okay. Okay, so we have a next topic which is called as an address. Address is very important stuff we have. So when you're talking about address in computer network, we have a two type of address. One is called as a logical address, and one is called as a physical address. Physical address is a fixed address we can't change. It is an address comes with the manufacturer. And logical address in our term is called as a IP address, which we can change easily. So first we're going to cover the IP address, which is a very important part of this requirement. Now what is IP address? See, like I want to call my friend. So he has one phone number. He has one mobile number. So I can dial his number. Same like I want to call my wife. She has one mobile number. I call that number, and by that we set up the link. Same like when one computer A want to communicate with another computer, it need to be communicate on a particular number. Every computer need to have that number. Then only I can able to communicate. And that number which we use in the network, that is called as IP address. Now IP address, IP has a two version, version 4 and version 6. First we covering the version 4. Okay. So when you talk about version 4, it has a 32-bit written as a 4 decimal octet, which is called as a 192.168.1.10 as a sample. And it is a common protocol we have. So let's first understand. Let's say example, when I say 192.168, okay, .1.10. Okay. So each octet, okay, so we use one term which is called as a octet. Octet, O-C-T-E-T, octet. What is octet? Octet is basically called as a group of 8-bit. Group of 8-bit. Okay, and which is also called as a 8-bit equal to 1 byte. Okay, so in IP version 4, we have a 4 octet. And that is why it's called as 8 into 4, which is called as a 32-bit octet. And each octet is written in a decimal. Okay, that's why we say we have a 32 bits, which is written as a 4 decimal octets. Okay, and IP version 4 provide two type of IP. One is called as a public IP, and one is called as a private IP. A public IP is IP by which you can able to communicate over the internet. And private IP is the IP which is used to communicate within the LAN. It is same like This is your hotel. So we have a room 1, room 2, room 3, room 4, room 5. So you check in into the room 1, your friend check in into room 2. Now you want to call your friend. So they have an extension number like 22. So by this you can able to call the room number 2. But if you want to call your wife, which is she is in your house, you need to use the public number which has some charge. Nowadays in India, incoming call, outgoing call, both are free, but you're paying some money for that, right? So if you want to call your wife, if you want to call some public numbers and all that, there will be some charge need to be there, right? So the number you're communicating within the rooms, that is your private IP. And the the number which you're using to communicate outside the hotel to any person on this earth, you is using a public IP. So same like you are actually paying a money for public IP. So here the IP version 4 we have. In a further discussion, we discuss that range also if time permit. So when we're talking about IP version 4, okay, now we have another version called IP version 6. Now IP version 6 are written in a 8 groups. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So total 8 groups we have. So IP version 6 are written in 8 group, which is called as a hextet, and it is a combination of alpha number. Okay, hexet, which is also called as a 4 hexadecimal, 4 hexadecimal digit, which is separated by the colons, and each group represent the 16 bits. Okay, each group represents the 16 bit, and the full IP version 6 is called as 16 equal to 128 bit. Okay, so that's something you can check that. So now the question is why we introduce IP version 6. Imagine when you're talking about IP version 4, it only have a 32 bit. Okay, and it was like, only having a 4-digit number. So it is basically running out of space because there's a lot of people using a lot of computers. So IPv6 is giving every house a 16-digit number. So range is big. So when the range is big, we have a more chance of creating a unique number. And with the IPv6, you can curve your network into neat, consistent chunks, and almost automatically you can assign without any blocks and all that. That is why IPv6 nowadays creating a huge impact in the cloud machines. Is it clear? So now when you're talking about IP version 4, as I said, we have a 2 type of IP, public IP. Actually, you're paying money for the public IP, which is assigned by your ISP or cloud provider. And then we have a private IP, which you use within your organization or in your house. Let's say example, we have a Airtel. Okay, he is the ISP. He providing you one connection. So when he say he providing connection, you actually paying for one public IP. And the public IP is basically 11.0.0.1, which is configured on your router. You're paying for one IP. But within the router, we have one feature which is called NATing. In my next video, I'm going to cover that. And that NATing, here we have a private IP. So the role of the NAT is to translate your private IP to public IP and public IP to private. So we're actually paying for one public IP. And based on that, my multiple systems which is in my house can use it to access the internet. Same now, like when you bring the ISP connection to your house, you can access the internet. Your family member can access the internet. Your team members can access the internet. So the IP which is assigned to your systems are the private IP. So this is the range of private IP. Anything which is not in the range are considered as a public IP. But can I add any public IP in my network card? Yes, I can add. But problem is that it cannot be routable over the internet. You're getting a point. You can add 11.0.0.1 in NIC, but you need to understand one thing that should be registered in ISP. Then only you can use that IP to access the Google page. So private IP is the IP which is used inside your local network to communicate within system. So anything which is not in this range are the public IPs. Okay. Now the next address is called as a MAC address. It is a physical address which is attached to your NIC. See, you go to network setting, change the IP. You can change that. Okay, but you cannot change the MAC address. MAC address is a 48-bit address which is integrated in your NIC. So you can see this is the one we have, MAC address, which is a combination alphanumeric. Now, if I take an example of this one, okay, so these three things. So first 3 block, this one are called as a vendor ID. Vendor ID. Example, we have a Realtek and we have a high tech and all that. So they are the vendors who provide you Netgear and all that. They assign one ID to that. They basically tell you who built this network card. And the last three are basically called as specific card, which is a subscriber number, which is called as a device ID. So when you purchase a NIC, when you check the MAC address by IP config and all that, you can see this address. So first 3 bit is basically the vendor ID, like Netgear and all that. And the last 3 bit are the device ID. It is more like a, manufacturing code is the first 3 and the last 3 is called as a subscriber number. Now question is why it's split this way. The first 3 pairs are assigned by the IEEE, Institute of Electrical and Electric Engineer, IEEE, okay, to the manufacturer, so that no other makers will share the same prefix. And the last 3 are the device serials, which is chosen by the manufacturer. So every card they make has its own unique ending. That's the reason. So let's move to the next part, which is called as a OSI model. OSI model is a very interesting thing, and we're going to deep dive into OSI model because it is a part of their job interviews. And if you are into network security and all that, you need to have a visibility about how the OSI works. Okay, so next topic is called as a protocol. See, we understood about IP address, we understood about the MAC address, but there is a set of rules computer has to follow. And through that only 2 systems can communicate with each other. I'll give an example, okay? So protocol is nothing, protocol is called as set of rule. Now, if you take an example of this video, I'm speaking in English. English is a one language that we follow. We follow one set of rule of English. And that is the reason everyone can able to understand. If I'm speaking in the Malayalam community, then I have to speak in Malayalam. Malayalam is a protocol there because destination also understand Malayalam. If I'm speaking in a North, in a Hindi and all that, they also understand Hindi. So we are using some rules, we're using some parameters, and by which we are explaining the topics. So we agree both sides that we'll use English as a communication parameter to communicate in 2 systems. So same like when we have a system A and we have a system B. When they communicate to other system, okay, they communicate through a particular port. Okay, port is the address, like we have an IP address, so by which we can locate a system B. But in the system B, I want to speak to a particular application. So that application has a port number. Like example, like I'm trying to connect with the website. So this is the website. Website IP is 1.1.1. So I can able to identify the location. But in the website, I want to understand the HTTP parameter. So I want to communicate either on port number 80 or 443. Okay, so every application, whatever is working, they listen the data from a particular port number. Like I'm connecting a telnet on the target system. So I need to know the IP of the system that is used to locate the host. But on that host, I want to connect to a particular application, and that application has a particular port. So protocol is a set of rules and standards that define how device communicate, exchange data over the network. And it ensure the device, even from a different manufacturer or running different software, can understand and interact with each other. In simple term, protocol is like a language for a computer to talk to each other. Now without IP, can you communicate? No. Without adding a preferred DNS, can you able to translate the name? So it is a set of rule. It is a set of rule. Like you need to add the preferred DNS, then only you can able to translate. You need to type HTTPS, the URL of the website, then only you can able to access the page if on the destination the port number 80 or 443 is open. And that is the reason it's very important. So when we're talking about protocols and the ports, we have, so you can see major protocols are work on the transport layer. So we have a TCP and UDP. TCP is the connection oriented and UDP is the connectionless. Same like, when you speaking to your friends, you start with hi, hello, how are you? And it can go up to 1 hour. That's a TCP. Same like here in TCP, what happened is we have a system A. So we have a system A and we have a system B. Before they send the data, they send the SYN packet. SYN is just like, hello, I'm audible. They said, yes, you're audible. So he also sent the SYNAC. And then he sent the acknowledgement. This is called three-way handshake. But in the case of UDP, this is called TCP. In the case of UDP, you just simply sending a data without considering any response from there. It is same like, speaking to your friend, you start with hi, hello, how are you? But when you go home and your partner say, where is a paneer, where is a milk, where is a curd, simply. So when you're having a conversation between the partners, when you're having a conversation with the partner, it's like a UDP, prone to error. It starts with no logic and finish at no logic. So port address operate at the transport layer. Okay, port address protocol works on all the 7 layers of OSI, but all the 6 layers, which is like application, presentation, session, transport, network, data link. But when we're talking about physical layer, we don't have a protocols. So purpose of the but port addressing is done on the transport layer. So what is transport layer of OSI? We're going to cover in my following slides. Okay. So when you're talking about the port address, it targets a specific application or device, and usage is only for the service identification. As I said, like I am a system A and I'm communicating with the web server. Web server. So I have to send the request. I'm using HTTP. So HTTP only listen on port number 80. No, I want to take a remote connect. That is only possible if I establish a connection on 22 or 21. Example, I'm giving FTP and all that. So every service listen through a particular port number. That port addressing done on the transport layer. On the other side, IP address, IP work on the layer 3 network layer, target the device itself on the network, and it is for a device or identify the host in the network. So in layman term, if I say I'm connecting on 192.168.1.1, it identifies device on a LAN. But 192.168.1.1.80 indicate HTTP service running on that device. Okay, that's the important part. Now, another important thing when you're talking about port address, port has a classifications. Okay, port is been classified by ICANN. So ICANN is the authority who classify the port. So we have a 3 range of ports, 0 to 1023, which is known by Microsoft also, Linux also, Apple also. Example, HTTP, right? It can be used by Apple also and Microsoft also. So it's a well-known port. Okay, reserved for the address by INA. So HTTP, HTTPS, FTP, DNS, it's used by Mac, Apple and all that. It's a fixed assigned for the standard protocol, not a vendor centric. Then what happened? Microsoft has registered some ports. Linux has registered some port for the services. So it is reserved for a specific application, but not as a strictly standardized. So Microsoft has reserved some ports for the SQL. Apple has reserved some ports. So that is basically come from this range, which is called 102.4 to 491.51. And then we have a 491.52 to 65,535. That's called dynamic port. Anyone can use that. It is temporarily assigned for the outbound connection or inbound connection. Because when any client initiating connection, suppose we have a system A and we have a system B, and they are connecting with the server, which is called web server. They're connecting on 443. So both are connecting on 443, but how the web server identify who connecting? So here the source will be any random port, which is like a 109000. Here also 10, or let's say example 49153, 49154. So source port is this, but destination port is same. So by identifying which source is sending this packet, we are using this dynamic port. So dynamic node always used by source for sending a data, which is randomly assigned for outbound connections like web browsing, video streaming and all that. So as a SOC analyst, you should know this, and that's why it is asked in the interview also. Okay. Now we're going to discuss some of the protocols which is used for remote management. What is remote management like? I'm a SOC analyst. I want to remotely connect to SIM. So we have to connect to the SIM through a particular port. Let's say example, we have a system A. Okay, and this is my system B. So today, if any friend has reached out to you and said, I want to troubleshoot my system. I want to troubleshoot, like, I'm facing some issues. Can you take a remote access of my phone? So we use this tool now, VNCs or any desk and all that, right? And through that, you can take a graphical access of the B system, but it was not like that 20 years back. We used to have a DOS based systems. So we basically take a remote connection of the command prompt. Like today we see a CMD command prompt. So we take the remote command prompt access and then we send something via command. Problem is that anyone can able to intercept that. But Telnet was used for the remote management. So we have other protocols also which is used for remote management. Let's take example, I'm a firewall administrator. Today I'm working from home, but I want to connect to the firewall interface. So I will use this SSH and all that to remotely manage the firewall. So that's why we have a different type of remote management protocols that we need to understand. Okay, so the first protocol that we're talking about SSH, as I said, Telnet send the data in a plain text. So we were looking for an alternative for remote command that we can use to send in a secure manner. And one of the popular is called as a SSH. So we have a system A, we have a server, which can be firewalls, anything, or server. And I will try to establish a connection on port number 22. And through that, I will send the data. And by SSH, it offer you multiple things. It offer you encryption, compression, authentication, accountability, integrity, and all that. So today, if you're talking about remotely managing the servers, remotely executing any kind of a commands on the remote firewall, remote server, we use SSH. And this is the interview question. What is the, they will give you scenarios which say, okay, you are working from home and you want to connect to the firewall. What kind of a protocol you use for remote management, remote command. I repeat, remote command. So we use SSH. It's a secure protocol for remotely managing a server and device. So use case like accessing Linux system for log analysis, configure device remotely, and security feature is encrypt communication in public private. Second is RDP. If you're looking for graphical access remotely, you want to take a graphical access. Then for Windows system, we have RDP protocol. Remotely, I want to take an access of the system, investigate the incidents, monitoring the Windows server, support encryption, MFA. But if you're looking for vendor neutral, which can be work in Microsoft, also Linux, also we use VNC, a graphical remote access, which can be for GUI requirement. Basic encryption is there, and it can be enhanced with the help of SSH. Telnet, as I said, it sends the data in a plain text. We also have one more protocol called SNMP. SNMP is used for remote monitoring. Like I want to monitor my systems remotely. I want to monitor the logs remotely. I want to monitor the device remotely. So we use one protocol called SNMP. It is used for monitoring and managing network devices. Okay. So we can gather logs or metrics for the network devices, and current version is SNMP version 3, which is more secure. Then if you're looking for web-based interface access, like I want to connect with SIM over the web, then we use HTTPS. I want to connect with a remote server over the web by HTTPS, so I will use HTTPS. So it's a protocol for access management dashboard for device or application. Like if you want to access remotely VMware administrator access and all that, you know, today when you access the AWS consoles and all that, what you do, you go to browser and type https server.com or aws.com. So with the help of HTTPS, you can have a web-based access. HTTP is also there, but HTTP send the data in a plain text, but HTTPS send the data in encrypted manner. So today, a SOC analyst using to remotely accessing the firewall web page, SIM dashboards, and cloud management tool. So it offers the TLS encryption, which is use the AES for the encryption. We also have one more thing which is nowadays are using is called PowerShell remoting. It is a protocol for managing Windows system remotely via PowerShell. You can say alternate of Telnet and alternate of SSH. And these are basically used for automating your incident response task. And more important, it is used for fetching the logs from endpoint. Okay, then we have a NetFlow. It is again a protocol for analyzing the remote traffic, network traffic. It is used for monitoring the anomalies for data exfiltration, and it is a secure implementation depending upon the collector. And then we have a RPC. See, RPC is used for execute the process. If RPC service are disabled, then it is difficult for you to execute the function. So RPC is very important. It is a protocol for executing process on a remote systems. And it is exclusively used for managing Windows services, and it can be secure using a firewall and network restrictions. I don't want someone to set up a connection with the remote server over the RPC. So these are protocols we are using for a remote management. Now we're going to discuss about some common network protocol, which is called as we discussed that the TCP and UDP. TCP is a three-way handshake we set up and then we send the data. In UDP, we don't follow any three-way handshake. We simply send the data over the network. So that's called TCP and UDP. So if you open YouTube and all that, okay, so first time when you open the YouTube page, it is happening on TCP. But when you start playing videos on YouTube and all that, it is happening on UDP. So why it is important for a SOC analyst to know TCP and UDP? Because we have a SYN flood attack where we monitor the three-way handshake of SYN and we analyze the packet flow for anomalies. There we need to intercept the TCP header and all that. And why we need to know UDP? Because when we're having a DOS or DDoS attacks, we'll discuss in later stage. We need to identify how the UDP packets are generated, and that is the reason it is very important for the SOC analyst to know how it works. Hope it is clear to everyone. So these are the two communication protocols we have, and all the protocols come under this category only. You know, this is the two major category, and under which we have a subcategory. So DNS can be UDP, TCP. So TCP, UDP is just like a family. We don't have a TCP as a protocol. TCP is a protocol representation. Okay, so DNS is a UDP, it work on TCP also, HTTP work on TCP. So TCP UDP is a functionality that we are using, and through that we're doing a communication. Okay, that is how it works. So now we move to the next part, which is called as a network management protocol. So when it comes to network management, network troubleshooting, as a SOC analyst, definitely you're going to encounter these protocol ICMP, SNMP, and ARP protocol. So first we're going to discuss about the ICMP, Internet Control Messaging Protocol. So we have a system A and we have a system B. So A want to check whether system B is available. So we use the command called ping. You know what is the full form of ping? Ping stands for packet intranet grapher. So it is a protocol by which you can able to do the ping connectivity. So what I did here is I type ping space IP address and I send the ICMP echo request. I send ICMP echo request to the target system. If port is up, if system is up, it will give me the echo reply. So ICMP is a protocol which I'm using for investigating a network issues. Tomorrow I'm trying to connect the website. I'm unable to load the page. So I will use ping space IP address and check the connectivity. If I'm getting request timeout, it means the system is up or network is down, something is there. So ICMP is used for remote troubleshooting. So it is used for diagnostic purpose like ping and traceroute. Ping is basically check the connectivity, traceroute get to know where the packet get dropped. Okay. So why it is important for the SOC people? Because there's a lot of DOS attack happen through the ICMP. Multiple packets will be sent. So we have to investigate from where it is coming, and ICMP works on the layer 3 of the OSI model. Next is called as a SNMP. In my previous diagram, in previous section, we discussed about SNMP. Let me explain you what is that. Simple Network Management Protocol. It is a protocol which is used for monitoring, manage and configure devices on a network. So if you take example today, any monitoring software. So let's say example, this is my server. And I have some clients here, or it can be server. Okay, so in this case, we called as two things, SNMP manager and SNMP agents. SNMP manager or SNMP agents. So we have two important thing here. Exactly. So SNMP manager and SMP agent. So that's something we need to understand. So when we're talking about the requirement of SNMP agent and SNMP server, so server is basically connecting with the systems. That is how it works. Yeah. So that is how it works. And according to that, so clients are basically sending the information to the server here. So agents, okay, are running here and they're sending information to server. That is how we have. So now what happened is when you're talking about SNMP manager, it is basically like a centralized system that query and receive information from network device, and agents are running on the network device like router, switch that respond to the changes. Now server maintain one information called as a MIB, management information base, a database structure information about device resource and configuration, and every device has a OID, object identifier. It is just for reference. Okay. So how it works is SNMP agent is installed and running on the device here. Okay. And SNMP manager here. So they send the information to server. SNMP manager basically monitor the things and remotely they troubleshoot the things. So agents can basically, or the server can remotely able to manage all things, monitor everything and check everything. So it has a 3 version, SNMP version 1, SNMP version 2, SNMP version 3. So if you take an example from an interview perspective, remember SNMP version 3 is more secure because it provides the authentication, encryption and message integrity. Along with that, SNMP version 3 is configured on the private strings. So we have a 2 type of strings in SNMP, public and private. Public is like read only. Anyone can connect with your SNMP port number 161, 162, and you can able to extract how many services are running, what are the users we have, which is a concern. So we need to shift to the private string. So private string is basically mean read and write. You need to have authentication, then only you can able to connect. So today when we running any kind of a monitoring tool and remotely want to monitor any device, we have to enable the SNMP services, which work on the port number 161 and 162. Okay, so next is called as a ARP. ARP is a protocol which translate IP to MAC and MAC to IP. And today it is used for the remote management from the sending data traffic. So let's say example, we have a system A, and this is my switch, and this is my system B. Let's say example, here we have a router. So B configure, A configure, B configure with the IP called 10.0.0.1, and B MAC address is 9B at 7. A IP address is 10.0.0.2. His MAC address is 8B at 7. And router IP address is 10.0.0.3 and MAC address is 9B76. So A maintain the ARP table. This is how the ARP table look like, in which we maintain the neighbor IP and MAC address information. So 10.0.0.1 and MAC address is 9B at 7. 10.0.0.2, the MAC address is 9B at 6. So when A want to send the data to router, because the gateway for him is the router only, so they will say 1.10.03 is basically mapped to which MAC address, 9B at 6. So they attach the 9B at 6, and through that it send the information to switch. Switch work on the unicasting, they will check this MAC address 9B at 6 on which particular port, and on that particular port we send the data. So ARP works on the layer 2. It resolve IP address to MAC in a local network, and it is also become an attack target for the people. So these are the protocol we have, but we also have some kind of a you can say web application protocols that you also need to know. Example, HTTP, HTTPS. Whenever you're trying to connect with any web server, or you want to connect over the web, so use HTTP or HTTPS. DNS is a protocol which is used to translate name to IP, because it is difficult for you to remember the IP address of any server. So here we have a DNS. Here we have a DNS, and this is my web server. Web server IP is 1.1.1.1. So in the DNS, we maintain the record that if anyone requesting for kk.com, it mapped to 1.1.1.1. So now a user in preferred DNS, he give the IP of the preferred DNS IP. So DNS IP is 2.1.1.1. So he had 2.1.1.1. So then he typed kk.com. The request goes to DNS. DNS will check into records. kk.com is mapped to which IP, and then it provide that IP 1.1.1, and through that he connect with the respective web server. That's a live example of DNS. DNS is service which translate name to IP and IP to name. So today, as a SOC analyst, you should know DNS and all that, because 90% of attack they're targeting a DNS, because by manipulating a DNS, we're redirecting a user traffic to some other websites. You can understand DNS is a name translation, right? It is just like, you have a phone. Now in phone, you have saved your girlfriend number or boyfriend number with same name. Now someone hack into your phone and change the name. So when you try to type the name, it translates to someone else's number. You're getting a point. So that is what today DNS security is the most important thing. Then over the web, you want to access the file server. Over the web, you want to access the file window. We use FTP. FTP is a protocol that we use for that reason. Okay, 2021 is the port we have, which we use. FTP defaults in the data in a plain text. So we are using FTPS or SFTP. FTPS over the SSL. SFTP is on port number 22. So when you're sending any kind of email by email server, we use one protocol called SMTP. But when you're receiving an email, you use the POP3. SSH we already discussed, which is used for the function. So these are some of the web application protocol, and as a SOC analyst, you should know, because sometimes what happen, you have to investigate the email server logs. So you should know, okay, some mails are coming, so SMTP is involved. Sorry, mails are sending. So SMTP is a protocol. It is used to sending an email outside, and POP3 is used for recovering. So whenever we're receiving any kind of phishing emails and all that, we have to investigate POP3 logs. Understood? And when anyone sending data outside, or any attacker remotely connecting to server, mail server, and trying to send the data, we're investigating SMTP traffics. So it's very important that you have to understand how SMTP POP3 works. Then we also have another important protocols, that is, as a SOC analyst, you should know SMB, very, very important. Server message block. So if SMB service is disabled, you cannot able to share the files. So SMB used for sharing a file and printer in window environment. It is just like you go to library and they have a entire panel where the files are located. So SMB is like that only. Server, message, block. It's inventory where the services are there. So if SMB services are disabled, you cannot able to send the file. And as a SOC analyst, you need to investigate the SMB logs, because when any attacker access to your internal network, he do the movement from one system to other system. So we have to investigate the SMB traffics. So as a administrator, as a SOC analyst, you should know how SMB works. Then RDP, we already discussed, remote desktop protocol. So you have to also check for the RDP ports, because hackers, when they hack into the internal networks, they actually hack by the RDP ports and all that. So you have to investigate any kind of an attempt, brute force attempt has been done on the RDP port 443 or something else, or detect the suspicious remote connections. So that something is part of the requirement. Okay, so we're going to discuss about now network connecting and troubleshooting protocols that you're going to use, or command utility that you're going to use when you are in L1 positions. Like ping is testing the connectivity to specific IP and host name. That's something we are using. The second one is called as a trace set and trace route. Whenever you want to understand the packet drops, you type trace set space the destination IP address. You will get to know where the packet get drops and all that. So we are using this to display the path packet take to reach the destination. The next one is called as a NS lookup. So NS lookup is a tool utility by which we can able to resolve the DNS name to IP. You open the NS lookup in Windows Linux, enter the domain name. If it convert into IP, it means it is working effectively. Then we're using dig. Dig is just like a NS lookup. We perform the detailed DNS query better than NS lookup. Then we have a telnet. Telnet is used for remote commands, but we don't use today because it sends the data in a plain text. So we use the alternate of telnet, which is called as a SSH. Then we also have a curl, curl, which basically tests the connectivities, tests the HTTPS connectivity and retrieve the content from URL. We are using this when we're doing a malware investigations and when we're doing OS fingerprintings and OSINT. Then we have a wget is a utility. We download the files or content from the specific URL. So we use a wget. So there's again a utility in the Linux and Windows. So these are the network connectivity and troubleshooting commands we are using. Otherwise, we also have assist internals window utilities, which is also used for the same thing. After understanding the overall protocol classifications and all that, we are jumping into the routing and routed protocols. So routing protocol are the one which creating a route. Routing protocol is the one which create a route, and routed protocol is the one which carry the data on the route. Okay, so when we say router, this is the router we have. Okay, so we have a router 1, we have a router 2, and we have a router 3. Router is a device which is used to communicate between the two different network. Okay, so they have IP like 1.1.1.1, 1.1.2, 2.1.1, 2.1.2. So these are the IPs we have. So if data need to be sent from one network to another network, so let's say example for router 1, he want to send data to router 2. For him, the router 2 is router 3, and router 2 is basically the gateway. So manually we create a route. Manually we create a route in the router, and that routing is called as a static routing. There's no protocol is working here. So manually we need to configure the route on the router 1. We need to dictate them what is the destination, what is a mask, what is a gateway. So manually we need to define the things. It is same like each driver has a paper map with the fixed route. If road gets close, they get stuck because map does not change. So that is called as a static routing, which is simple and used for the smaller network. But when you're working on the big networks and all that, there we basically use the second one, which is called as a dynamic routing protocols, where we're using a routing protocol to extend the route. So we have a router 1 and we have a router 2. So here what happened, we don't manually create a route. So there is a protocol is configure this side, here we configure that side. So they broadcast their route itself. So automatically it adjusts. It is same like you when you're using Google Map, it automatically based on a current live traffic provide you the right location. So manually you don't define anything. So router automatically exchange the information to build and maintain the routing table. So routed protocols like IP, which deliver your application data, and routing protocols ensure your IP packet find the best loop-free path. Even if the link goes down or topology change, we can able to change the things. So we have a different type of routing protocols. So we have a RIP, we have a OSPF, we have a EIGRP, we have a ISIS, and we have a BGP. We have other protocols also, but in this we're talking about these basics only. So if you take example of RIP, routing information protocol, it's a very old, simple, use the hop count. So if you're looking for the small network, we use that. Now overall routing protocols are categorized into two parts. One is called as a distance vector, and one is basically called as a link state. I repeat again, one is called as a distance vector and one is called as a link state. So please understand this carefully. So in the distance vector, what happen is we share the entire route with the neighbor router. So we have a router 1, we have a router 2, we have a router 3. So in the case of distance vector, we actually share the entire routing information with the router 1 and router 2. Is it clear? So it shares the entire routing table with the neighbor on a periodic basis. So how it happens is, like example, in this case, each driver will basically shoot out, hey guys, this is the new list of the IPs are there. There's a new list of network data is there. So please find the updated information. So on regular basis, it basically update the information. And that is basically called as a distance vector routing protocol. But in the case of link state routing protocol, we don't share the entire information. We only share the link state information. So each router build a complete map and run one specific algorithm. So it basically update that information only. It seems like whenever driver learn about a road or opening or closing, they broadcast just that a single update. So each driver then use all those updates to redraw the own full path. Is it clear? So summary is that when we're talking about distance vector, we update the entire information, but in the link state, we only update the recent information or the updated new information, which is basically there. Okay. So that is the thin line difference we have. Summary is that distance vector routing protocol periodically swap the entire routing table with the neighbors and learn the hop counts. Hop mean routers here, how many routers we have, and update accordingly. But in the link state, the router share only their local link information, which build the full network map, and it is independently compute shortest path. So RIP is the distance vector. Okay, maximum it support hop is basically 15. It means we have a router 1, 2, 3, 4, 5, 6 we have here. So maximum it can cover up to the 15 routers. So it's used for the short distance. Second is basically called as a OSPF. Now when we're talking about OSPF, what is the full form of OSPF? OSPF stand for Open Shortest Path Label. It is a link state protocol. It is an open protocol not owned by Cisco like eGRP. So it use a cost matrix, which is called as a bandwidth. So higher bandwidth, lower cost. So before OSPF, the older protocols like RIP was use simple logic like hop count, number of router, and based on that pass the data, but it could not consider the speed and bandwidth. So OSPF came into the picture. It offered the quick reaction. It looked for the better path decision, and it is scalable for the bigger networks. Am I clear? So that something is basically there. So it uses a SPF algorithm. So all routers share the roadmap with each other. They draw the each full city, and according to that, they look for the fastest route path and update the information. Then we introduce the next one, which is called as a EIGRP. EIGRP is the Advanced Distance Vector Protocol, which use the composite matrix of bandwidth, delay, and all that. So EIGRP stands for Enhanced Interior Gateway Routing Protocol. And it is a Cisco proprietary protocol developed by Cisco, and it has both distance vector link state feature. That's why it's called as a dual algorithm. Okay. So old protocol like RIP was slow and basics. Cisco created EIGRP, which fast convergence alternative OSPF, and it giving a best competition to the EIGRP, best competition to the OSPF. Okay. So that something is there, and it considered some metrics like bandwidth, okay, delay, and next is called as a load. Load is optional, and reliability. Okay. So it consider the bandwidth, it consider delay, it basically consider load, it consider reliability, and based on that, it transfer the data. So that's how it basically send that information. So it know multiple routes, it pick the fast and safest method, and keep the backup route ready. Now next is basically called as a ISIS. So that is the another one we have. It's a link state protocol, and it is also called as a intermediate system to intermediate system. Okay. So it's a dynamic routing protocol. It moves data within a large network like ISP, telecom, or big enterprise. Is it clear? So it's like a open protocol, and that's why it is a cost base. So in OSI model, when we're talking about this protocol works on the layer 3, and it built with the flexibility and carry your IP and IPv6 traffics. That's something is there. So any question talking about ISP, large telecom service providers, like in India also Jio, Airtel, they all are using a ISIS, which is basically like a backbone. You can say like that. Next is basically called as a BGP. BGP is a path vector, okay, which is also called as a border gateway protocol. It is a protocol that runs the internet, okay, and it works with different networks used by the ISP and all that. That something is basically there. So I'm sure you got this visibility. What is MPLS? What is VPN? We will discuss in the next session, where I'm going to discuss deep dive into each and everything. But right now I'm just giving you information. So RIP, when you're talking about routing information protocol, used old simple hop counts. OSPF is more intelligent. It use a link cost, which is good for enterprise. EIGRP is a Cisco proprietary, fast and efficient. BGP is use route between the countries and ISP. An alternate of that, we had a IS. So that something is basically there. So I'm sure you got the visibility about that things. One more important thing, distance vector update the entire routing information regular basis. But in the link state, we only update the new features we have. One more important thing you need to understand is ISIS works on the layer 3. BGP works on the layer 4. Okay, between the ISP. I repeat again, ISIS inside the company or ISP backbone. But BGP between the ISP, it basically works between the cloud and global network. That something is there. You need to understand that. Then second thing is that, in the case of ISIS, we build a full network map, but in the case of BGP, we don't have a full topology. In the ISIS, we use based on a link bandwidth, but in the BGP, we use other factors. Which one is fast? ISIS, BGP is basically slow. That something is there. So if you're looking for the best route within your city, use ISIS. If you're looking for the best route between the cities, within your city is ISIS, between your cities, between the things, that is basically called as a BGP. So if you take example of telco or enterprise network, okay, for high speed, they use ISIS, but to connect to the internet, cloud, multi-home and all that, they basically use the BGP. And that's how it basically works. So question is how the routing protocols basically works. That's a question. So first step is router first meet each other on a common link. So they establish the session hello message. They exchange either routing tables by distance vector or link state. As I said, distance vector add the hop count to each network and pick the lowest, and link state build the full map. And based on that, we update the routing informations, and then they exchange the data. Okay, so we're going to discuss now about OSI model. Now in 1969, the first network was created, but the problem is that different vendors, they speak in a different way about how the data need to be communicated between the two parties. So we were looking for a one common standard. Okay, this is a set of rules that we follow, and that basically define how the two systems communicate with each other. So we have a system A and we have a system B. No matter which protocol you're using, this is the standard set of rules which define how the two systems communicate with each other. So 1977, the OSI was introduced. Okay, in 1984, the model was published. So this OSI model is a blueprint which talk about how data should travel, okay, between two devices. And actually the OSI model was introduced with the objective of how the destination receives data. That is why according to OSI model, the first layer is physical layer, second is called data link layer, third is called network layer, fourth is called transport layer, fifth is called session layer, sixth is called presentation, and seventh is called as an application layer. Okay, but whenever any instructor or whenever any teacher try to explain the OSI, he take the reference of both sides. He take the reference of source also, he take the reference of destination also. And with that context only, I'm going to explain the OSI. Now let's take an example. You open a browser. Okay, so you open a browser. In the browser, you enter gmail.com. So when you hit gmail.com, you're actually interacting on the application layer. Simply open a browser, you enter the URL, you're interacting with the application layer. From application layer, the data basically goes to the presentation layer. Now, what is the role of presentation layer? Presentation layer responsible for two things. It does encoding and it does encryption. Along with that, it also do one more important thing, which is called as a compression. Okay, it does the encoding, it does the encryption, it does the compression. So ultimate goal of presentation layer, present the data in a format which lower layers can understand. Now data, once it compressed and then we encrypt, it moved to session layer. Session layer responsible for setting the session between the two parties. It is a layer which is responsible for setting up the session between the two parties. When we're using HTTP and all that, we are agree on one session, right? So that is basically set up between the two parties. Now the data is moved to the transport layer. See, transport layer play a very important role because it maintains the flow control between the lower three and above three. So you can say it is a backbone of the communication. In transport layer, what happens is we divide the data into segment 1, 2, 3, 4, and we assign one number to the each segment 1, 2, 3, 4, 5, so that when destination receive data in a segment, with the help of number, we can rearrange and form the data back. Second thing is that transport layer is the layer we have a two sub protocols. One is called TCP and one is called UDP. Now what is protocol? See, right now this session which I'm recording in the English so that you can able to understand. If I speak in Hindi, you will not able to understand. So I'm using a set of rule which is called English, a standard rule by which I can able to communicate with everyone. So protocol is a set of rule which talk about how the two systems communicate with each other. I will give one more example. Until unless we don't add the IP address, can you communicate over the internet or network? No. Without adding a preferred DNS, can you translate name to IP to name? The answer is no. So it is a set of rule. So TCP and UDP are the two protocols used on the transport layer. Now what is the difference? See, when we have a system A and we have a system B, whatever the protocols we use in application layer like HTTP and all that, it need to go through a particular port number, that port addressing done on the transport layer. Example, HTTP, I'm communicating with the server on HTTP. So it need to be communicate on the port number 80 or 443. So before we sending a data, we send a SYN packet. Hey, this is me. Yeah, hi. So it is just like, you when you call someone, you say hi. So hi is like a SYN. If the port is up, it will reply back, yes, hi, how are you? So he give the acknowledgement of how are you? Hi, I'm good. And he also send the hi. And then you're giving acknowledgement. Yes, I'm also good. So this is called as a three-way handshake. So this is happen in the case of TCP. But in the UDP, we don't do this three-way handshake. We simply send the data. It is same like, when you're doing a conversation with your friend, it start with hi, hello, how are you? That is why you can speak for 30-40 minutes. But when you speak to your partner, whether you speak to your husband, you speak to the wife, it start with no logic and finish with low logic, right? So which conversation has prone to error? UDP. Same thing happen here. In TCP, we have a reliable three-way handshake and then we proceed with the data because end goal is to deliver the data in the same state. But in the case of UDP, we simply deliver the data. We don't do three-way handshake. Second thing is that when the transport layer divide the data into segment, we also follow one more feature in the transport layer, which is called as a flow control. Flow control. What is the flow control? Flow control basically mean we divide the data. Okay, so we send 3 data, 1, 2, 3. We get acknowledgement from there for 4. It means he received the last 3. So by this way, we maintain the flow control. So it should not be overflow the packets. Now what happened? So in transport layer, we divide the message into segment. So we have 1, 2, 3, and each segment is further fragmented into packet 1 and packet 2. So in the network layer, we have a packet. So each segment is further fragmented into packets. Can you imagine? So that's something we are doing. So now what happened when network layer receive the packet 1 and packet 2. So each packet, they assign the source IP and destination IP. Source IP and destination IP. On transport layer, we are assigning a source port, destination port, but in this layer, we attach the source IP and destination IP. Then after attaching the source IP, destination IP, actually in the network layer, we have a two type of protocol. One is called as a routing protocol. Routing protocol. And one is called as a routed protocol. Now what is the difference? So we have a system A and we have a system B. So we need to first create a route. So route is created by the routing protocol. In my next video, I'm going to cover that. Routing protocol is the one which create a route. And routed protocol, so example of routing protocol is RIP, IGRP, OSPF. These are routing protocol which define the route. And the data which is carried on the route by IP and IPX are called as routed protocols. Most of the protocols on network layer are connectionless because their role is to just deliver the data. Then the data, each packet, it moved to data link layer. Data link layer have a two sub layer. One is basically called as a LLC and one is called as a MAC. Now what LLC does, LLC receive every packet. So this is suppose LLC receive a packet. This is the packet we have, which already have a source IP, destination IP address. Now in this, what happen is, so each packet, so we assign the source MAC and destination MAC address. And in the, and we also check the hash for this and we add the CRC value. CRC value is check the hashing for that. And when you attach the source MAC address and destination MAC address and then you attach the CRC, this entire representation is called as a frame. And then data passed to the MAC. MAC will unstructure data and convert into the binary and pass the information, the binary format to physical layer. From physical to physical, it go in the electrical signals. Then go to physical layer. From there, it picked by the MAC. MAC will structure the data, pass to LLC. LLC check the MAC address. Is it same or not? Remove the address, pass to the network layer. Network layer check the source and destination IP. If it's same, go to transport layer. Transport layer rearrange the data. Go to the session layer. Session layer terminate the session. Go to the presentation layer decode the data, and then finally we have an application layer where the user can see the data. So in every layer we have a data format. Let's say example on the application layer, the data format is called message, and we adding a respective header of the layer. On presentation layer, the data type is message. As it passed the data from application layer, it already has a header. He also had his header. Then data is basically on the session layer. The data type is basically message. It already have an application header, presentation header, and session header. Then data go to the transport layer. In transport layer, data is segment. Already have an application layer, presentation layer, transport layer. Then data is basically going on the network layer. In network layer, the data type is basically packet. And we add the respective application, presentation, session, transport, and network header. And data in the data link layer is basically called as a frame. Respective header is there. Application, presentation, session, transport, network, and all that. And the data is basically, so in every layer, we add the header. So when the data goes through this, after verification of every address, they remove the header, and that is called as a decapsulation. So this is called as an encapsulation. And this is basically called as a decapsulation. In my next slide, I'm going to discuss about that only. So let's understand the OSI also more from the simple analogy perspective. So you get a more visibility. Now here we have a OSI model with, let's say example, if you are in Middle East, you know Talabat. You are in India, you know about Uber Eat or Zomato Eat. So let's say example, you open a food aggregator app. So you can see the list of restaurant and all that is called application layer. Now you select the particular restaurant. They basically provide you the setup of session. Once the session is established with that restaurant, they will show you the list of menu and you select the menu and then you add your address. Okay, then you also add your pin code and the order is basically shoot. When the agent reach your physical location, that is a physical location based on a pin code, he exactly get the building. Now he coming on a particular floor number, that is a network. Before he ring the bell, he organize all the food. Then he ring the bell. Then he present the food in a way you can able to grab, and then he grab the thing. So that is how the OSI basically works. Okay. And we also called as a short form to remember is all people seem to need data processing. All people seem to need data processing. So I have created one more table where I have explained about in each and every layer what is there. So application layer, interface for user application network. So protocol like web browser, HTTP, email, FTP works here. Presentation layer, we have translate, we encrypt, decrypt, compress the data. SSL, TLS works from here. Session layer, establish, manage the session. VPN tunnel, RDP, NetBIOS works here. Transport layer, we have a TCP, UDP, reliable for best for delivery and all that. A logical addressing, routing is done on the network layer. Physical addressing, error detection is basically done. It is also called as a MAC address. And we also do the switching, which I'm going to discuss in our next videos. And physical layer is basically we have a raw bits which is transferred by the media and all that. So these are the different type of layers we have that we need to understand.
Today I'm going to discuss about backup and backup types. This topic can help you for your Security Plus or other CompTIA exams, IC squaring saga. See, the example that I'm going to refer in this topic, it is a practical parameter which is done in a Windows backup. Okay, so based on that, I'm trying to explain you the backup types. So backup is a tool by which we recover the data, and with the help of backup we can able to restore the files if it's deleted and all that. The question is that we have a different type of backup: full backup, incremental backup, and differential backup. So full backup is the backup which we have taken in a one go. But after the full backup, we have a two more type of backups: incremental, differential. This video is only and only focus on incremental and differential backup because a lot of people have a confusion regarding this section. So first we discuss about the incremental backup. So I'm creating one table here. You can say match the following. Here I'm going to explain about incremental backup. I need your 5 minutes of attention, and mark my word, you will get this concept clear. Incremental backup. Okay, now what happened, we have a folder. Okay, so we have a folder. In the folder, on Monday I add the file 1. On Monday I added the file 1, and I have taken the full backup. Okay, this is happening on Monday. Then Tuesday I add file 2, and this time I have taken the incremental backup, and this is happening on Tuesday. Okay, so when I'm taking incremental backup will take a backup of file 2 only. After the full backup, whatever the incremental is there, it take a backup of that. Same like we said that your increment salary, the salary is increased from today, it is 3,000 rupees or it's $1,000. So it is added to your additional existing salary, but it will be a separate value which is given. Same like that. Increment is a word used for weakness. So file 2 has been added, and we have taken the differential incremental backup. Okay, so in that case, it will take a backup of this file 2 only. You're performing a backup on folder itself, but it will skip the file 1 and it will only take a backup of file 2. Now Wednesday you add file 3. Okay, and this time you have taken the incremental backup. Wednesday. So Wednesday when you add a file 3, okay, it will take a backup of file 3 only. Okay, because Tuesday this backup is already taken. What is the logic behind that? See, when you take a backup of the file, if you go to file properties and in the advanced option, you can see one option called archive date. archive bit. When you take a backup of file 2, archive bit is already checked, okay? When you take a backup of the file 2, the archive bit become unchecked. It means file is already backed up. And when you take a backup of file 3, that archive bit become unchecked. It means the file is already archived. So that is why the backup tool identify which file is backed up and which one is not. So according to that, it will take a backup of this new file. So with the help of archive bit, we can able to identify the file is backed up or not, or new entry has been created or not. Now example, file 2 after incremental backup, you introduce some changes into the file 2. Then again it become a check. It means I'm ready for backup. So with the help of archive bit, we can able to get the idea whether we need to back up or not. So in the incremental backup, it take the backup incremental wise. Now Monday, Tuesday, Wednesday, Thursday I add the file 4. And now I'm taking an incremental backup. Thursday. So it will take a backup of file 4 only. So it means taking a backup is faster because it taking that individual day. From a storage cost point of view, it's a cost effective because it's taking a backup of the incremental file. So if the question talking about cost and faster taking backup, answer is incremental. As a consultant, you can recommend this in a solution also. Example, interview questions and all that. Because it will take a backup of the new file. It only take a space in the tape backup of the new parameters. So it saves cost and taking backup is also faster. But if you're planning to restore, we have to go by sequence. First, I need to restore the file 4. Then I need to restore file 3. Then I need to restore file 2. Then I need to restore file 1. See, right now I'm taking example of one file only. Just imagine every day how many files we backed up. So taking backup, it is faster. But restoration is basically slower in the case of incremental backup. So I'm sure incremental backup is clear to everyone. So let's move to the next backup, which is called as a differential backup. Now in the differential backup, we have a folder. Monday, I added a file 1. Monday, and I have taken the full backup. Okay, now Tuesday, I add the file, and this time I have taken the differential backup. It will take a backup file 2 only. Then Wednesday, when I add the file 3, in the file 3 on Wednesday, and when I'm performing a differential, it will take the last differential and this also. That is the difference. In this, it will take the individual day, but in the differential, it will take the previous differential and the current differential. So Thursday, if I add the file 4 and I'm taking the Thursday differential, so it will take a Tuesday one, Wednesday one, and Thursday one again. You know why? Because their archive bit always remain check. It means we need to take backup again and again. So in the incremental, it become unchecked. Okay, but in the differential, it remains check. It means we need to take a backup. So while taking a backup, differential is basically slow because it takes the previous differential also. But if I restore the Thursday one, it will restore from Tuesday, Thursday in one go. So restoration is fast. So when my requirement is data criticality, and on a regular basis we restoring a data, we go for differential backup, but the cost is basically very high. So that is the point we have to understand. So in the incremental, taking a backup individually, that's why taking backup is faster, but restoring is slower. Cost is okay because it's taking a new backup, but in the differential, it taking the backup space more because we adding previous and current differential backups. So this is the important point we need to understand. One more important thing when we're talking about the validation part, in the exam they're talking about storage cost and everything. So that is an important parameter we need to understand. And one more important thing which I need to explain you in the incremental differential. So when you're talking about incremental backup, and when we're talking about differential backup, we have one concept called as a archive bit 1 or 0. Archive bit. Okay, so when you're talking about differential backup, in that archive bit remain 1 because it is not become unchecked, right? So it remains checked. But in incremental backup, it becomes 0. It means get removed. So this is another important point, because when you take a backup, it becomes unchecked, right? So that's why it becomes 0. But in differential backup, it remains 1 because it remains checked. So it means again we need to take a backup. So if you find this video useful, do share in your network, and those who are preparing for ISACA, CompTIA and IC2, this topic is very important. And you can share with your networks, and do share your suggestions, do share your feedback in a comment box. How do you find this video? Do you wish to continue the similar videos of the whiteboard presentation, or you want back to digital presentation? Thank you.
Today we're going to discuss about information and cybersecurity fundamental. My name is Prab Nair, and for more information you can refer my LinkedIn profile. And if you're new to this YouTube channel, do subscribe to my YouTube channel and click on the bell icon to make sure you should not miss any of my video. So without wasting a time, let's move to the next part. So what is information security? Information is basically a value which is generated by the organization, or you can say information creating a value for the organization. Let's take an example. We have a Netflix. Netflix earn the revenue from the web series. They earn the revenue from movies. Okay. Now just imagine if someone hacked into the Netflix. Okay. They hacked into the Netflix and download all the web series and everything and kept offline. And then he start distributing, or she start distributing those series and everything offline. It is a direct loss for the Netflix because no one is going to visit the Netflix. Okay, the hacker with a bad guy, he just start or she just start a bad practices and selling the videos in a very half cost. So it's a loss for the Netflix. So what Netflix did, they basically appoint a InfoSec team. And that team is responsible to protect all these data. Okay, so data is belong to an asset. So when I say information security, their primary objective is to protect the assets. An asset is two type, tangible and intangible. So when I say tangible, like which we can physically touch, and intangible is logical. So here what happened is the Netflix, whatever the movies, web series we have, these are intangible because it's a logical. But there will be some servers which hold the data. They also need to protect that. So that is called as a tangible assets. So information security is a process by which we try to protect this asset. Information security has a procedures by which they protect the asset, and that is why the company basically hire the professional for the same activity. So here they will ensure that okay, confidential data must be protected by the responsible individual. All type of data must be protected, and most important, this reduce the risk to the business and other implication of losing a critical data. So this is what we have. So we also have another important term which is called as a cybersecurity. So it does always create a confusion. Prab, what is the difference between the cybersecurity and information security? So you can see like that cybersecurity is a sub part of the information security. Example is we have a smartphone. This is my smartphone, Android phone. In this Android phone, I hold some data. I hold images. I hold WhatsApp chat. So those image, those WhatsApp chat is basically protected with the password. I encrypt that, or I protect it with the password. So that is deal called as a cyber security. Okay, that is called as a cybersecurity. It been applying the password, protecting with the password, images, WhatsApp, that is a cybersecurity. But if I place this mobile in the locker and locked with the key, that is part of a information security. So information security is deal with the physical security and logical security. And under the information security, the logical security deal by the cyber security. That is why cyber security is a part of the information security. So summary is that cyber security deal with the digital data, whereas the information security deal with all kind of assets, tangible and intangible. Okay, so that is the difference. So when you're talking about the information security, it is basically achieving the three things, and that is how we build the trust: confidentiality, integrity, and availability. Now let me give you an example. Okay, so example, this is me, Prab, and this is Manish, my best friend. Okay, Manish one day came to me and he shared me some information, and he told me, Prab, I trust you, do not share this information with others. So based on the trust, I hold that information with me and ensure I will not share with anyone. So what is the outcome we got? Manish basically gained more trust. Manish blindly start trusting the Prab and all that. And based on the trust, he's sharing more and more information. So I have some information security principles, and because of the principles, what I did, I protect those information and to make sure I should not share with others. Second important thing, Manish, one day what happened, he got to know that his friend got the information about him, and later on he got to know that information shared by Prab. Okay, so in that case, there the Manish lost the faith on Prab, and from the next day onwards, Manish stopped communicating with the Prab. So same thing happened in the organization. We have a bank. So me went to the bank to open an account. Bank opened the account and they issue me a username and password. And with the help of username and password, I can log into my net banking. I can check my financial statements and all that. So there is a team in the bank, which is an InfoSec team, which ensure the confidentiality of the data, which is the customer data. And that is why, to maintain the confidentiality, they issued the username and password to the customer. So he can use his own username and password, and through that he can log in and he can see the data. And we have issued the separate username and password for other customer. So that is the utmost priority we have to maintain the confidentiality. But tomorrow, if his bank statement, his account got hacked and someone get access to his account and access to all the financial data, he will be kind of a panic, or she will be kind of frustrated, and they can come to the bank and they start, or she or she start abusing, and there is a possibility bank lose that customer also. That is why the bank has an InfoSec team and ensure the confidentiality of a data must be protected, because tomorrow if data goes disclosed, they might lose the customer. So that is the first goal of the information security as a process, to maintain the confidentiality of the data. Not a first process, one of the goal is to maintain the confidentiality of the data or confidentiality of the asset. Second is basically called as a integrity. Integrity basically protect against improper information modification or destruction, including that information reputation authenticity. It's a very technical term. So if you go by the layman, it means protection of the information from unauthorized modification. Same story here. Prab told something to Manish. Okay, so Prab has told something to Manish. Based on the trust, Manish accepted the information, and based on the information, he did some planning, and later on, Manish was in a deep trouble. One example is Manish asked me, Prab, can you tell me how's the weather in Goa? Okay, I intentionally gave him a wrong information. Manish, weather is amazing, go with a 5. Based on my advice, Manish went to Goa and he planned his vacation. But later on, get to know there was a lot of rain happen and all that. So next time Manish think twice before asking anything from Prab, because Prab has given the inaccurate information. So you can imagine here how the integrity of information play an important role in building the trust. So in this case, Manish stopped asking the questions from the Prab. Same thing happened with the bank. So here we have a bank. Okay, and there is a user. So we have an InfoSec team, and that InfoSec team is basically introduce some kind of a certificates, and they also introduce some kind of a hash. So when bank issue a bank statement, along with that they give the hash value, which is a fixed value of the data. And they told them, hey guys, whenever you download the bank statement, check the hash value of the data. Okay. First scan the hash value and compare the hash value with the hash value what you receive on an email. If hash value is different, it means this is not the same data we have sent. So with the hash value, we can able to identify the accuracy of a data. Second is you go to website, you visit the website and see the certificate. You see the URL certificate with, compare the URL with your actual URL. If URL is same, it means you are connected with the right website. If URL is different, do not proceed with the website. So as a information security, the goal here is to maintain the integrity of the information. Okay. So that is called as integrity. So we can achieve the integrity by hashing, by digital certificates and all that. The third important thing is called as a availability. So information must be available whenever it required. So same with Prab and Manish. Manish reach out to Prab, but Prab is not available. And whenever Manish need the help, Prab is not available. So that lost the faith. And later on, Manish stopped communicating with the Prab. Same thing happened we are opening a website of the bank. And every time when I'm trying to open the website, it giving me error. The website is not available, website is unavailable. So it creates some kind of frustration. And I decided I will not going to continue the business with the website bank. And in that case, the bank might lose that customer. So as an information security team or information security department, we ensure the information must be available whenever it required. That's why we introduce a load balancers. We introduce the redundant systems and all that. So every company who have an information security team in the organization, they introduce a process by which they want to ensure the confidentiality of our assets, integrity of an assets, and most important, availability of the assets. Today, after the confidentiality, the second most important thing on which they work is called as the integrity, because accuracy of information is very important. Like data science, data analytics rely on the data. So data must be accurate because based on the data only they do the planning. So this is called as a CIA. Moving to the next part. We also have one more important statement which is called privacy and secrecy. So privacy is something which is deal with the individual, your PHI, personal health information, your personal financial information, your WhatsApp chat, which is deal with the individual. And secrecy is basically deal with the organization. Example, company's trade secret, company's internal formula and all that. Example, Coca-Cola, Pepsi, their internal information about how they make the items. We have a KFC chicken process making. So that is internal to the organization. That's when the organization, we use the concept called as a trade secret and all that. So privacy is deal with the individual, and we have a regulations by which they protect the privacy of an individual. And company creating a policy for their internal data, which is called as a secrecy. That's why we say secrecy deal with the organization data and privacy deal with the individual data. And we have a necessary controls for that. Let's move to the next part. Okay, so we have some more terms. Example like identification, authentication, authorization, and accounting. Identification is the process of verifying the identity. Example like you go to airport. So I'm going to the airport, example, and I told them, hey, my name is Prab and I'm traveling from Trivandrum to Delhi. So they will see my name in the list, whether I'm in a part of passenger list. So that is called as an identification. Yes, I can see your name. Do you have any proof which can claim that you are Prab? That is called as an authentication. So in this case, I'm showing my passport, which representing my name with photo ID. So I have something which can prove I'm who claim to be. That is called as an authentication. Okay, sir, we can confirm your identity. Thank you. I'm giving you the seat number 34. That is basically called as a authorization. But make sure I'm taking the right plane, right seat, and doing everything as per things that required my activity. That is called as an accounting. Same thing with the Gmail. You open the Gmail. First thing they ask for the email address. If email address valid, then only it moves to the password page if you notice. So entering the email address and they're checking the email is valid in the database. That is called as a identification. Okay. Now second thing basically ask for the authentication. The person who claimed to be. That's why you enter the password. Because when you're talking about authentication, authentication is the process of verifying the person who claimed to be. So we have a 3 type of authentication. Something you know, which is your password. Something you have, which is like a smart card, token, and something you are, which is a biometric. So once I type the username password, I get access to my mailbox. I can access my particular mailbox. So that have a authorization. Whatever I'm browsing, whatever I'm checking, they're tracking my activity. That is called as a accounting, and which is achieved by the logs. Okay, so these are the general terms we have. Now next important thing is an asset. Asset is anything which create a value for the organization team. Okay, we have a tangible asset and we have a intangible assets. Okay, mobile is my tangible. Data in the mobile is intangible. Server is a tangible, physical asset. Data in the server is intangible. So we always define their values. Value is something which generate for the business. Second thing which is called as a threat. Threat is any action that compromise the asset. Example like virus. So if you take example, virus. So virus is a threat. Okay. Which exploit the server. Disgruntled employee is a threat. Okay. Which hack the server. So threat is any action or event or actor who compromise the asset. But question is how? He need to discover the vulnerabilities. And that lead to the loss. So if I articulate everything, how it works, we have a user here. So user is a threat. He discovered a weakness in the server. And the weakness was password. There is a no password. So password is basically a vulnerability. Weak password is a vulnerability. Weak password is a vulnerability. And this is my employee, or you can say hacker. So he discovered the weakness in the server. Server is the asset. Okay. He discovered the weakness in the server, which is called as a vulnerability, and by which he gained access to the server and he was able to seize the data. So gaining the access to the data is a loss for the organization. So that is basically called as a risk. So asset is the one with generating a value. Threat is an action which done against the assets by exploiting a vulnerability. And if this attack becomes successful, it directly impact the business, and that is basically called as a risk. Risk is a concept that indicate the exposure to the change of damage or loss and signify the likelihood of the dangerous threat we have. That is basically called as a risk. Oh, I lost my $5,000 because hacker gained access to the system. So hacker is a threat. He exploits the vulnerability, and the loss what I face from that attack is a risk. Risk is an outcome. Okay, next is called as a virus, Trojan, and worm. Virus is a self-replicating program which infecting a system. But if I say we have a system A and we have a system B, if virus is basically infected the system A, in order to move virus from system A to system B, it required human interference. How? I plug the pen drive. So virus use the memory as an opportunity, and through which he moved to the pen drive. When I remove the pen drive from the virus become deactivate. When I plug the pen drive in the system B, virus automatically replicate from the USB to the system B. So this is how the virus replicate from one system to other system with the help of human interference. So virus required human interference to replicate from one system to other system. But when we're talking about the worm, before going to discuss the Trojan, if we're talking about worm, if system A is infected with the virus and he is part of a network, if system A is infected with the worm, if system A is infected with the worm, then, and it's part of a network, automatically worm replicate from one system to other system without human interference. So that is the thin line difference we have. So virus replicate from one system to other system with the help of human interference. Worm doesn't require any kind of a interference from the human. It automatically replicate from one system to other system. One more thing we have called a Trojan. Trojan is installed. Trojan is basically kind of a malware which is introduced to gain access to the system. Okay. It is more from a covert channel. Example, this is me, Prab, and this is Manish, my friend. So I convince Manish, hey Manish, I'm giving you one application. It is a free game. Enjoy. So based on the trust, Manish installed the game in his laptop. And then what happened? It create one logical port. And I gain access to the system through that particular port without his permission. I can remotely manage the system, remotely monitor the system. I can do anything with the system. So with the help of Trojan, it helped me to create a channel. And through the channel, I gain access to the system. Another important thing about Trojan is it is a kind of a malware that hides itself on the infected system. So I'm running an application. So I'm in this impression that game is getting installed, but behind the scene, there is a Trojan get installed in the system. And then attacker use that system, or attacker basically with the help of application can control the system. So that is what is called as a virus, Trojan and worm. Next thing is called as a hacker, black hat and white hat. See, hacker is a person who know the tips and trick and play with the system. That is called as a hacker. We don't call hacker as a bad or white, no. Hacker is the person with having a skill and he use that skill for the company objective or for his personal objective. Now it's up to you. You are using for offensive or defensive. But hacker is a person who play with the skill. Okay. And he know the computer, he know the knowledge and he uses knowledge for his own reason. So that is called as a hacker. Like I know how to cook. So I can play with that. That is called as a hacker. I know computer and know how to use a computer. So that is a hacker. So hacker is not a bad guy. Hacker is a person who know the computer and he use for his reasons. But hacker is categorized into two parts. One is basically called as a black hat and one is called as a white hat. I know the computer but I'm using for the bad activity. Like I want to hack the website and get the money from there and all that. So that is called as a black hat hacker. Offensive guy. But we also have a white hat. White hat means he know hacking. He know how to hack. But he think more from a security point of view. So one of the company gave me an order. He told me, Prab, do one thing. Test my website. They don't say hack my website. They say test my website. Check my website and tell me how secure it is. Because I want to protect my website from actual hacker and all that. So in that case, they will appoint a white hat. They're going to hack. They're going to test all the security issues from an actual hacker point of view and suggest the recommendation to the clients. And according to that, they will apply the necessary controls. And today we're going to discuss about control categories and type. When we're talking about controls are basically introduced to manage the behavior of the people, process and technology in the organization. That's why we have a 3 type of controls in the organization. The first is called as a technical control. Something you implemented technical in nature. Example, firewall, antivirus. So you just installed, their technical function is involved there by which they try to detect, by which they try to block and they do their activity. So something was technical in nature which tried to manage the behavior. That is called as a technical control. One more example I can give you. Suppose this is the firewall we configure and we created a rules in the firewall. So my work is over. Now any packet is going to the firewall, their technical function is going to inspect the packet, compare against the rule, and based on that it will allow or deny. So my involvement is not there. The technical function was involved to inspect the packet and take the further decision. So that is called as a technical control. So if you go by the layman term, hardware, software mechanism use the manager access to resource and system and provide protection for those systems like encryptions. All are basically example of the technical control. Second is called as a physical control. The control that you implement physical in nature, which block, detect, alert physical in nature. Example is physical lock that you install on the doors. So you need a physical key to insert and operate, and by which you open the door. Otherwise, you cannot able to access the facility. That is a perfect example. Then physical detective camera. Camera is there which is physically installed and detect your activity. Something was physically configured there. Something was physically placed there which monitor your behaviors, which block your behavior. So that is called as a physical control. Third is basically called as a administrative control. Administrative control is set of instructions which is set by the management to control the behavior of the people. Example, management has introduced one notice, one rule that we have to resume the office from the March. And for that, you need to carry your vaccination certificate. So it's an instruction. Clearance process, hiring process, background check. It's an instructions. It's instructions which is used to control the behavior, not something technically implemented, not something physically implemented, but it is set of rules or soft cultures or soft control which used to control the behavior in the organization. So these are the three type of controls we have. We're going to discuss each and every type in more detail in the next slides. Okay, so first part is called as a administrative control. Okay, so we have some examples here like operational procedure, like we have a document with us, and according to the SOP document, we follow all the instructions and everything, which is set by my manager. I join the organization, I need to access something. So I have checked the policy. In policy, it is mentioned until unless you don't have a clearance, you can't access the thing. So something was set by the management by which we controlling the behavior. That is a different story. Through the technology we can implement, but that become a technical in control. But here some instructions, some policies already created by the management to control the behavior. Then we hired a human which monitoring and supervising the people and checking whether they're working as per the policy or not. That's administrative control. We have a user management process. Okay, I'm sure user management and privilege management, you might be thinking it is a technical control. No. Suppose someone join as an organization as a new employee and all that, through the user management process, it's a process, it is a policy we have created, and according to that user management process, we issue the new username password, we manage the username password. Through the tool like SailPoint and all that, we are issuing that, then it is become a technical control. Okay, any kind of a privilege credentials we need to manage, it need to be managed through a privilege management control. So these are the examples we have for the administrative control, like introducing a separation of a duty policy that one person will not perform end-to-end task. So it's an instruction. So we have to make sure we have a 3 people in the process where the one person will approve, one person will sign, and one person will make the payment. So it's an instruction, it's an order, it's a requirement which is used to control the behavior. Okay, so that is called as an administrative control. Now next thing is called as a physical control, something we implemented physical in nature. Example, network segregation. So we have one physical switch and we have another physical switch. So by which we can able to segregate the host physically. So that is the one example we have, network segregation. Okay, then we have a perimeter security. It is a mechanism that provides the physical access control by providing protection for individuals, facility, and the component within the facility. It means one human or one user cannot able to access the other part of the perimeter physically because his card doesn't work. Example, this is the facility we have. This is the one parameter, this is another parameter. One person came from outside, he can able to access this area physically. But if he try to access this area, he need to punch card. When he punched the card, his access was rejected. So physically, we prevent him to access this area. physically we prevent them to access this area because there is a guard, there is a door, there is a proper lock control is there. So something was physically installed there which prevent them to access that particular area. Then we have a computer control. Computer control, like we have a locks on the laptops, we have a locks on the system, so no one can take it physically from there. Okay, then work area separation, like we creating a cabins by which we ensure one person should not able to access the other area. Data backups ensure access to information in the case of emergency or disruption of a network or a system. So that is the data backups. I'm talking about data backup here is physical access of the data backups on the offsite and all that. Then we have a cabling. All cables need to be routed through the facility and all that. So we're providing a proper physical security to the cablings. So they should not able to access that cable directly. They should not burn it. They should not cut it. Okay, which can be lead to the eavesdropping. So something you have implemented physical in nature. So that is called as a physical control. Okay. Next thing is basically called as a technical control, which is technical in nature, like user access. Now, as a user, I want to access. So I have a system A and I want to access system B. So when I request for an access, like request for the IP, B automatically asks for the user and password. It is not something a user is there who follow the company order and ask. No, there's a technical function is involved which automatically asks the system A. I'm sure whenever you're accessing any kind of a folder, resources and all that, it always asks for the user and password of the target system. So it is an authentication procedure. So single factor is there, multi-factor is there, two-factor is there. Same thing happen in the case of network access also. In network access, you're trying to connect the systems on the network. Okay, with the help of router, with the help of switch, we're creating a logical segmentations. So there is a technical control in the switch we have by which we're creating a logical segmentation. Okay, we can do physical segmentation by physically isolate the switch. But within the switch, we can have a logical segmentation. We call it as a VLAN. So that is because of a technical control we have in the switch. Remote access like VPN. So user is connecting by VPN server asks for the username and password. So there is a technical function is involved. Then we have a application access where the application may have a layer of control like user activity, object security, internal services. Then any malware in the system, there is a malware control is there which detect the malware. So it is a technical function by which they try to block. And finally, we have a encryption, which is used to protect the data in a technical manner. So key is need to be feed by which encrypt and decrypt the data. So these are the control which are technical in nature. Okay, we just configure it and they just work technically. So these are the three type of controls we have, but the question is how they work. That is why we have a 7 category, and that I'm going to discuss in my next slide. Okay, so we have discussed about type of controls, which is a 3 type of controls. And now we're going to discuss about 7 category. Perhaps 7 category? Yes. But here I can see on the screen 6 categories. Yes, so 1 category is missing here, which is a deterrent control. We don't implement, but we just create that environment. That is why it is missing here. So moral of the story here is we have a 3 type of control, and each type performs 7 type of functions. If I say we have a lock, why we need a lock? So we can able to block unauthorized user to access a facility. So it's a physical preventative control. So this is how it works. So whenever we organizing a control, we organize them in a form of type with category. So categories are the function. So the first control here is called as a directive control. Directive control is like giving instructions. Okay, a mandatory control that have been put in place due to the regulations or environmental requirement. One example of the directive control is speed limit sign, which is a common example of a directive control. Okay, when you join the facility, when you join the organization, they have given the direction. For the masked people go this side and non-masked people go this side. So it's a directive, it's a direction. Okay, so some controls are there which basically give the direction. And that is called as a directive control. One more example is no one's supposed to browse social media 9 to 5. It's a directive control, a kind of a technical directive, because there's a technical information is there which instructing the people. No one's supposed to browse social media 9 to 5. That's a directive control. Now in this message, if I add one more point, if I find anyone browsing social media 9 to 5, we will take a very strict action against the employee. So this message create a fear. This message create a deterrent environment. Deterrent. Oh, so I am new to the company and I heard this thing is that I have seen this in the policy that no one's supposed to browse social media 9 to 5. And if they find us browsing social media 9 to 5, then they can terminate me. So it create a fear and I will think twice before doing this activity. So here in the directive control, this word was added to discourage the user. One more example is when you go to the bank. In the bank, it is mentioned you are under CCTV monitoring. It's a directive control. It's giving you direction that the system is under the CCTV monitoring. If they don't put that message, it is considered as a spy. That is why they post this message. They post this sign that, okay, this area is under CCTV monitoring. So for an intruder, it is like a deterrent. Oh, there is a CCTV monitoring camera. It might track my activity. So deterrent access control or deterrent control is deployed to discourage the violation of our security functions. Deterrent control pick up where the prevention leaves off. Deterrent does not stop with trying to prevent an action. Instead, it go further to exact the consequences in the event of attempted or the successful violation. Okay. So we have a strong fence. We just created this information. We have a strong fence. Oh, they have a strong fence. Oh, I am unable to get into this facility. They have a too much security control. So this kind of an environment discourage my behavior. So that is called as the deterrence control. That's why it is not mentioned here because it is just like a placement of the environment or create an environment. Next control is called as a preventative control. It is a control which used to avoid an incident in the organization. Okay. It is introduced to stop the unwanted or unauthorized activity from occurring. Example of a preventative control, like technical preventative, is firewall. We install the firewall to make sure unauthorized user should not able to access my facility. Okay, we install the lock, which will make sure physical user should not able to access the unauthorized area. Okay. Everyone has to sign in the register. So it is an administrative preventative. Until unless you don't sign, you can't access the facility. So message convey the meaning of preventative parameter. So that is called as a preventative control. Same example, everyone have a clear mandatory parameter. No one's supposed to browse social media 9 to 5. Now there is a one user. What he did, he tried to open social media. But there was a endpoint DLP installed in his laptop, or there was a proxy which is installed in the network. So whenever he tried to send Facebook request and all that, this proxy will try to block that. So that solution will prevent from browsing such kind of website, which is against the company policy. So we cannot completely rely only on a directive control. That is why with the directive control, we implement the preventative control. That is why it is part of building defense. But only rely on one single preventative control will not be a good effective practice. That is why we introduce the compensating control. Compensating control is basically introduced to support my existing controls. One common example I can give you. We introduce a policy parameter in the organization that every user must follow 8-character password. Now some users are frustrated. They set only 4-character password example, but we need to protect their accounts. So what we did, we enable the OTP with that one-time password. So tomorrow, if their account get hacked, their password get hacked, still the hacker need a OTP access. So my first control, which is a password, is already hacked. But thank God we have enabled the OTP, which stopped that activity. So that is a perfect example of the compensating control. So in this case, when he tried to browse social media, okay, he's sending a request by proxy. So proxy will try to block that, which is installed on the network. So what he did, he disconnect the network and he trying to connect his dongle. And through the dongle, he want to browse the private surfing. But what happened is there was an endpoint DLP which is installed in his system, which prevent him to run that internet connection. My primary control is failed. And that is why we introduce a secondary control, which is an endpoint DLP, which is installed in his laptop. Same like he trying to open the Gmail and through which he want to upload some data. And he discovered that, okay, he unable to send through his proxy. So he disconnected, he connect the pen drive, but there was an endpoint DLP installed in his laptop, which prevent him from copying those files. So my primary control was failed and secondary control is there to block that. But by hook and crook, he was able to browse the social media. So his actions get detected in the SIM. That's why we have a detective control here. Detective access control is deployed to discover the unwanted or unauthorized activity. And here he was able to bypass the policy, he was able to bypass the proxy, he was able to bypass the DLP, so his actions get detected. So first thing what we did is a corrective action. So corrective control is basically like a temporary activity that we can do against the system. Okay, so corrective is like remediate the circumstances or mitigate the damage which is during the incident, which is done during an incident. So corrective control is deployed to restore the system to normal, not complete normal, but partial normal. One example I can give you that in this scenario that he was able to hack, he was able to access the social media. So he went against the policy. So HR took the corrective action is terminate the person, and security team, what they did, they have seized his laptop, or we have discovered the system was infected with the virus now. So corrective action was remove the system from the network instead of doing an investigation there. So that is a temporary activity what we did. And then we have a recovery control. Recovery control is basically restore the operating condition back to the normal. So with the same example is HR will find a new candidate and replace the person. So that is an administrative recovery control. And incident management team, what they did, they removed the virus, reinstall the new window and system back to the production. So corrective control is a temporary activity, whereas a recovery control is a permanent activity. Repair and restore the resources. So I'm sure you get the visibility. I can give you one more example from a COVID point of view. The government has announced no one's supposed to go out. So it's an instruction. Some SOC people, what they did, they wore mask, they carry the vaccinations, which is part of a preventative and compensating. Preventative means they have a vaccination, but still they cannot trust that. That's why we're wearing a mask and maintaining a social distance, which is a compensating control. When they reach office, they detect with the RT-PCR test and all that, and we discover they have a COVID symptoms. Definitely there we cannot do the investigation further. So we have isolate them immediately from the family and from the company. That is a corrective control. And then we went for the 14 days recovery. That is a recovery control. So this is how the control category work. When we're talking about these controls are basically applied in a different states of data. And we have a 3 states: data at rest, like it is stored data reside on a hard drive, tapes, in the cloud or storage media. And this data is prone to the extraction by the insider or external attacker who gain access to the system and able to, browse through the content and all that. So data resides somewhere in a storage. Second, data is sent over the network. Okay. So when data travel on the untrusted network, it is open for eavesdropping attack and all that. And data is most vulnerable in a processing. Another name of data in processing is called as a data in use. Right now I'm running a PPT. It is a data in use. I'm uploading this video on YouTube. You can take a print screen of any PPT. So that is the data in use. So we use masking. Okay. We use tokenization during a data in processing. During a data in transit, we can use TLS, SSL, and data at rest, we can use a storage-based encryptions. So if you find this video useful, do share in your network and do let me know what is the next video you want to make on cybersecurity fundamental. If you're new to the channel, click on the subscribe button, click on the bell icon to make sure you should not miss any of my video. Thank you for watching this video. So the first part in this topic is threat. So let's understand what is threat. So threat is anything that has potential to cause harm to the system or an organization. Now it can be person or it can be situation. Okay, so let me explain you with the example. Now if you basically take the perspective of the scenario, let's say example is we have a house. Okay,
So threat could be a burglar who might break into your house. So that is one example. Because when you're talking about the threat is an action which basically trigger. So let's understand with the one scenario. So let's take example, this is my house. Okay, so this is my house. Now what is a concern? Even I have a strong physical door. I have a light. Okay, but if there is any bad actor, okay, or some guy, now he knocked the door or she knocked the door, I open the house and they can do attack on my house, right? So it is an action which basically trigger here. So threat is an action. Okay. Now, if you really want to understand from the, you can say a security point of view. Okay. So that is called a threat is an hacker who want to steal sensitive data. The hacker who want to hack your data, that is basically called as a threat. Now let's take an information security example. We have a server here. Okay, so this is basically my server. Okay, or this is basically my smartphone. Okay, I have some images in my smartphone. Okay, I have some audio, I have some video on my smartphone. Okay, so that is something very valuable for me because it is an asset. Now, for me, the concern is if my girlfriend see these messages, or for me, the concern is my father or my mother see these messages. So at least for me, that is a threat at the age of less than 18 and all that. And for me, the biggest concern is tomorrow is someone stole my phone. Okay, and or someone steal my phone and they see my images for which I am not happy. So these are basically called as a threat because they're doing an action. What is the action they're doing? They're checking my phones. They're trying to steal my phone. So that's an action. Okay, they're doing. So threat can be a hacker. Threat can be my family member. Okay, from which I should have a fear. If they hack, if they get, then it's a problem. So threat is an hacker who want to steal sensitive data. The threat can be intentional or it can be unintentional within the organization. So let's say example, we have a system here. Okay. And we have an employee. He received one phishing link. He click on the phishing link with this impression that, okay, it's some informative things. So it was his unintentional attempt. He was not intentionally doing that. Okay, I want to damage my company. No. He click on the phishing link. He was not in the impression that link can help you to help the hacker to reset the password. So what hacker did, hacker basically sent a phishing link to the A. He click on the link and hacker basically gain access to the system. So here hacker is a threat, the action what he performed. Employee is become my threat because unintentionally he basically click on the link. But there are some employees who intentionally want to commit a crime. For example, I'm on a notice period. I don't like my manager. So before leaving, I'm doing one action is I'm trying to steal data. I'm trying to steal documents. So that is basically called as a threat. So when we're talking about the threat aspects, one thing we need to understand here is threat has a factors. Okay. So when we trigger any threat has a factor. The first is called as a motive. Second is basically called as an opportunity. And third is basically called as a mean. Now, when we say motive is basically mean what basically drives. See, for me, the motivation, I want to shut down my manager mouth, or I want to create damage to my company. That is my motive because they're terminating me. So motive basically mean what drives the attacker. Like for me, the financial gain because the competitor is paying me money. So that was my motive to hack. So motives refer to the reason or incentive behind, you can say, why the threat actor want to carry out an attack. Second is basically called as an opportunity. Opportunity mean the weakness, the weak controls that he identify. Okay. So my family member knows very well. I keep my phone when I go for a washroom, example. Or when I go for gym and all that, I keep my smartphone at the desk. So that time my parents use this opportunity and try to check the thing. So here the opportunity basically means circumstances which allow the threat actor to carry out an attack. Outdated vulnerabilities. Okay, there's no security guard. Okay, so that is basically called as an opportunity. Opportunity where the vulnerability situation can the threat actor exploit, unpatched softwares. And third is basically called mean. It means skill. What is the capability he has? I know hacking, that is my skill. So as a security professional, what we can control is the opportunity which they're going to exploit. Okay, somehow today we have a solutions in place where we can identify what is a method they can use, which is called TTP. So that's why you heard about the new buzzword in the market called threat intel. So by which we can able to predict maximum behavior. So that is basically called as a threat actors. So when we trigger any threat is driven by three factors: motive, opportunity, mean. So by understanding the motive, opportunity, mean, the company can basically better assess the threats and implement the appropriate measures. Is it clear? So let's take one example. Okay, imagine there's a cyber criminal group targeting a retail company. So this is the retail company we have. So we have a retail company. Okay. So imagine a cyber criminal group targeting us. So there is a hackers or groups which targeting a retail company. So anything has a word called action, that is a threat. So here the motive of the cyber criminal is to have a financial gain. They aim to steal customer data. They aim to steal information, which is they want to sell it on the dark web. So that is basically called as a motive. Second is called as an opportunity. Opportunity is basically, we have discovered the retail company basically having a servers which is running with the outdated vulnerabilities. Okay, so company is running an outdated e-commerce software with a known vulnerability which can be easily exploited. And third, the criminal group have a sophisticated malware and they have a special skills to send a phishing mail. That is called as a mean. So that is how they basically target. So security professional, what they do, they will try to see proactively, is the other companies also facing the same method of attack, or what is the opportunity. So they try to use a reference and try to patch that. So that is the basically visibility we have from the mean, and proactively by which we can able to apply the controls. So threat is the most important factor we have that we need to understand. I'm sure these pointers are basically clear to everyone. Now we're moving to the next part, which is basically called as a vulnerability. So vulnerability is a weakness or a gap in a system that can be exploited by the threat. It is a flaw that make the asset susceptible damage. See, one thing what you can do is you can control vulnerability. You cannot control threat. If anyone want to do attack, they will do attack. It is your weakness if you react to that. I'll give you one layman example. So there is a one person, my relative, okay. So he has a weakness that, okay, he cannot say no to anything. Okay, so there was my relative, so he cannot say no to anything. So that is his weakness. Now threat was, there is a one in-laws or there was a one family member who basically bring a marriage proposal. He said, do you like this girl? He cannot say no because he has to study, but he's having a vulnerability. He has a weakness. He cannot say no to that. So here, the intention of this uncle or intention of this auntie was successful. So they basically get the marriage of the person with that girl, or vice versa. So here what happened, the uncle or auntie who basically coming with a marriage proposal are the threat. And they can be successful targeting that particular person if having a weakness which can say no to that. If we say no, then it's not a vulnerability. But they use this as an opportunity because they know very well they will not say no to that proposal. So vulnerability is basically a weakness. So if you're understanding from the perspective of non-technical, like we continuing with the house analogy, vulnerability could be unlocked door or open window where thief can basically use to access, right? So that is basically called as a vulnerability. Now, if you basically take a perspective, so let's take example, we have a house here. So this is basically the house. Okay, so it having an open door. So the thief can use this open door to attack. So for a thief, it is an opportunity. Okay, and he using his skill, which is called method, by which he penetrate into the house. So we cannot predict when they're going to attack, but we can able to control what is a weakness we have. So we should close the door and all that. That's a important part we have. So if you see the technical definition of the vulnerability technical definition is outdated software, okay, weak password, which is persist in the asset. So that is basically called as a vulnerability. Now the third part is basically we need to understand the risk. Okay, so remember one thing, action is equal to threat. What we can see in the asset is the vulnerability. Is it clear? What we can control is the vulnerability to patch. But what we cannot control, that is called threat. We can predict, but we cannot control, okay, tomorrow do the attack or day after tomorrow do the attack. You do attack, it's okay. But I have a vulnerability. if their vulnerability is there, they can able to exploit. If there's no vulnerability, they cannot able to exploit. So we're putting a control to patch the vulnerability, not a threat. Okay, so let's move to the next part, which is called as a risk. Now with the same context, if you can see, risk is the potential for a loss or damage when threat exploit vulnerability. Okay, risk is a probability. Risk is not something which is already occurred. So we have two things here. One is basically called as an incident, and one is basically called as a risk. The thin line difference is risk is a incident is a confirmed action. Okay, burglar attacked and steal data or steal assets. So it's already done. It's an incident. But if you don't close the door, if you keep the window open, there is a possibility someone can attack and they can take your asset with you. So that is a risk. Risk is a probability. So when sometime what happened, we learn the lesson from our neighbors. Oh, they have opened the door, that's why thief came and they attacked. So we use this opportunity, we use this information, and what we did proactively, we close the door and we close the window. So risk is the potential for a loss or a damage where threat exploit the vulnerability. It is a likelihood of a threat taking advantage of vulnerability and impact it would we have. So let's take an example. We have a server here. Server basically have a weak password. It has an open vulnerability. So what hacker did, hacker tried to exploit this vulnerability. Okay, hacker is an action which is a threat actor who performing an action to exploit the vulnerability by which they gain access to the system. By gaining access, he steal data. That is the loss I have, and that is basically risk. Okay, the loss I face from the attack, the loss which I see as a company, that is a risk which I don't want to lose. Understood? So that is a pointer we're trying to understand here. So risk is basically the possibility of the hacker exploiting a software flaw to access and steal sensitive data. Okay, and that potentially lead to the financial loss and reputation damage. That is the risk I have here. So with the context of information security or normal thing, threat is a burglar, vulnerability is called as an unlocked door, and risk is chance of burglar entering to the unlocked door and steal valuables. That is a loss I have. So if you want to map with the information security, let's understand with the information security context. So that give you the better visibility. So threat is a hacker who want to steal sensitive data, which is an action. Vulnerability is basically a weakness, a outdated software application with known security flaw. Anything with the asset is a vulnerability. Risk is basically the possibility of the hacker exploiting the software flaw to access sensitive data that lead to the potential loss. See, this is the definition of the possibility of hacker is a threat. Exploiting a software flaw is a vulnerability. If they do, what is the impact? Impact is representing as a risk. It is a financial loss. Okay, so that is something is basically here. Okay, so that is the impact we have. So we know, okay, there is a possibility they hack my server, they can steal data. There is a possibility thief attack my house, take the asset. Okay, we know there is a loss of asset, but actual, what is the value of the loss? How much I'm going to lose? Example, if I'm fail in the exam, I lose 750. That is a risk I'm taking here. So I need to know exactly that particular value of the loss. I know there is a loss, but I want to know exact loss. So we have a formula to calculate the risk. So let's understand the formula. So when you're talking about the formula is likelihood and impact. So if you see the formula of a risk, we calculate like risk equal to likelihood and impact. So what is likelihood? Now, if you go by the definition, it refers to the probability that given threat will exploit the vulnerability. It means we're talking about chance of occurrence. Okay, so that's why we say it measure the estimate that occurrence of an event. That is called likelihood. And impact is basically refer to the potential consequences of a damage resulting from a threat exploiting the vulnerability. That is called as an impact. Okay, so let's understand with the example. So we have a server here. So we have a server. Okay. For example, if you have a server, which is a website, okay, if it's not updated, if it's outdated, okay, and it is configured with the common vulnerability. Okay, so hacker basically have a higher chance to exploit that. So this is called as a likelihood. Okay, if there is a known vulnerability and their information is available outside, So there is a higher probability that hacker can able to exploit that. So likelihood is basically high. But if it happen, okay, does it have a PII data? Yes. So even if he hack one time, he might access to the PI data, which is the biggest loss for the company. They might face regulatory issues. So impact is basically from that activity. What is the impact? What is the severity it will occur? Okay, so if hacker exploit the vulnerability, the impact would be on what the hacker could do. If he could access to the sensitive customer data, the impact would be high because of the potential of data theft, privacy breach. So there is a formula called likelihood. So chance of likelihood is suppose one time in a year. Here, how to calculate the likelihood? Because likelihood mean what is the probability of attacking that. So here your experience matter, your past data matter. If you're doing for the new project, we always keep the likelihood 1. So for that also we create a table. Okay, impact we know, if a target, I might lose this data. So same like, let's take example of CompShare security plus exam. What is the probability of questions coming in the exam? Can you predict? No. So it's based on experience with a mentor. You ask mentor, so how important is the domain 1? It's very, very important because most of the question you can get from domain 1. So likelihood of the questions coming from the domain 1 is high because threat here is questions. And those questions which basically exploit your weak areas. And if you don't answer, the impact is basically you lose your $250 or $300, whatever the impact is there. So here, in this case, the impact is basically all about the loss. So when we're talking about impact as a matrix, okay, measure the estimate the consequence of impact. So here we have a combination formula is we're trying to quantify, okay, 0.3 is a probability of happening. But even if it happens, the impact value is $10,000 or $1 million. So overall value is coming is $30,000 is a risk. So that's something we have calculated. Is it clear? So this data, it's completely based on experience, based on your knowledge, based on the data, past data and all that. Like in the past, this is how activity happened. So let's take example, if the server connected with the internet, we have a higher likelihood. But if the server is a part of the internal network, we have a less likelihood. It's come with experience, okay? What is special about this kind of a video is, it basically come with a question. So let's discuss some coffee shots to understand whether you understand the topic or not, okay? So which of the following best describe a threat in the context of cybersecurity? Option A, software bug, but that is a vulnerability. Individual event potentially cause harm to system, that's an action. Security measure implement to protect data, that's a control. And technique used to recover lost data is a control. So answer is basically B for beta, because B is talking about the action. Let's go with the next coffee shot. What is a vulnerability in the context of cybersecurity? Strong password policy is a control. Unpatched software flaw that can exploit, yeah, makes sense. Method of preventing, that's encryption. Comprehensive backup solution is a control. So answer is basically B, unpatched software flaw, because that is a persist in the system. Third question, how is risk defined in the cybersecurity? Option A, amount of money spent on security measure. Potential for loss or damage where the threat exploit the vulnerability. Option C, process of identifying mitigating risk, threats. And D is implementation of firewall. So D and A is the control part. C is only talking about threat. The answer is basically B. Okay, so first, what is attack surface? If you see the definition, it will say attack surface refer to sum of all the different points, the surface where the unauthorized user, attacker, and try to enter data or extract data from the environment or do the attacks. So let's understand with the example. Let's take example, we have a system A. Okay, so this is basically my system A. Okay, now in this system, we enable two ports, port 1, port 2. Okay, and we have a port 3. Then we have a system B. Okay, so we have a port 1 and port 2. And then we have a system C where we have a port 1. Now when we talking about surface, okay, so here we have 3 opportunities. So attacker basically have 3 opportunities by which he can able to penetrate into the system A. Okay. In the case of B, he basically have 2 opportunity by which he can able to penetrate. And here he basically have one particular port through which he trying to penetrate. So here what happened? Simple logic is if you increase the functionality, Simple is, if you increase the functionality, okay, you're actually also increasing the surface to exploit. And if you decrease the functionality, you basically decrease the attack surface. That's a simple principle rule. It is same like when you go out, you're wearing a mask and all that, it's extra protection. But if you don't wearing a mask, okay, and here what happen is you don't cover up things and all that, and you expose everything. So that is basically invite the opportunity to attack. So attack surface basically play a very important role in the information security, how you basically plan, how you plan things and all that. Now, second example is we have a system A, which is basically connected with the internet. So you're more exposed to the internet. So there is a chances through the internet they can do attack. On the other side, we have a system B, which is part of an internal network. Or here you can see system B. It is part of an internal network. We have a firewalls and everything as a security control, not as a functionality. So it is difficult to do the attack surface, or it is difficult to do the attack. So attack surface is basically very important to prioritize. See, it's not our intention, okay, we have to increase the functionality to so attacker can able to launch. No, we increasing a functionality because we want to give freedom to the user. We want to provide the services. Okay. Businesses always start with the concept of balancing the security versus functionality. Okay. If you see the hierarchy, let's say example, airport. If you take an example of airport, we have a 2 level of security checks. So here we have one security check and then we have another security check. So if you see from the first gate, they only check tickets and everything, which allow you to go inside. They cannot do the deep level of inspection on the gate 1 because it will create a huge queue. But after collecting a boarding pass and everything, you go to detailed security check. And here they have a detailed security inspection. They're okay to compromise functionality, but they cannot compromise security. So that is how the example look like. So if you see the first gate, they do high level check because of functionality reason. They want to pass the candidate. So there is a possibility anyone can do attack. But that is the reason is they have a second layer of check, which is called a detailed check. There is an impact of functionality because for them, they don't want to leave any new attack surface. So attack surface is an opportunity we try to exploit. Now, attack surface is like a total exposure of a system to potential attack. And the broader the attack surface, the more opportunity the attacker has to exploit. That's why one of the key responsibility of the security professional is to reduce the attack surface. So there's a quiz we have. Okay, so we have a system A. I have installed the Windows. Okay, and then I basically install the VMware workstation, and then on top of it I basically create a machines. Along with that, I'm also installing some other machines. And this environment 2 is basically we have a server, and directly I basically deployed the ASXI, and then on top of it I basically create a machine. Now you tell me in the comment box which attack surface is bigger. So in this case, attack surface bigger is 1 because we have a functionality here to exploit. We have a functionality here to exploit through which we gain access. But in this case, we just need to protect this. My end goal is to protect this because if I protect ASXI, I protect the entire infrastructure. So more functionality, more cost. So according to that, you need to prioritize. Is it clear? Now, attack surface is basically varies. So we have a different type of attack surface. So first is called as a network attack surface, which include all the network points through which attacker can potentially enter. Again, it is depending upon what kind of a ports are open. So suppose this is basically my server and this is basically a firewall. If you allow more ports to be traveled through this particular network, so attacker will use those ports through which they can try to enter. So example like open ports, what kind of a rules we create in a firewall, what kind of a network protocols you have allowed. Let's say example, this is the website and we basically allow port number 80. Okay, we allow 443. Now attacker has an option, either he can exploit through the port number 80 or 443. Okay, if other unnecessary ports are open, they can also exploit that. So that's why we say keep things simple. Whatever the ports you need to allow, you can only allow, rest you can block. So by this way, you can able to focus on the quality instead of quantity. Sometimes firewall was configured with only basic rule like source is any, destination is basically a web server, source port is any, and destination port is 80. Hypothetical scenario. So there's a traffic coming from source any and destination is going on port number 80. That is possible. Now, but the question is that what kind of a content he carry on that port. We are not doing the inspection. So when we allow more functionality to pass the traffic, because if you basically implement too much inspection on the firewall, it will impact the performance. So we let them to pass more and more data. So in that data, what happens is they don't inspect the content, and that is an opportunity attacker can use to bypass the network. And that is why we say keep things simple. Now we have attack surface on the software level. Okay, so we have a web server, the same example. Okay, it running with the 3 vulnerabilities. So attacker has a 3 opportunity to exploit. So this is called as a software attack surface. This consists of software running on the system, such as operating system, application services. So a web server must be up to date, and any vulnerability in server could be exploited. Or the code is basically running on the web application could also have a bug. So attacker can able to exploit that bug and gain access. So no matter you have protect everything on the server, but the application which is running on the server, it has a bug. So attacker exploit the bug and gain access. Or entire thing are secure, end to end, everything has been tested, but you downloaded some drivers and libraries. And that basically bring the exploit. That basically bring the vulnerability. So the application might use third-party library or framework can have a vulnerability. So that is called as a software attack surface. Okay. And third is basically called as a human attack surface. Human attack surface mean attacker might target the end user. Now, let's take example, there is an employee who have not attended the security awareness training. So he is not aware about, okay, what links to be click or what links to be ignore. So attacker basically uses opportunity and he send the phishing email to those users. So that is called as a human attack surface. Okay. Or you can have a developers, they have not been trained on how the secure coding done. So because of the stupidity, they write some code which can bring attacker opportunity, or administrator could trick into misconfiguring the system or inadvertently installing a malware. So these are the opportunities we have that attackers basically use to target. Okay. Social engineering and all that. So question is how to reduce the attack surface. So keep the software OS up to date and install which is relevant, because more you install, more opportunity you basically bring. The second thing is that from a network security point of view, disable all the ports which is not required, have a proper network segmentation. So let's say example, if you're planning for a network segmentation, suppose this is your network we have. You can have 3 servers here. If you think these servers are internet exposed, if you think these servers are internet exposed, so you can only install the internet exposed servers, like it can be my web server. Okay, you can have a DNS server, because these are you want on an internet, and those are internal to the organization. Keep it in the other network which is protected by the firewall. Example like database, Active Directory and all that. So we can have a basic rule in this firewall. All traffic by firewall can access this, and that's the work done. If someone want to hack into the internal network, he has to pass through layer of security checks. So that's how. So whatever the critical server public facing, you can keep it in the DMZ, and whatever the sensitive we have, we can keep it in the internal network. So you can have a network segmentation by which you can reduce the attack surface. Then we have a secure coding practice, like regular code review, implement proper authentications and all that. And on the human level, we can have a proper trainings and all that, make them more aware about the attacks, threats and everything. And we can also enforce a strong password policies. So that's something you can do. Now the question is basically, by doing a monitoring also, you can able to track this particular functions. You can see the deviation, and according to that you can able to patch. So these are basically the functions we have, controls we have, by which you can reduce the attack surface. Now let's understand whether you understood this topic or not with the question. Which of the following best describe the strategy to reduce the network attack surface of corporate network? Option A, implement robust password policy and educate user about phishing attack. It is more directive control. Even you basically implement the policy, what is an assurance people will follow that? Option B, closing the unnecessary port using a firewall, segmenting a network into the smaller isolated subnet. That is something more relevant to the network attack surface. C is called as a regular updating antivirus software on all the endpoint and conduct routine vulnerability scan, but that is more from an endpoint security. And option D is installing the IDS to monitor network traffic for suspicious activity. D makes sense, but D is part of a B. That is the reason answer is basically B for beta. Okay, so let's start. So when we're talking about phishing, first let's understand the word phish. What is phish? Phish actually is a verb that mean to trick an internet user into revealing the personal or confidential information that can be used illegally. So phish is the word, and ing is basically we use together. So phishing is a type of cyber attacks that combine the social engineering and spoofing technique to trick individual into providing the information. So let me explain you with the example so you get a better visibility. Let's say example, this is my friend. Okay. Now there is a hacker. What he did, he basically spoofed my name. And along with that, he also spoofed my email ID, prab@gmail.com, hypothetical scenario. Okay. So spoofing means impersonating someone else, someone else. So hacker basically hacker is impersonate my email ID to convince my friend, this is the email. This is an email coming from Prab only. So he prepared one email. We have a lot of websites which give you the option of, using any sender email address, receiver email address and all that. So he used or she used my email ID. So that is called spoofing. And he create a sense of urgency in the mail that, okay, hey, I'm in a need of money and all that. Definitely my friend, when he received an email, he saw the mail, and in the mail, it is talking about account number and everything. And based on a trust of the content and the email ID, because it is he transferred the money on his account. So this is called as a phishing. So phishing is the technique, okay, by which we perform some illegal activity. But the base of the phishing, we receive a phishing email, lottery email. You won the lottery from IBM. So IBM is a name has been used. That is called as a spoofing. And instruction, sense of urgency in that if you don't process this application in 5 hours, then you will lose this money. So that's called social engineering. Okay, so phishing is a type of cyber attack that combine social engineering and spoofing technique to trick individual into providing a sensitive information. This phishing as a concept came from a fishing. We go for fishing. So we put food in the ocean so we can catch the fish. So here the food is a form of something like a advantage and something like a sense of urgency we create. Like lottery is a food for the individual. Money claim is a food. Okay, emotions is a kind of food. So here they try to trap my friend with my name, and they also create a sense of urgency. And through that, based on a trust, the person has basically processed the things. So when it comes to phishing, so we have two key characteristics of phishing is, one is social engineering. That is the one thing we have. The attacker exploit the human psychology and creating a sense of urgency or trust to manipulate the victim into taking a specific action. And spoofing is attack, create a fake website, email, message that appear to be from a legitimate source. Now, when you're talking about the phishing aspects, one thing we need to understand, we have a different type of phishing tactics. Tactics basically mean technique. So first is called email phishing, where someone spoof my email address and send an email to my friend and all that. Hey, this is Prab. I'm in a need of money. Please transfer the money on this account. That is called as an email phishing. So we send by email. Second is called as a website phishing. Website phishing is, I will design one website which is look like one banking website. Okay. And I will convince the user, visit this website, okay, and use your net banking credential and process the fund. Okay. So that is called as a website phishing. Let's say example, there is a betting app is there. Hypothetical scenario, there is a betting app. Or there is a gaming website. It look like a real gaming website. You need to enter username, password. You need to enter the credit card, debit card information. So they enter that and that steal their information. Or it is like a copy of gmail.com. So it look like a Gmail page. You enter your username, password, but in the backend they have their own database and they collect the information. So that is called as a website phishing. So we have a two type of phishing. One is sending an email and collect the information. Website phishing is basically we send the email, but in this email, or we do the marketing. On Google, we do marketing. Hey, Gmail has launched new offer. Register yourself to claim this offer. I'm sure you have seen such kind of ads. So we redirect them to one fake website where they submit the username, password, credit data, credit cards and all that. That is part of website phishing. Nowadays for the we are using this for trading also. Like, if you want to do the trading, international tradings, and if you want to earn money, if you want to double the money in 100 to 200%, you can visit this page, process your fund, and we will double the money in 50 days. So that website is a fake website which collect your information. That's called website phishing. Now, when we're talking about the phishing perspective, we have a different type of phishing types. Now, first is called as a wishing. Wishing is like, one day, so nowadays it is a very common thing happen. So there is a hacker. Okay, he called my uncle. Okay, and he said, I'm calling from the telecom company. In 30 minutes, we will block your number. So phishing is a phishing conducted over the phone. So attacker use phone call to impersonate legitimate organization like bank, government agency or tech support. Or, hey, I'm calling from a bank and congratulations, you have claimed the lottery. To process that, you need to process one application which costs you only 500 rupees. So the person in excitement is okay, 500 to claim 5 lakh, it's okay. So go to UPI, enter the details. I will tell you the number on which you can process the 500. So that is called as a phishing. It means over the voice, over the call, try to trap or create a trap for the individual. That is called as a phishing. And today, if you see the modern phishing attack, it has happened through phishing only, at least in India. Now, how it works is attacker create a sense of urgency, such as claiming there is a problem with your bank account and then ask for the sensitive information from your number or social security number. It was one of the common attack in US. Lot of people, I'm sorry to say that, but a lot of companies from India, a lot of companies from Pakistan, Bangladesh, Sri Lanka or Philippines, a lot of countries, they set up the fake call centers and do the calls to US, and they tell them we are calling from tech support team, and we can see that there's a lot of issues in your operating systems. To process this operating system, you have to make the payment. Okay, so this is how over the voice call they try to trap for the credit cards and all that. That's a live example how the phishing has been done. So you receive a call claiming to be a bank fraud department, asking you to verify account detail by to prevent the unauthorized transaction. So in that case, in hurry bari, you might share your credit card or debit card information. That is called as a phishing. Now we have a smishing. That is also new tag. So smishing is phishing carried out by the SMS. So attackers send a message that appear to be coming from legitimate entities. Hey, I receive one day one message, not on WhatsApp, message, directly telecom messages. This is a message from the e-trading company. We have opened a new services where if you open the account, you can able to convert double the money size and all that. So I receive a message, which is a very lucrative message, to open the link and claim your things and all that. Or we will send you some Google, YouTube links. You have to like and you have to comment, so that every week we will process the money. So that is the example of smishing. So over the SMS, I'm not using email now because most of the people don't have emails. Okay. So they are targeted by their SMS. So SMS is a smishing, is a phishing carried out by the SMS. Attacker send a message that appear to come from a legitimate entities, prompting the victim to click on the link or respond with the personal information. That is called as a smishing. So how it works is message might include the link to the fake website or instruct the victim to call a number to resolve the issues, where the further social engineering attack take place. So example is you receive a text message from what look like your bank saying there's an urgent issue with your account and providing link to fix. So they will send now link over the SMS. So question is how to protect. That's a very good question. So first is called be skeptical of unsolicited communication. Why I've highlighted in bold, because if you basically focus on this metrics, you can able to handle 95% of the attacks. Be skeptical of all the unsolicited communications. Unsolicited communication means unexpected or very suspicious. So if you're receiving any unexpected email, call or text asking for personal information, be cautious. If you're receiving any email, nowadays we have a new concept of phishing is called deepfake videos, where they try to make a video of your partner and sending you the video. So directly call the person and confirm, is it you or someone else? So legitimate organization typically won't ask for any sensitive information this way. So that is the one thing. Second is verify the source. Don't click on the links or download attachment from unknown or suspicious source. If in doubt, visit the organization website directly by typing the URL into browser or contact them using an official phone number. That is called as a verify the source. Third is look for red flag. Phishing messages often contain spelling errors. Okay, domain names. Let's say example, domain is apple.com, GOGLE.com. So look for the red message, red flags, dear customer, sense of urgency, be alert. Okay. And last is use multi-factor authentication. Like in our UPI in India, even you're doing a payment and all that, first it asks for the 4-digit PIN, then it asks for a 6-digit PIN, or when you click on any kind of a phishing link and all that, it redirect to reset the password, ask for the OTP. So even if attacker obtain your login credentials, okay, MFA basically add the additional layer of security that make it harder for them to access, and make sure in every 3 months reset your password and keep your software updated, because Some softwares, DLPs and all that can able to prevent such kind of an attack. But most important part is be skeptical of unsolicited communication. 3 things remember. If you're receiving any call from telecom unit, they say we're going to block your number in 30 minutes. That is a spam. If anyone saying I'm calling from CBI, spam. If anyone saying you have won the lottery and this is the money, spam. So be skeptical of unsolicited communication. That's the most important part we have. So let's understand whether you have understood this topic or not. Let's understand with the concept. You receive an email from what appear to be an email provider warning you your account will be deactivated unless you verify your password within 24 hours. The email include a link that look likely to the provider login page. What type of attack is that? The keyword is email provider. So definitely it is. So what is the difference between phishing and spear phishing? Phishing is basically mask. Like I am sending an email to everyone. Spear phishing is particular company. Like my target is IBM. My target is a particular company, ABC company. So I'm sending an email to all the employee of ABC company. That is a spear phishing. Okay. Then we also have a whaling attack. So whaling attack is like a method used by criminals to spoof senior members of an organization, directly target the other people. Okay, I'm calling as a boss, your manager and all that, what you're doing, please share this information. So that is called as a whaling attack. Okay, so their objective is to steal money or sensitive information, gaining access, and they target also a senior people. So spear phishing is complete, but whaling is the senior people of that company. Then tailgating, like we request them punch the card, so we try to enter under the permission. That is called tailgating. So in this case, answer is phishing attack. Okay, phishing attack. Let's go for the next question. Company employee receiving a phone call from someone claiming to be an IT technician, asking for the employee login credential to fix a network issue. The caller ID show company internal IT support number, but employee feels something is off. What type of attack is that? If the question has a number, so answer is phishing, because someone is calling and try to convince him. So that is called phishing. Phishing, voice, over the voice. Phishing is not. Baiting is something like, asking some information and gain access. Pretexting is like having some information based on that, create a scenario. That is called as a pretexting. Okay. So close answer is basically A, phishing attack. Next is you receive a text message claiming to be from your bank, starting that your account has been locked due to the suspicious activity. The message instructs you to click on provided link to verify your identity, unlock your account. The URL is the link look like to your bank official website, but slightly different. So here they say your bank, you receive a text message, not an email, text message. So phishing is basically over the voice, phishing is over the SMS, phishing is over the mail. Credential harvesting means hunting for the passwords. So only close option we have is B for beta, smishing, because keyword is SMS, text message.
Team, welcome to my session on Coffee with Prab, and today we're going to discuss about cryptography fundamentals, which is symmetric and asymmetric. I made this video in such a manner the person with the basic IT can able to understand that. Who am I? My name is Prab Nair, and for more information you can refer my LinkedIn profile. If you're new to my YouTube channel, click on the subscribe button and bell icon to make sure you should not miss my future videos. Without wasting your time, let's move to the next part. Thank you. So when we're talking about cryptography, let me first explain you the basic fundamentals of cryptography. What is crypto and what is graphy? So crypto plus graphy. Let me split that. Crypto means secret. Okay. Secret mean encoded, unreadable. मुझे नहीं पता क्या होगा. So what I did, I spoken in Hindi. Now those who don't know Hindi, for them it's a secret. But those who know Hindi, they can able to understand what I said. So for the people who are not a Hindi listener, they will not able to understand. And my goal is to make sure that this information only available to the authorized user. Okay, so I spoken in a language which can only known by Hindi. So this is called as a secret text, encoded text, unreadable data. And graphy is called as a science of writing. Science of writing. That's why if you see the definition, it says science of writing data. Science of writing data into secret text is called cryptography. Now in cryptography, we have some basic terminologies. The first terminology is called as a encryption. It means it is a process itself which convert the data from plain text into the unreadable format, which is only and only available to the authorized user. As I said, this is me, which is Prab. And this is my friend whose name is Manish. My best friend, you can say like that. He's my lovable friend. So I always use this example. So what I did, this is my text we have. Okay, and now we have some set of 70 people here. They knows English only. So what I did, I convert this text, which is an English text, into Hindi. And I told Manish bhai, I'm sending you some data. Okay. And I mention in the Hindi because if I pass through the 70 people, they will able to understand. So I converted it into Hindi. So when you receive, you read that. So you'll get to know what I want to convey. So what I did here is I convert the English into Hindi so that only Manish can able to understand. This process is an encryption. Okay. A technique by which I convert English into Hindi. So from the information security point of view, you can say like that. It is a process by which I convert the readable data into the unreadable format so that only authorized party can able to access. In this case, Manish can only able to understand because Manish know in that group Hindi. But decryption is a reverse process where we decrypt the encrypted text or unreadable text back to the plain text. The representation of the readable value that is called as a plain text. Here the English was the plain text. And encoded value, unreadable data, that is basically called as a ciphertext. Okay. So this is the high level process or terminologies that we used in the cryptography. Now before moving ahead, let me give you very basics overview of entire element that we're going to cover. Now if you take example here, if I say cryptography, crypto plus graphy, it is actually divided into two parts. We have a modern cryptography and we have a classical cryptography. If we're talking about the modern cryptography, we have a two type of modern cryptography. One is called as a symmetric and one is called as a asymmetric. But when you're talking about the classical cryptography is basically two type. One is called as a substitution and one is called as a transposition. Actually, classical cryptography is more like an encoding concept. And modern cryptography is more like a core encryption. Now let me explain you the thin line difference between encoding and encryption also. Now when I say encoding, this is my text we have. Example, this is my text money. This is my plain text. I use one encoding language. I convert M into B. I convert A into H. I convert N into D. And I convert I into A. Bada. So I replace character to character. That is called encoding. But in the encryption, what happens is we have a plain text called money. And that will be converted into binary. Then, so this is my plain text. Now we need a key. Key is the logic. Sorry, key is the factor. So key is like a passcode, capital P A $$ W0RD example, which will be converted into binary. Then between that we do the XOR. just giving example, and that value will be my ciphertext value. That is why encryption take more time than encoding. Encryption take more processing than encoding. So we are doing a changes in the binary level in the encryption, where in the encoding we introducing a changes in the character level. Coming back to the cryptography part, in cryptography we have a two important component. One is called as a key and one is called as an algorithm. One is called as a key and one is called as an algorithm. So key is called as a factor. An algorithm is called as a logic. Let's take example 1. And logic I use plus. I'm using one base language here, which is like a alphabets. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So this is the alphabet I use. So when I use in a classical cryptography, what I did, I use key as a 1 and plus is a logic. Then I combine that plus 1. Because algorithm is called as a logic. English I'm using as an algorithm. But what is the phrases I'm using in the English to communicate, that is called as a key. Because key is the factor. I will show you the example. Now in the substitution cryptography, what happened is, this is my plain text called, let me delete that. Okay. Now I have a plain text which is called security. Okay, this is my plain text. And now I want a encoded text. So what I did, I use a plus 1. Substitution means using an alternate value. So we have a S, that is S. S plus 1 is T, because S after S plus 1 is coming as a T. So I use the T as a value. E plus 1 is F. C plus 1 is D. U plus 1 is R plus 1 is S. I, we have a I. Then we have a J. Then we have a T, we have a T, U. And Y, Z. So this is basically my encoded text. If you notice, if the key length is small, it is easy to find the pattern. Now instead of plus 1, I use minus 1 example. So we have a S, we have a S. S before minus R. So this will be the R. So in substitution, we are finding an alternate word. But when you're talking about transposition means trans plus position. Transparently, we're changing the position. How? S plus 1 is E. So E will be the first. E plus 1 is C. C will be the second. C plus 1 is U. U plus 1 is R. R plus 1 is I. I plus 1 is T. T plus 1 is Y. Y plus 1 is S. So this is how I use the transposition cipher. Okay, in substitution, we're finding an alternate word, but in the transposition, we're just replacing the character. So this is the high level summary of classical cryptography. But what we're going to learn in modern is a symmetric and asymmetric in my next slide. Now when you're talking about cryptography, as I said, encryption, decryption, plain text and ciphertext. In modern cryptography, we have two major components, a very, very important, which got enhanced. One is called as a key and one is called as a cipher. Another name of the cipher is algorithm. So key is a specific piece of information that is used in a conjunction with the algorithm to perform the encryption and decryption. If you saw in my previous example, plus and 1. So plus was the algorithm and 1 was the key, which is used together to perform the encryption and decryption. I told Manish, hey Manish, A plus 1 is B. So remember, so plus is the algorithm calculation with the alphabets and 1 is basically the factor. So one simple rule you need to remember with reference to the key, longer key produce the stronger encryption. Let's take an example. My key length is 1111. So it will produce the fixed output of 111 example. But if I have a larger key plus 2, 3, 5, 6, 7, so they will see the 2, 3, 5, 6 pattern and by which they basically form the key. That's why we say larger the key or bigger the key, more secure and more stronger will be the encryption output. Now I told Manish, okay, remember plus 73. So then they will calculate the plus 73 values and then it produce the output. But problem is that bigger key, higher key, bigger key size will produce the more secure output, but it take more time also. So whenever we selecting the key for the encryption, okay, we need to balance the performance and security. That's why we called as a key is the process which is used with algorithm to encrypt and decrypt the data. And cipher is called as an algorithm. Another name of cipher is algorithm, which is used to encrypt, decrypt the data. And there is a process called science of breaking the code or learning the cryptography algorithm or finding a weakness. And that process is called as a crypt analysis. A lot of company hire crypt analysis whose primary role is to discover the weakness in the cryptography algorithm, study the cryptography system so they can able to break it. Now there is a possibility like me running a cryptography solutions. So what I did, I hired the cryptography professionals and I told them, find the weakness in my system, find the weakness in my algorithm. So they tried to break my algorithm. How? The data which is encrypted by the algorithm, they try to break the data. They try to recover the plain text from the data. And then they will give me the report. Okay, by this factor we are able to break it. So we will add that information and make the algorithm more secure. So study of algorithm, process of breaking, that is called as a crypt analysis. Moving to the next part, we're going to cover about type of cryptography, which is called symmetric and asymmetric. Let's move to the next part. Okay, so symmetric encryption and asymmetric encryption. If you go by the description, symmetric key used to encrypt and decrypt the data. Symmetric key use the same key which is used to encrypt and decrypt the data. That is called symmetric encryption. And asymmetric is basically used two-way encryption that is used with pair, public key and private key. It means one key is used to encrypt and one key used to decrypt. Okay, so how it works, let me explain you. So let's start with the first part, which is called as a symmetric encryption. So if you read the description, it is clearly say that two-way encryption scheme in which encryption and decryption are both performed by the same key. How? Let's take an example. We have a system A and we have a system B. This is my data. So we got one key which is called as a, this is called as a symmetric key. Now we have a different name for that. We called symmetric key, we called session key, we called secret key. Okay, we called private key. Okay, so we have a different name. Or in your language, you can say this is a password. You can say like that. In a very layman term, it is called as a password. So what I did, A basically use his key plus algorithm to encrypt this data and produce the ciphertext. The same example I have shown you. It is same like, you have a WinRAR document and you protect the WinRAR document with the password, right? So here the password is called as a key. Okay, so key is suppose 12798. So this is the key we have, which is used with the algorithm to encrypt the data. And this is the ciphertext we produce, which is called as unreadable data. Now A sent this data to B. Okay, it is a encrypted data which is sent to B. Now B received the encrypted data. Same like if I protect the file with my password, you will ask for the password only. Now concern here is I have to send my key, the same key. So I sent 1
12798. So B applied 12798 by which and plus algorithm and decrypt the data. Okay, so that is why we use 12798 to encrypt the data and to decrypt the data. That is why today's symmetric encryption is used for the data encryption. Today, if you take an example of AES, you heard about AES on your browser, wireless AES. They all are symmetric encryption only, where we're using a same key to encrypt and decrypt the data. Now there is a one concern here. The concern is if you're sending the data and key in a same channel, this is called as a same channel. Now what happened? There is an attacker. He can intercept the encrypted data also, and he can intercept the key also. So by this way, he get the data also and key also. So that is why the biggest concern with symmetric encryption is the key exchange. Key exchange. And that is why they use multiple technique. One is called OOB, out of band. It means sending a key by email, sending a key in a hard disk, sending a key in a pen drive, or calling the person and dictate the key. Or the second process, they will use asymmetric process that I'm going to discuss in the next slide. So the primary concern with symmetric encryption is the key exchange. But today, primarily symmetric encryption is used for encrypting a data because it is faster in processing the data, because same key used to encrypt and decrypt the data. So when you're talking about symmetric encryption, we have a two type of symmetric encryption. One is called stream based and one is called block based. Now when I say stream based, example YouTube. Okay, so in stream based what happens, whatever the data we have, it is convert into binary. And whatever the key we have, okay, it is also convert into binary. So in the stream based encryption, it encrypt the digital data stream 1 bit or 1 byte at the time. It means they do like this way. So bit by bit stream is basically happen. Example, in my video, if I upload this video on YouTube and you're playing my video, okay, smoothly without any interruption, thanks to they using a stream based encryption. Okay, they encrypting bit by bit parallelly. Okay, bit by bit parallelly. Okay, bit by bit parallelly on the same time. So that is called as a stream based encryption. But when we're talking on block based, in block based what happened? We have a data here. Data divided into block 1, block 2 and block 3. And then each block is basically encrypted by the same key. And then we send this block. Now, if YouTube is using a block based encryption for the video streaming, so my voice will be like that. Hey guys, is that clear or not? So if you see, there's some interruptions because data was not something parallelly getting encrypted and decrypted. It is not something parallelly going bit by bit encryption. Data divided into block and each block is basically encrypted by the keys. That is why block based encryption used in that case when data resides somewhere in a storage. Okay. So stream based use in application, block based use in a hardware. So these are the two type of encryptions we have. So key exchange is a concern because same channel we are using. So we use the out of band exchange. Scalability is another challenge we have because for every user we need to have a unique keys. Example like this way. We have a system A and we have a system B, we have a system C and we have a system D. B, C, D. For every encryption we need a unique key. So imagine more and more hosts. Now B want to send data, he need to send his key. B need to send to C, he need to send to his key. So for every user, B need to issue the new keys. For every user, A need to issue the new keys to every user. So as more and more hosts increase, scalability become a concern. And we have some algorithms which support the symmetric DES, 3DES, RC4. These are the symmetric algorithms we have. Currently we're using AES, which is a replacement of the DES algorithm. The biggest reason of not using DES is it requires a lot of compute and all that.
And AES, which is Advanced Encryption Standard, they basically provide the better security and better functionality with better compute parameters. So that is the advantage we get when you go with the symmetric algorithm. AES algorithm, sorry. So I'm sure you get the understanding of symmetric. So how it works, symmetric algorithm in a real time, let me show you. Let me show you the practical demonstration of symmetric algorithm. Okay, so this is the practical demonstration. So I use this website called xcode.com. Okay, that is the name of the website we have, which I used in this reason. Now what I did, I'm going to type the message here. Hi, Prab. Okay, hi Prab. I use AES algorithm. This is the key we have that I'm using. This is the key which I'm using to encrypt the data. Let me try to perform the encryption. So this is the ciphertext we have. Okay, this is called as a ciphertext. So this is called as a ciphertext. Now what I did, I copy this and paste here. Sorry, I copy this and I paste here. Okay, now I will try to decrypt. So you can see hi Prab. So we have used the same key. We have used the same key to encrypt and decrypt the data. So I'm sure you get a visibility about symmetric encryption. So now the next part is called as a asymmetric encryption. In asymmetric, we use the pair of keys. Each pair consists of public key, which is known to others, and private key, which is only known to the owners. So that is what is called as a asymmetric encryption. So how it works, let me explain you. Now we have a system A and we have a system B. Okay, so we have a public key here. Let me draw it. So we have a public key A and we have a private key A. B also have a public key and private key. Let me draw it. So this time we have a two keys. Public key and private key. So now we have a data. So this is my data. Now A want to encrypt this data and send it to the B. So when I say public key is something which is known to other. That's what we share. And private key is basically may not be known by anyone except A. Okay. So A first request B public key. Then B sent his public key. A basically apply public key of B and encrypt the data. So this is the encrypted data we have. And then A send this encrypted data to B. When B receive encrypted data, he apply his private key, and by which we decrypt the data. Now if there is an attacker, suppose if there is an attacker and he intercept from here, he intercept here also, and it intercept here. So he got the access to the encrypted data. He got the access to the public key of B. Still he cannot do anything with that because he need another portion of a key which is called as a private key, which we don't share. So one key is basically used to encrypt and one key is used to decrypt. So this is how it works. That's why we use asymmetric encryption to exchange the symmetric key. Let me give you that example also. Now we have a system A and we have a system B. As I said, we have a public key A and we have a private key A. We have a public key B and we have a private key B. We always generate a key pair, okay? Now we have a data. This is my data. What I did here, we also have one more key which is called as a session key. Another name of session key is symmetric key. So now A have a 3 keys. Always remember in cryptography fundamental, sender generate the session key. Sender generate the session key. So here A is the sender and B is the receiver. A is the source and B is the destination. So A basically use the session key and encrypt the data. So this is the encrypted data A will send to the B. A sent encrypted data to B. Now B received the encrypted data. Problem is that now B need to decrypt. So in this case, B will send his public key. You know why? I will tell you why. So B sent his public key. The reason why, by this key only we decrypt the data, but A cannot send the session key over the network. So B will send his public key. A will basically apply B public key. A will apply B public key to encrypt the session key, because by end of the session key is a value only. And then we encrypt and send back the encrypted session key to B. Now B received the encrypted session key. B will apply his private key to find the session key, and then session key used to decrypt the data. That is how asymmetric is used with the symmetric. So summary is that symmetric used for data encryption and asymmetric is used for the key exchange. I'm sure this point is clear to everyone. One primary advantage with symmetric is it is faster because we're using the same key to encrypt and decrypt. But one primary disadvantage with the asymmetric is that slow, because one portion of the key used to encrypt and one portion of the key used to decrypt. Let me show you the practical demonstration of asymmetric encryption. Thanks to Khan Academy, they did the amazing job. So I'm using their website reference for this practical. Another name of the asymmetric cryptography is also called as a public key cryptography, because we're using a public key to encrypt, right? So this is the website called Khan Academy. Here we are generating a key pair. Okay, key pair. So we generate the public and private key. So what I did, I copy the public key and now I type hi prab. I click on the public key, I encrypt. So this is the ciphertext we have. Now what I did, I paste the ciphertext here. Now we have a private key here. I copy that and we have a private key. See, I got the same message. So you can see the size and all that, okay? So when you're talking about asymmetric, one portion of a key used to encrypt and one portion of a key used to decrypt. The biggest concern is performance and primary use for the key exchange. We have a different kind of algorithm like RSA, ECC. ECC was the alternate of RSA because it takes less compute to perform encryption. We have a Diffie-Hellman also. So asymmetric algorithm are used to encrypt the keys and symmetric algorithm are used to encrypt the bulk data. So this is what we have. When you're talking about the overall cryptography offer the confidentiality. Okay. It offer the integrity where the data has not been altered in an unauthorized manner since it was created, transmit and store. How? We're going to discuss in my next video. It also offers the authentication by which we verify the identity of the user or system that created the information. Authorization, those who have a key, they can able to decrypt. And by this performance, it able to achieve the non-repudiation where the sender cannot deny for his actions. So cryptography offers 5 major services. With the help of cryptography, we can able to provide the 5 major outcome of information security. So this non-repudiation, authentication, integrity, we're going to cover in my hashing topic, which I'm making soon. So this is all from my side. And if you find this video useful, do share in your network. And do let me know what is the best thing you like about this video. Another important thing, I want you to do one homework and let me know what is the thin line difference between the AES and DES and ECC versus RSA. Hello team, welcome to my session on Coffee with Prab, and today we're going to cover hashing and digital signature. If you're new to my YouTube channel, do subscribe to my YouTube channel and click on the bell icon to make sure you should not miss any videos which I'm going to upload in future. Who am I? My name is Prab Nair, and for more information you can refer my LinkedIn profile. So without wasting a time, let's start with the first part, which is called as a hashing. So first we're going to learn about hash function. So if you go by the definition, it is saying that cryptography hash function is an algorithm that take arbitrary amount of data input and produce a fixed size output of a text called as a hash value. And hash is a value created by the hashing algorithm. So again, it is written in a slide. So let me explain you with the reference. See, hashing is basically used to provide data integrity. Let me give a practical demonstration of that when I say integrity and how the hash play an important role. Suppose this is a food which I order from Zomato. Zomato is a food aggregator services in India. Now if you notice, this food package, whatever I order, it has a seal. This is called as a seal. Can you see that? This is called as a seal. This seal, so example like this is the restaurant, okay, who cooked food and placed that food in a box, and he then sealed that box with some tape and all that. And he just told a customer, which is me, that we have sent a food to your house. So now what happened? The food is carried by the food delivery guy and it is delivered to me. When I receive the food, I can see a seal on the food, like this kind of a seal. It gives me assurance that during a transit from this point to my point, no one has altered the food. And I receive the same state of the food which is packed by the restaurant. And that shows the integrity of their services. And how I verify with the help of this seal. Same like in data security, we need to provide data integrity. So if you take an example of the bank. Now bank sent me a statement. This is the statement, bank statement. And what they did, before sending a statement, they generate the hash value of the data. So what is this hash value? Hash value is the fixed value they generate for this data. It doesn't mean that, okay, they convert something. No. This is the bank statement we have, which is produced by the bank. And they generate, not convert, they generate one fixed hash value, a digest value of this particular bank statement. And they attach same hash value on the email and send it to me. They told me, hey Prab, when you download the statement, check the hash value of the statement and compare the hash value with the hash value what you obtain in an email. If both hash value same, it means the data came without any unauthorized modification. Because if you're getting a same state of value, you're getting a same hash value, it means data was protected from unauthorized modification. You haven't received any kind of a different data. Same like we have a Amazon. When you order something from Amazon, any liquid component, or when you buy something liquid component, Pepsi and all that, they clearly mention if you receive the product with a broken seal, do not accept. There is a probability during a transit they have opened that and mixed something, which is creating an integrity issue. So hashing is a function used to provide the integrity to the data. How? Suppose this is the name which is called hyperpub. So I use a hashing algorithm like SHA MD5, and with the help of that, it produces one fixed hash value. You don't trust me? Let me show you the practical demonstration of the hash. So this is the website called tool4noobs.com, and I type hi prep. I selected MD2 and hash this. So this is the hash value has been created. Okay. So it doesn't convert, it generates the fixed value of this data. Okay. Now what I did, I just remove H. And now you can see a different hash value. Now if you notice, by changing one bit, it changed the entire hash value. So when I received the data, they told me on the bank statement, on the email, this is the hash value of the bank statement. But when I scan it, I found this, I use the same website, or I use a hash calc by which I scan my data. And I found this hash value. So it means the data what I receive is not an authorized one. So this is how we can able to detect the unauthorized modification of the data. And that is basically called as a hash function. So hashing used to verify the integrity of a data such as email, download files stored on the disk. And we have some common example like MD5 and SHA. SHA is basically more secure because it providing me a larger length of hash value. Because if we have a smaller length of hash value, then it is a chances that, okay, two different data can generate a same hash value. Okay, high prob or high money can generate the same hash value because it is not converting, we're just generating. So that is basically, and that is a irreversible. Normally in the encryption, what happen if I convert high prob into something with the help of key, I can reverse back. But in the hashing, we cannot reverse back because we are not converting something. We're generating a fixed value from the data. So that is what is called as a hashing. So next topic, what we have is called as a digital signature. Okay. So digital signature are similar to the handwritten signature on a printed papers that identify user, but it is an electronic verification of the sender. Okay, so digital signature is a hash value that has been encrypted with the sender private key. If you need to understand this better, you must refer my previous video where I cover the cryptography fundamentals, because digital signature we can achieve with the help of asymmetric cryptography. Now let me explain you with the practical demonstration. If you saw my previous video where I discussed about asymmetric cryptography, so we have a system A and we have a system B. Both have their own public and private key. Public key and private key. B also have a public key and private key. If B want a session key, he will send his session key. So you can check my previous video. So in digital signature, what happens? Suppose we also have a C, we have a D, and we have a E. Okay, so we have a multiple systems here. Now what happened? Accidentally what happened? E, A, C, and D all have a common public key of B. Example. Because public key is accessible to everyone. So D use the public key, encrypt the data and send it to the B. C use the public key of B, encrypt the data and send it to the B. A will basically use the public key of B, encrypt the data and send it to the B. And E will use the public key of B, encrypt the data and send it to the B. And B will use his private key to decrypt the data. But my question here is, I want to verify the authenticity. I want to know who sent which data. Okay, and who sent this data. I want to verify the source because my key is accessible to everyone. So anyone can use the key and encrypt and send it to me. But I would like to know who sent this data, who sent this email to me. Okay, who sent me this data. I want to verify that. And that is why we use digital signatures. That is why, when you're signing up papers, documents and all that, they say, please sign here, please sign here. Tomorrow you should not deny that. And by the paper, we can able to identify the authenticity of the document. Same thing happen here. So when sender sending a data, he add a signature into that so that destination can believe it is came from a respective source. And that is why we use digital signatures. Example like if A want to send a data, okay, and he want to give assurance it is came from me. So this is the data which is basically generate. Okay, right now the time is in India is 9:55 PM IST. At this particular state, we generate this data. Okay, so A is saying that boss, this is my data, and for this assurance, I will generate the hash value of this data, which is a fixed value of the data. This hash produced by me only, I will encrypt this hash with my private key. And as you know, no one share their private key. So when you use the private key of A to encrypt the hash, it produces one DS value. I repeat again, private key of A used to encrypt the hash. It produces the digital signature value, and that is basically add to the data. And A send data to the B. When B receive the data, it has a DS value. So B use the public key of A to decrypt the hash. So by decrypting the hash with the public key of A, it gives the assurance to the B it came from the A. And then he scan the data and find the hash and compare this hash with this hash. By this, it achieved the integrity. So by this way, we achieve the authenticity also and integrity also. So this is basically called as a digital signature, where you're encrypting the hash with the sender private key. Digital signature, apart from providing the solution, it also offers other things. Okay. If the recipient means receiver of a digitally signed email can be decrypt the hash, it provides the 3 security benefits. First is called as an authentication. I have already demonstrated you practically that when I receive an email, I decrypt the hash value of the email with the sender public key. So by this way, I can able to verify from where it came, right? So I can able to validate that. And no one share their private key, so it give me the assurance. Second is, now if it came from the sender, I able to verify. So in that case, sender will not able to deny. Now example, you are the sender and you send me the data, which digitally signed with your private key. So you cannot deny on a later stage that it was not me who sent the data. Come on, this data is now decrypted. This hash value now decrypted with your private key. Okay. One more example I can give you about the non-repudiation is basically like, imagine we have Amazon. So Amazon sent an order to sell a stocks using a digitally signed email. If the stock increase after his sale complete, he cannot deny the transaction because it is added with the digital signatures. And that digital signature is basically generated from their private key. So that is why, see, the proof I have the DS value, which is decrypt with the public key, that is an authentication, which is / called as authenticity. And because of that, the sender cannot deny for his action. That is called as a non-repudiation. And along with that, I'm able to achieve the integrity already, because when I generate the hash, I check the hash to verify the integrity of the data. So digital signature provide the authenticity because there's a unique piece into that by which we can able to identify who sent this data. And when I'm able to verify who sent this data, the sender will not able to deny for the later stage because I'm able to decrypt with his public key. That is called as a non-repudiation. And third, by the hash value, I'm already validating that point. That is called as a integrity.
And today we're going to discuss about what is PKI, public key infrastructure. It is a very important topic today in network security, very important when you're preparing for any certification exam. There's a lot of content is already there on PKI, but no one talk about why we need a PKI. What is the reason this PKI was introduced? What is the limitation it's addressed by the PKI? So PKI stands for Public Key Infrastructure. My name is Prab, and for more information, you can check my LinkedIn profile. If you're new to the channel, do subscribe to my YouTube channel and click on the bell icon to make sure you should not miss the future videos on a similar topic. So without wasting a time, let's start with the first part. Thank you. Okay, so what is PKI? PKI stands for Public Key Infrastructure. Before I start with the PKI, I highly recommend to check the video in the description box, which is talking about symmetric and asymmetric encryption, because it is very important for you to understand. So I'm skipping the symmetric encryption. I will first cover the asymmetric, because from this diagram you will get to know why PKI was introduced. See, when we're talking about asymmetric encryption, so we have a system A, we have a system B. So in asymmetric encryption, we have two keys, public key and private key. So A has a public key and private key. B has a public key and private key. Now if A want to send data, so this is my data encrypt with the session key, data encrypted with the session key, and we send the encrypted data to B. Now when B receive the encrypted data, okay, definitely he need a session key. So here what happened, B sending his public key. So A apply a B public key to encrypt the session key and send the encrypted session key, and B use the private key to decrypt the session key, and then session key used to decrypt the data. So this is how asymmetric work. Now here the challenge here is, let me take the diagram example. So here the challenge is, if there is a hacker. Now listen this carefully, okay? Here is a hacker. Hacker hijack the session. So when B sending his public key, attacker hijack that and he send his public key to A. So A was an impression, the key coming from B. Because there is no centralized verification, identity and all that. We are sending everything on the internet. So B, when he's sending a public key, he hijacked the session and he sent his public key to A. So A was an impression, this is the public key of B, but reality it is a public key of hacker. And with the help of that key, he encrypted the session key. And he sent back that session key. So hacker hacked that, he got the encrypted session key. As it is encrypted by his public key, he will use his private key to decrypt the session key. And further session data, whatever it sent by encrypting with decrypting, it was get decrypted by the same session key. So that is the reason we introduced the PKI concept. So now what happened is, we have a client A. Okay, we have a system B. And here we introducing one more server, which is called as a PKI server, public key authority server, which is called as a CA, certificate authority. Now listen this carefully. So now B send his public key to CA, public key B, and CA will generate one certificate. So public key is add in a certificate. So right now time is suppose 2:15. At 2:15 the certificate was generated. Okay, so this is basically called as a hash value. It gives the assurance about the integrity of a certificate at 2:15. When certificate was with me, this is the current state of data. And this certificate hash generated by me, it is encrypted with the CA private key, which add the signature. And CA basically send back the certificate with signature to B. Now same process, A generate the session key. The session key encrypt with the data and send encrypted data to B. Now B need a session key because then only he can able to decrypt. So B this time send a certificate instead of sending a flat public key. So he sent a certificate. So now what happened? A maintain the public key of his trusted CA. So when he download the certificate, he first verify the signature of the certificate with the public key of CA. Or, we maintain the public key of CA. If signature is verified, then only from the certificate, he will extract the public key of B. And then he use the public key of B to encrypt the session key. So only thing we introduce here is extra independent server, a third party server, because A trusts CA, B trusts CA. So let's take one very layman example. You have a information security knowledge. I have a information security knowledge. Okay. Now you are looking for a CISSP training, or you're looking for the CompTIA Security Plus training. The first factor based on which you evaluate me, whether I have a certification. So between you and me, the trusted body is CompTIA or ISC Square or IC2 or ISACA. So I meet the criteria. So here the CA is the IC2. So I meet the criteria. I gain the knowledge. I obtain the certificate. Now, if you are looking for the training, I will provide you my certificate which build the trust. And then you will assure whatever the data I'm sending you, it is accurate. So to authenticate this public key that it is coming from right source, we involve the certificate authority. And this is basically part of one infrastructure which is called as a PKI, public key infrastructure. So public key infrastructure used to create, manage, distribute, use, store and revoke the certificate. And it play a very important role in securing the communication, ensuring the integrity and authenticity of the data. Okay, so we are using certificate for multiple reasons. Like certificate used to encrypt the communication. So we're taking a same SSL example now. So we have a system A, which is a client. Okay, this is your website. Let's take example, this website is Gmail. Okay. Now client first time when he type https gmail.com, he send the request to Gmail. Request for access. Gmail will send his certificate. The certificate has a public key of Gmail. A download the certificate which has a signature. So first he verify the signature with the public key of the CA, because here we have a CA which issue the certificate to Gmail. If it verifies successfully, then only from the certificate he will extract the public key of Gmail. So client here does not have any key. So client will generate one key which is called as a session key, and the session key encrypt with the public key of Gmail, and it send it to the Gmail. Gmail basically use his private key to verify the signature. Private key to decrypt the signature, and you get the session key. So now whatever the communication happen, it is happen through that process only. This is the example of SSL. Okay, because otherwise what happen, you randomly trust any website, share the informations and all that. Now, so here between A and B, there's a trusted CA we have, which is called a certificate authority. So let me explain you with the diagram. So here you can see, if I basically go to the connection secure, certificate is valid. Here you can see the certificate. Common name is WR2. I go to detail. Now here you can see the version is 3, serial number, certificate signature. So normally we generating a hash. Here they use a SHA. Issuer is the Google Trust. Okay. So 37, not after. Now here the most important part is this one, subject public key. See, when we talk in Google homepage, they're running on ECC. Okay. And certificate subject public key is this. You can see that. So this is our signature part. Signature algorithm, they use RSA, and this is the signature value. So that is how that works. Okay. So our server, our browser maintain the public keys of the trusted certificate authorities. So here between me and Gmail, we have a trusted CA by which we can trust. So then only I can share information with the Gmail. Now in this scenario, if you can notice here is, we are using a certificate for multiple reasons. We're using certificate for encryption. As you can see, HTTPS we are using. It is used for authentication. Nowadays, what happens, instead of sending a password to the server authentication, we send the certificate. So your company laptop has a predefined certificate. That's why when you connect to the company Wi-Fi or connecting VPN, it automatically use your stored certificate for authentication, because certificate is act like a password also. Third, it has a signature which ensure it is coming from a trusted CA. Now, no one can able to hijack the certificate, because if someone hijack the certificate, they need a CA private key to sign it again. If someone compromise the CA private key, then accountability is compromised. That's a different story. Understood? So when we're talking about certificate has a standard. Okay, the standard is called as the ITU X.509. So it's a primary standard for a digital certificate within a PKI, and it defines the structure, format, and use of a certificate across a wide range of application like SSL, TLS, and all that. We involve certificate in that case when we are communicating with a third party. Now, when we're talking about PKI, in PKI we have a two type of servers. One is called CA and one is called RA. So let's take an example. This is basically called as a CA, and this is called as a RA. So RA was introduced to offload the work of CA. So suppose let's take an example, this is a web server. So web server want a certificate so that the client can communicate. So web server send all this information to RA. RA will collect, verify all the information, and then they pass the information to CA. Ultimately, CA is the one who issue the certificate. For any example, let me explain you with the example. You are a candidate. You want to write CompTIA exam, but you will go to Pearson VUE. So Pearson VUE, where you basically provide your information, does the physical verifications and all that, and where you write the exam. But ultimately, it is a CompTIA who certified you as a CISS or Security Plus. Or you go to Pearson VUE for CISSP exam. So you provide all the physical document, everything to the Pearson VUE. But ultimately, it is a CompTIA or IC2 is the one who issue and revoke the certificate. Same thing happen in PKI. In PKI, we have two servers: Certificate Authority Server, which is responsible for issuing, revoking, and managing a certificate, and it verify the identity of requesting certificate and signing them using a private key. And CA are the central to trust model PKI because it ensures that public key associated with the entities such as user, device, application are trustworthy. But to offload the work, because I don't want all the requests go to CA, so we introduce a next concept which is called as a RA. Now RA act like an intermediary between the user and CA, and it is responsible for accepting a request for certificate authentications and forward to approve the request to CA. And RA was introduced to offload the process of CA. That is the process we have. So let's understand the step-by-step process how the certificate works. So first step is to obtain the certificate. So as we discussed already, this is my client and this is my web server. Okay. So what web server need is everyone should trust web server. Okay. Everyone should trust web server. So web server need to obtain the certificate. So first step is enrollment. So to obtain certificate, you prove your public key to the CA. Okay. And this process is called as enrollment. Now, when you receiving a certificate, you verify it by checking a CA signature. So here CS issue the certificate. Then he provide the certificate to the client. The client maintaining a public keys of the trusted CA. So when they receive a certificate, in the certificate, we have a signature. So signature is verified with the help of public key of CA. So if the signature verify, then only we extract the public key. Now, second thing, in the certificate, we check the revocation status. This is the very important part. Revocation status. Because sometimes what happens, the certificate we consume, it is a revoked. Okay, so always remember in the information security, we never accept a revoked certificate. It is same like, you're looking for the CISSP training or CompTIA Security Plus training from me. My certificate is basically revoked by the IC2 or CompTIA in the year of 2023. So you will not trust me. See, knowledge is different and attestation is different. So one simple principle rule is that when we receive any certificate, we first check the certificate is valid. It is same like, you're riding a bike and suddenly police or cop has stopped you and asking you for a license before doing any kind of a communication. So license will basically give the information primarily whether it is revoked or valid. Now question is how they check. So there is a two way to check whether certificate is valid or revoked or not. One is called as a CRL process. In my further slide we discuss. CRL stands for certification revocation list. So as a system, we maintain the list of certificate which is expired. We maintain the serial number of the certificate which is revoked, not expire, revoked. When we revoke any certificate, we give the number to that. Revoke can be happen for multiple reasons. So we maintain the list of certificate which is revoked. So when a server send a certificate, we check the certificate number in that offline list. And that list is called as certificate revocation list. If the number in the list, I will not accept that certificate. It is same like I'm giving you the currency which is already revoked by the government. but it is a time consuming task. It is same like I shown my driving license to the police, and police called to the transport department dictating my number, and manually they're checking in the files. On the other side, we have a second process which is called as a OCSP. In the OCSP, what happens is when we sending a certificate to the client, immediately online they check the certificate. Same like, police has stopped, ask for the driving license number. So I enter the number in the app and immediately I got an alert. So if you get a question, whether it's a security plus or CISSP or SSCPs, what is the primary objective OCSP? So OCSP is faster because it do the revocation check in the online phase. Challenge with the CRL, on a regular basis, we have to download the list of revoked certificate, which is a time consuming activity. Okay. So latency issues there when it comes to the CRL. Now here, the certificate is revoked for a multiple reason. When certificate was compromised, so CA will issue the revoked certificate. When it is errorly issues, or there's a subject got changed, the website's gmail.com, it moved to gmail.co. So they have to change the certificate or change in a security association. So these are the multiple reasons we have because of which a certificate we revoke. See, expire is not revoke. Because of expire, we revoke. Understood? So these are the 4 conditions we have in which we revoke the certificate. The first, the compromise certificate, like someone has compromised and they start using resending. So like, let's say example, someone has took my certificate, edit my name to his name and start circulating everywhere. So I request the IC to issue me the new certificate number, or errorly issued, not associated the random numbers, or change in the certificate detail, we change the subject name, gmail.co, or the entire entity got changed. So these are the multiple reasons we have because of which we revoke the certificate. And expiration is also another reason to revoke. Now we have a different type of certificate standard. The first standard is called as a PKCS, Public Key Cryptography Standard. So this is something used in a laboratories, okay, for the certificate management, like RSA laboratories use. Second is called as a PIV certificate, Personal Identity Verification. It is a standard used by the US government for the smart cards. And third is called as a CVC, Card Verifiable Certificate. It's a standard which is used in the European Union for certificate on smart cards, particularly for e-passports. So the certificate is not only about in CISSP, so certificate is used in the information security and physical security also. Now, as I said, revocation status, the first is called as a CRL. So CRL maintain the list of certificate which has been revoked by the CA. And reason for the revocation might include compromise of the private key. Okay. And CRL is used by the entities to verify the state of certificate. If certificate is listed on the CRL, it is considered invalid. Okay. So we will not go for the things. Let's say example, a company have an internal PKI and they maintain the CRL to manage the revocation certificate, those who are leaving the company. So that is how we basically maintain the CRL. But on the other side, when we say OCSP is certificate obtain revocation certificate of the digital server in real time. So any question talking about digital real time and all that, answer is OCSP. And it allows entity to query a CA directly on the function. That's why it is faster than the CRL. Okay. So OCSP provide more efficient and timely method for checking the status, and required the connection between the client and server should be secure. So when you visit a secure website, your browser might use OCSP to check if the website certificate is valid or not. Okay, so this is the process we have. So OCSP is the online process, immediately check. CRL is the offline process. Okay. So let's understand whether you understood this topic or not with some questions which give you the idea. Okay. So let's start with some coffee questions. So first question, what is the primary objective of the PKI? Option A, encrypt the address. It's not necessary. We can use encrypt in transit also, but that is not a primary rule. Second is facilitate secure communication, authentication over the network, which makes sense. Store user credentials securely, but that is something we can achieve with the help of encryption. Manage distribute software update. That is also one of the requirement, but the biggest is basically called as a B. By end of the day, it is help you to build the trust party communication, authentications and all that. So let's move to the next question. What is the primary usage of OCSP? Generate a certificate? No. Encrypt the communication between the client server? No. Check the real-time revocation status certificate? Makes sense. Store public key in security? We store private key, not a public key. So answer is basically C for Charlie. Check the real-time certificate. Okay. Third question. What is the primary usage of CRL? Distribute the public keys? No. List certificate have been revoked before expiration date, makes sense. Manage the issue of certificate, no. Or encrypt the communication, again, that is for the session key and all that. So answer is basically B for beta. So let's understand with the scenario based questions. Okay, your organization has implemented the PKI to secure the email communication among the employees. The PKI is configured to issue a certificate to each employee. The organization security policy required sensitive emails must be encrypted and digitally signed before being sent. Okay, fine. Recently, the employee reported they receive a digitally signed email from the colleagues. Okay, but when they check the certificate, they notice that it has been revoked. So what should be the employee do in response to receive the email with revoked certificate? What does this indicate about the PKI? So option A, ignore the certificate status. This indicates that PKI is only used for encryption, not for authentication. Report the incident to the IT security team. Definitely this indicate that PKI is being used to ensure both encryptions and authentication. Revoked certificate may indicate potential security breach. Option C is reply the email, ask the sender to resend the email with a new certificate. This indicate PKI has been used as a primary for encryption and revocation of the certificate, which is not a crucial for authentication process. And delete the email immediately, as revoked certificate mean email is automatically malicious. See, this indicate misunderstanding of PKI. A certificate revocation alone does not mean the email is malicious. Okay, so answer is, as a practitioner, my role is to report only. In this scenario, employee should report the incident to the IT security team because the use of a revoked certificate indicate the certificate should no longer be trusted. And this could, I repeat, this could be due to the number of reasons. It can be certificate being compromised or employee leaving the organization.
Hey team, welcome to my session on Coffee with Prab, and today we're going to cover about IDS and IPS, Intrusion Detection System and Intrusion Prevention System. I'm covering this concept more from the interview preparation and exam preparation. So this topic is testable in the IC Square exams, ISACA exams, CompTIA exams, EC Council exam. If you're new to my YouTube channel, do subscribe to my YouTube channel and click on the bell icon to make sure you should not miss my future videos. My name is Prab Nair. For more information, you can refer my LinkedIn profile. So without wasting a time, let's start with the first part. Okay, so first we need to start with the introduction of IDS and IPS. Intrusion Detection System and Intrusion Prevention System. If you're talking about the definition of IDS, it is clearly said that it is a solution which monitor a network or system for a malicious activity or policy violation, but it doesn't drop. It doesn't prevent, it is only detect. And IPS basically a solution capable of detecting all the security concerns, but as well as it basically drop anything which is non-compliance. It means things which is not going as per the requirement. Let's take an example like we have a security guard. Now, security guard, we have given a clear instruction to security guard. If this number plates of car is basically coming, please block him. So here it worked like a IPS. But we told security guard that any car is coming to the apartment, okay, outside of these numbers and all that, just note down in the register. Okay, you don't need to stop them because there will be unnecessary fight. So this is where the security guard work in a IDS mode. So IDS discover if anything going against the policy, it will only discover and detect. But in the case of IPS, if things are going against the policies and all that, it will basically block and it will drop the packet. That is why we call IDS used to detect the intrusion and IPS used to prevent the intrusion. So intrusion is basically mean any action which is attempted by the attacker to compromise the network or anything which is accessing in an unauthorized manner. That is called as an intrusion, like uninvited guest. Okay, so example like this is my IDS. We have example intrusion detection system. Okay, and we have a user one, and this is my web server. Okay, so user sending a traffic. Now IDS will basically capture this traffic and compare against the rules which is basically create. I'm just taking example by defining a rule here is source is any, destination is basically a web server, source port is any, and destination port is 80. So what happened is we have created this rule which define as a legitimate traffic behavior. Now IDS will capture the traffic and check the context of the traffic against this particular rule. We have discovered, yes, source is any, we can ignore that. Destination, yes, packet is going on a web server. Source port is any, okay, but destination port is not a 80 in the packet. It's showing me 27 or 23. So IDS will basically log that traffic. Okay, so that is the role of IDS. But if I say we have a IPS, in that case, it will basically block that traffic. It will drop the traffic. That is why IDS is also called as a outline mode and IPS is called as a inline mode. It means if user sending any traffic to web server, if the traffic doesn't meet as per the IPS, it will block there itself. It will not reach the web server. But in the IDS, it will remain outline, it will remain passive and just allow the traffic to be go on a web server, but it will log the traffic. That is why IPS slow down the performance. Whereas IPS will basically slow down the performance, whereas the IDS will not slow down the performance. That's why it's clearly mentioned here, IDS does not slow the network traffic because it will not block. But in the case of IPS, it will basically block. That's why it will impact the network traffic. But ultimate goal of IPS and IDS is different. So that is the thing we have. Now, when you're talking about IDS component, because we're specifically talking about in this session IDS. So IDS basically has a two component. One is called as a sensor and one is basically called as an analysis engine. Okay. So first we discuss about the sensor. So sensor is two type, network based intrusion detection system and host based intrusion detection system. So what is NIDS and what is HIDS? Suppose this is my network, internet. So we install the NIDS here on the border of the network. And then we have a switch here. And then we install the system A, we install the system B, and we install the system C. Okay. So now what happened? The traffic is basically coming from outside. So NIDS will monitor from where it is coming to where it is going. It also monitor from which port is coming to which port is going. But once the traffic is passed to the NIDS, what kind of a changes it introduce in every system that NIDS will not able to monitor. For that, we need to install in every system HIDS. Okay. So NIDS is basically used to monitor the network level traffic and HIDS is basically used to monitor the host level traffic, like modification attempt in a system level and all that. So we have a tools like Tripwire and all that. But one concern with installing HIDS in every system is that performance issue. Okay, so that is the NIDS and HIDS. So that's why we prefer to install the NIDS in the border of the network, which monitor all the traffic which is coming to the enterprise network. And if you want a system level activity, we install the HIDS in every system, just like our antivirus. But the question is how they detect the intrusion. So they have a two-way to detect the intrusion based on a pattern matching and based on anomaly that I'm going to discuss in my next slide. So we have discussed so far about IDS component, which is called as a HIDS and IDS, and that is the two type of sensors we have that we place in the border of the network or in a one particular host. And the second part is basically called as the analysis engine. But the question is, based on what factor it able to detect the intrusion. So we have a two type of intrusion detection mechanism we are using. One is called as a pattern matching, which is also called as a signature based intrusion detection. And second is anomaly based detection. Like example, we have an antivirus. The antivirus that we installed in a system, it basically scan the file, check for the signature and compare against the database signature match. They will give an alert. It will block. So same like IDS and IPS use sensors. They use analysis engine. They use this mechanism based on which they detect the intrusion. So first, which is a traditional method, is called as a signature base. Fast and very effective. You can say like that, but fail to detect the zero-day attacks or new attacks and all that. So pattern matching and signature base is basically use fixed sequence of bytes within the packet. It use signature based inspection limited to the service and protocol of layer 2 to layer 4. Attack vectors is known and system procedure and alert if the pattern is basically detected, which is mentioned here. Example like this is the NIDS we have, just imagine. Okay. And we have a web server here. Example, this is my web server. And we also have a attacker. So attacker basically send the packet. Now this NIDS, if it's using a pattern matching, they will check the content. They check the packet. In the packet, they check some strings. Okay, there is a strings are there. Example, FF11, FF22. I'm just giving example here. So in the packet what we have captured, in that there is a content, and the content it has some this kind of a strings. Then NIDS will check in his database and try to identify if we have any such kind of an attack with this kind of a pattern. If pattern match, NIDS will log the traffic. That is why it is called as a pattern matching signature base, or pattern matching or signature based intrusion detection. They check the signature, they check the string values in the packet and compare against the database they have. Okay, so that is how it works. But there is a one disadvantage of the pattern matching or signature base we have. If signature is not up to date with the new attacks, or new signature is not there, then NIDS will fail to detect the new attacks. So that is the one concern we have is pattern matching. Faster, effective, based on the signature base. In order to improve that process, we basically introduce the second one, which is called as a anomaly based detection, which is abnormal. Okay, so in this case, we basically what we did, we created a normal baseline and look for the deviation from the normal baseline. Example, source is any, sorry, like source is any, destination is the web server, source port is any. Most of the traffic is coming on the port number 80 because we have web server only. So any traffic coming from outside it going on a port number 80. So we will look for any kind of a abnormal behavior. If any packet is going against this traffic profile, I want that to be recorded because that is an anomaly. So we develop the profile initially when we install the solution. What it does, it basically develop many behavioral attributes like number of emails sent by user, number of failed login attempts, number of hosts, number of packets are going on this port, telnet attempt by root user or telnet attempt by some other thing. So this kind of a profile behavior we have created. So whenever such kind of a profiles comes, or such kind of a traffic comes, we will basically compare against the traffic profiles. If it's basically going against that, it will record that as an intrusion. Example like 4 login attempt, it's a common thing. But if we discover more than 5, 6, 7, which is against the deviation, it will record that as an intrusion. So instead of checking based on a signature base and all that, they observe the behavior of the traffic. Today we're using the advanced version of anomaly in which we introduce the AI and ML, which is called as a network behavior analysis anomaly, where we analyze the behavior apart from checking the signature, and based on that they record the intrusion. So it's very effective at detecting the previously unknown threats because we have created a traffic profile for that. Okay, but it generates a lot of false positive traffic. Okay, so this is called a pattern matching or signature based or anomaly based detection, which is also called as a network behavior analysis. Let's move to the next part. So we have discussed about different type of IDS. Then we discuss about the way to analyze the traffic intrusion, which is more like a based on a signature content, based on the uh, behavior. Now, when we implementing IDS in the organization, we consider several parameter. Okay, so we have a number of factors when we're implementing IDS. It's not something okay randomly we implement NIDS and HIDS. So we have a multiple parameters. So first is called about scale of traffic. If you know that okay, we don't want a host specific, we receiving more and more network traffic and all that. So as a security architect, as a security consultant, as a security manager, we will recommend to have a one common NIDS in the border of the network. So any traffic is coming from outside, we can able to monitor. Now, if NIDS I want to monitor for the internal traffic, so what is the best practice is, this is my switch. Okay. A switch is basically work in a unicast mode. So if we have a system A, we have a system B, and we have a system C. If A want to send data to C, A send data to switch, and switch will directly send the data to C because switch work in the unicast mode. But in that case, if I install the NIDS and NIDS want to capture the traffic stream and all that, it will not possible. So we need to create a span port. We called as a span port, mirror port we called. And that port is basically mirror with all the ports. So if A sending any kind of a traffic to C, the traffic is going to this port only. This port will send one copy of the traffic to this port. Make sure capability and capacity bandwidth of this port should be bigger than other, because that port is handling the copy of the traffic which is coming on these ports. Okay, so when you're planning for you have you have a huge traffic network quantity and all that, so according to that you need to place the NIDS. Might be sometime one NIDS will not be effective, so we install the multiple NIDS which work in a fail safe mode. Okay, so if one NIDS is down from another NIDS, we can able to inspect the traffic. So this is how we can able to create the load balancer. Second is we need to improve and increase the attack signature, because that is the one concern with signature based IDS. It will fail to detect the new attacks. So on a regular basis, we need to update the attack signature so it can able to discover the new attacks. Third is we need to focus on the quality instead of quantity, because more data we collect, more time it will take to do the analysis and all that. So it's very important during an anomaly we create a more granular traffic profiles, and that is only possible when you install the IDS. It will be in a learning mode where he will discover, or the tool is discover, or device will discover more and more traffic pattern. So that is another important thing. The placement of IDS, it's also play a very important role. See, if you place the IDS inside the security parameter, example, this is the firewall we have, and then you basically install the IDS here. Okay, so example like this is the IDS we have. Sorry, I'm sorry. So if you have a IDS here, and this is the firewall. So traffic is already restrict the firewall. So firewall already filter the cream traffic, and then the cream traffic is going to the IDS. Okay, so IDS will basically focus on the quality traffic. Okay, and anyone who try to bypass the firewall and able to hack any servers or other servers, that intrusions can be discovered and detect by the IDS. So that is the one thing. But if you place the IDS, if you place the IDS before firewall here, then what happen in that case, it will monitor all kind of a traffic and the unknown attack pattern which is coming from outside. So again, depending upon the business requirement, we can able to place the IDS. When you're dealing with the IDS, we have a two type of error: false positive and false negative. False positive is basically when IPS IDS identify something as an attack, but in fact it's a normal traffic. It means it give alarm that okay, someone has a password attempt, but in reality it is like a normal traffic. Or there was a one day administrator trying to access from its home. IDS discover this as an intrusion, but in reality it is not an attack. Okay, it's a normal traffic. So that is called as a false positive. Then second is basically called as a false negative, where there was an actual an attack, but IDS failed to detect. So for the any security consultant or any company concern is the false negative incident, where we have installed the hi-fi solutions and everything, but failed to detect the new intrusions and all that. Okay, that's why when we're dealing with the IDS and IPS, we also have one more important matrix. One is called as a reporting, and second is called as a event monitoring. Now, I have seen a lot of people get confused with these two words. Reporting is all about analysis based on the archive information. Analysis based on archive information, whereas the event monitoring is basically a real-time monitoring. Okay, so reporting is all about analysis based on archive information. Event monitoring is all about real-time monitoring. So IDS, what it does first event monitoring, and then it will basically document as a report. Okay, that's why in order to reduce this false positive and false negative, we need to tune the sensor more effectively. Tuned to ensure these are kept to be minimum. This false positive and false negative need to be keep minimum. Okay, so this is all from my side. So let's have some questions. Which type of solution deployed in a inline mode? IDS is outline. We left with IPS. So answer is basically IPS. Let's discuss the second question. Which type of solution deployed in a outline mode? Answer is IDS, which we have covered. Next question. Which type of IDS is most effective for detecting audit logs, processes inside a single system? Keyword is single system. That's why I'm going with the answer HIDS. Which type of IDS focus on analysis of the network traffic? The answer is NIDS.
IPSec. It is basically part of my network security interview series. So I was thinking about picking one topic of network security and discuss about the topic for 15 to 20 minutes. My name is Prab Nair, and for more information, you can check my LinkedIn profile. And if you're new to my channel, do subscribe to my YouTube channel and click on the bell icon to make sure you should not miss my future videos on a similar topic. So without wasting a time, let's start with the first part. Thank you. So let's understand what is IPsec. So if we go by the definition, it's a IP security or IPsec is a collection of protocols designed by the IETF to provide security for a packet at the network level. It is actually a solution which is introduced to protect the data in transit. Okay, so we have a three states of data. One is basically called data at rest. One is basically called data in transit and data in use. So example, if data resides somewhere in a storage, we need to protect. We have a solution for that. But when one system A sending a data to B over the network, okay, so there is a possibility that a hacker can able to intercept the data. So I want to protect the data from, I want to prevent the data from getting intercepted. So one of the protocol suite we are using is IP security protocol suite. Now, overall, as I said, it is used to ensure the confidentiality, integrity, and authenticity of the data transmit over a different type of network. Okay, so example, like we have a system A and we have a system B. So we have a data here. So what we did is data is basically protect with the key. So we have encrypt the data. So data will remain encrypted throughout the journey and it reach B, and B will basically use the same key to decrypt the data. So by this way, it offer the confidentiality. It also offer integrity, authenticity. How we'll discuss in a later stage. Before we're going to discuss about IPsec in detail, let me tell you the IPsec family. In IPsec, we basically have a three important component. One is basically called as a protocol. One is basically called as a modes. And one is basically called as a key exchange. So when you're talking about the protocol we have a two types, AH and ESP. When you're talking about modes, we have a two modes in IPsec. One is called as a transport mode and one is basically called as a tunnel mode. And the key exchange is basically achieved through ISA, KMP, Oakley, and SEA, SME. So these are some of the parameters we have. For data encryption, it basically use AES, and for the key exchange, it use Diffie-Hellman. Along with that, for the hashing, is basically use the SHA. So this is basically the primary goal of IPsec, or primary component of IPsec. So ultimate goal, whatever the data we are sending over the network, it should be protect from unauthorized disclosure, unauthorized modification, and giving an assurance that it is coming from the right source. So the first thing we're going to discuss in the IPsec is the protocols. So the first protocol that we're going to discuss in IPsec is AH. So AH is designed to authenticate the source host and ensure the integrity of the payload carried in the IP packet. How? Example, like we have a system A
and we have a system B. Okay, so this is basically my data. So if you see the statement here, it is clearly mentioned, the protocol use a hash function. So what we used to do is we create a hash value of the data. We generate the hash value. Hash value is represent the integrity state of data. So example, right now the time is basically 6:38. So at 6:38, the data was formed, and this is the hash value of the current state of data. Is it clear? And then this hash is basically encrypted by the symmetric key. And we append the AH header as a signature into the data. And when we send this data to B, when B receive the data, they will see the AH header. So first AH header will be decrypted by the secret key. Then they get the hash. So that is an assurance that this is come from the A, because B already have that same session key which A has. So that give the assurance it came from the A. Now we have to check the hash value. By check, we checking the integrity state. So we scan the data and check for the hash and compare this hash with this hash. So if it's same, it means it gives also the assurance data came without any unauthorized modification. So that is why I call protocol use a hash function and symmetric key to create a message digest, which is called hash, and insert into the authentication header. That is why AH primary offer authentication and data integrity, but not a privacy, because anyone can able to read the data. Is it clear? Because when A sending a data to B, okay, so example, someone is sending a data. Okay, so attacker is here. He can basically intercept the data and easily for the user to read the data. It doesn't matter for them what is AH. Is it clear? But if we modify the data and resend, B can able to identify this is not the same data which came from A, because it is encrypted by the unique keys. So AH primarily offer the authenticity and integrity of the data state. But if you're looking for the complete solution, end-to-end solution, then we have a ESP, which basically provide the source authentication, integrity and confidentiality. So example, like we have a system A, we have a system B. This is basically my source. This is my destination. So far what we have learned is we have a data to give an assurance it is coming from A, and with the integrity state we add the AH header. But then what happen is they basically encrypt the entire data into a new packet, and then it basically sending that encrypted data over the network. Now if there is an attacker, if he monitor and he capture this, they cannot able to read anything on that. So it already having a authentication header which providing the authenticity, which capture your integrity hash value, which provide the integrity and also encrypt the entire data. So it provide the source authentication, integrity and confidentiality. So ESP authenticating the data are added at the end of the packet. So ASP protocol was designed after the AH protocol was already in use. So first we introduce the AH, and when we discover the issue in the AH, then only we introduce the ESP. So same example we have a data, then we have a AH header, and then we have a IP. This is the external IP which is used by the router by which they are routing the information. But in this case data, then encrypt the data, then we adding the external IP by which the routers can able to communicate. So if you go by the security protocol comparison, access control offered by both AH and ESP, message authentication offered by both, entity authentication, it means data source, offered by both, but confidentiality AH doesn't offer. It is basically offered by ESP. Replay attack protection offered by both, because when we say system A and system B and there is an attacker, if A is sending any data, B is asking for the password and he is sending something, so he will capture and resend. That is not possible in the case of IPSec, because every packet has a unique packet header by which we can able to prevent the replay attack protection. So it solution offered by the both AH and ESP. So today IPSec is also used in a Microsoft. It is used in a Linux in a form of policies. How? Example, like we have a domain controller, and here we have a switch. We have a system A, we have a system B, we have a system C, and we have a system D. Now you want to ensure that A can only communicate with B, and you want to ensure C can only communicate with D. So from a DC, we can create a IPSec policy, and by which we can ensure that A can only communicate with B, B can only communicate with A, C can only. So this is basically called as a feature called IPSec filtering. Another important feature which IPSec offer is port security. Port security. What is port security is, suppose we have a server here.
web server. So from a domain controller, we apply the IPSec policy that they can able to access by a port number 80, but if they try to ping on ICMP, that will be blocked. So IPSec offers this kind of an access control. Is it clear? But primary introduction of IPSec was a data security which need to be sent over the network. Now, when we're talking about IPSec, in IPSec, we have a different modes. So in IPSec, we have a different type of mode. The first mode is called as a transport mode. IPSec in transport mode does not protect the IP header. It only protects the payload coming from a transport layer. That is basically called as a transport mode. It is also called as a end-to-end encryption. So this mode is used when we need to communicate between host to host. Example, we have a system A and we have a system B. Okay, here we have a firewall, here we have a firewall. So this mode is basically happening between end-to-end host. So between A and between B, this encryption happen. So in which they only encrypt the data. AH and AH is basically visible. So it only encrypting a data, but IP header is basically visible. You can see we have a data, we have a ESP header, IP header. Okay, so in this case, they basically encrypt the data, but header is basically visible. And that is why it is used between the two hosts. But between the two firewalls, we basically use a tunnel mode. So it protects the entire packet. It take the IP packet, including the header, and basically apply the IPSec method to encrypt the entire packet. And then they add a new header. So it is basically happening between the two routers. So if you take an example, the same example we have. So this is basically called as a transport mode. And between these two routers, we basically have a tunnel mode. That's why tunnel mode is called as a link encryption, which is happening on the layer 2, and transport mode is basically happening from application to transport layer encryption, which is also called as a application level encryption or end-to-end encryption. Okay. So if you can see the packet header size and types, so we have a data which is only encrypted, rest is basically visible. But in this case, data is encrypted along with the IP header is also encrypted. So definitely tunnel mode is basically offer better security. Now, in which condition we use tunnel mode? So company want to create a secure tunnel between its headquarter and remote office, they would use tunnel mode. The government agencies, they want to create a secure tunnel between its headquarter and embassies around the world, they will use tunnel mode. The bank want to create a secure tunnel between the headquarters and ATM, they will basically use the tunnel mode. Along with that, we have a case studies where the transport mode is used. Example, user want to securely access the work files from the home, they will use transport mode. The user who want to securely connect to the remote desktop, they will use transport mode. Or user want to securely send an email, would use the transport mode. But the question is, what is the key by which they encrypt the data? So we have a third important component in the IPSec, which is called as a IKE, Internet Key Exchange. So it is a protocol designed to create both inbound and outbound security association. So IKE is basically the complex protocol, which is based on the other three protocols. One is basically called as a Oakley, one is called as a SCIMI, and one is basically called as ISA-KMP. So first is basically called as a Oakley. Oakley is basically called as a key creation protocol. Okay, so you can say we have a stadium, okay, in which we need to play cricket. So Oakley are the players, you can say, okay, who want to play cricket, which is used with the ISA-KMP. ISA-KMP provide the infrastructure, like what is the mode, what is the key, and what is the algorithm we have to use. But when you're talking about SKEME, SKEME basically stand for Secure Key Exchange Mechanism. So it was an alternate of ISA-KMP. So today, if you take example, ISA-KMP is used for negotiation. It is basically used for establishing a security association and securing the connection between the IPSec peer, okay, which specifying the network for key exchange and authentication. And Oakley basically used for the key agreement or exchange and define the mechanism used over the IKE session for the key exchange. And Diffie-Hellman is the default algorithm they basically use. So IKE is a part of IPSec, Okay, a pseudo protocol algorithm which is used to secure the sensitive data transmit across the network. So that is what we have. So okay, so next topic is malware. You're one of the best friend if you're working in the SOC, and you're going to encounter this. So these are the biggest threat for SOC analyst, you know, because these are the one who's creating a problem. You know, we have a doctors. So doctor investigating every day some kind of virus. Same like SOC, people will investigate a different kind of a malware. Okay, like we say a software. Same like we have a malware, and these are basically the one who exploit the systems. So first is called as a virus. Now virus is a kind of a malware which replicate from one system to other system with the help of human interference. Okay, so that is basically called as a virus. Now virus required human interference to replicate from one system to the system. Without human interference, it cannot be replicated. How? Let's say example, we have a system A which is infected with a virus and it slowed down the process and all that. I plug the pen drive and I copy some file. Along with that, virus also copy into the pen drive because it required power, it required memory. But when I connect the pen drive in the B system, automatically virus jump into the B system automatically. So that is called virus, which replicate from one system to other system. So worm doesn't require human interference. It can be replicated from one system to other system without any human interference. What is the meaning is, if the system A is infected with the virus, if system A infected with the virus, then, sorry, if system A infected with the worm, even B ping the system, automatically the virus replicate from A to B. That is called as a worm. Ransomware is a new kind of an attack where it is hack the system and encrypt the file. It hack the system and it encrypt the file. That is basically called as a ransomware, and then it asks for ransom. The primary goal is to hack and encrypt the files. Okay. Spyware, when you install, it start recording a keystroke. So the purpose of spyware is not to slow down the system, but slightly it's basically installed in a system, and whatever you're going to type, whatever you're browsing, remotely it send the information to the hacker. Purpose of Trojan is not a objective to slow down the system. Trojan was introduced to, you know, gain access to the system. So when you're talking about Trojan, we have a system A and we have a system B. I convince the B, hey, this is a very good application, install that. And the person installed that. Now what happened? I gain access to the system through that particular backdoor port. See, if I'm going to initiate the connection from the A to B directly, B will ask for the password. I need to provide the username password. But in this case, I installed the Trojan by convincing him. So now I'm gaining access to system B without any username password, which is called as a covert channel, stealth channel. Is it clear? But one of the biggest, and actually the biggest concern for us, Trojan, because by installing a Trojan, we perform a ransomware attack. We hack the system, we gain access, and then we encrypt the files. Another important malware which is difficult to detect is a rootkit. Root mean root level and kit is a construction kit. See, if you talk about the system architecture, this is how the system architecture look like. So we have a kernel, we have a driver, and here we have an antivirus. So antivirus install here, but if hacker basically hack into the kernel and he installs some kind of a rootkit on the kernel, antivirus will not able to detect. So if system is infected with the virus, worms, okay, spyware, we can able to investigate because this is happening here. But rootkit is installed on the kernel level, which is like a backbone of the operating system. The only solution is basically clean installation, because it is easy to identify virus worm, but it's difficult to identify the system is vulnerable for rootkit or system is infected with the rootkit. So as a security analyst and all that, the major challenge for us to investigate the rootkits and the ransomware. Okay, so that's a very important part. So that is why to handle this kind of an issues and everything, we introduce the first thing called antivirus. Antivirus are the tool detecting, preventing, remove the malicious software from a system. That is basically called as an antivirus. So let's say example, we have a system A and system A is installed with the antivirus. So now what happens, any file comes, antivirus scan the file and check the file signature with the antivirus database. If any signature of the file is matched with the database of antivirus, the antivirus will block that.
but if signature doesn't match, the file can enter into system. So one primary concern with antivirus is that if it's not up to date with the new signature of virus, it will not able to detect. That's why today we use a new modern solution, which is called as a EDRs. So antivirus is a tool designed to detect, prevent, and remove the malicious software from a system. And why it is important? Because logs from this tool often feed in SIM for further analysis. So that is the reason. Some examples we have: Norton, McAfee, Kaspersky softwares. So these are some of the antivirus we have. I'm not here to recommend any solution. I'm just giving an example here. Another important tool that we are using is called as a firewall. Firewall. See, and antivirus install on the endpoint, but firewall we install on the border of the network. So if you take example, we have a system A, we have a system B, we have a system C. So we have installed the antivirus in every system. Okay, which inspect the data. Okay, but when we're talking about firewall installed here on the border of the network level, it monitor the traffic. It monitor the content based on IP. Okay, it monitor the content based on IP. So now what happened? So whenever any packet pass to the firewall will check source IP, from where it is coming to where it is going, from which port is coming to which port is going. If it's allowed as per the firewall, they will allow the packet. If it's against the rule of the packet, it will block. So firewall was introduced to monitor the primary incoming traffic, what comes in. But whatever is going out, for that we also have a dedicated solution which is called DLP. But primary objective of firewall is to monitor what kind of a traffic is coming from outside. That's called fire. Wall is like a thick wall. So primary purpose of firewall is to monitor the attacks which is happening from outside. That something is part of a requirement. And firewall is a first line defense. So SOC analysts often review the logs to identify, block or suspicious traffic. That's why we have a different type of firewall here that I want to discuss. So first firewall is called packet filtering firewall. It's a very basic firewall. So when you're talking about packet filtering firewall, let's say example, this is the packet filtering firewall that we install on the border side. Here we have an internet. Okay. And here we have a system A and here we have a system B. So A IP address is 10.0.0.2 and B IP address is 10.0.0.3. So now what happened is we have a user. So in the firewall we create a rule like source is any, because we cannot monitor from where it is coming. But if anyone is coming to 10.0.0.2, the source port is any, but destination port is 80. So if any traffic, when it passes through the firewall, so this is the packet content. This is the packet content. So we check from where it is coming. It has a destination IP, source port and destination port, but we have a content also. So when the packet passes through the firewall checking from where it is coming to where it is going. Destination, it's mentioned 10.02 in the rule 10.02, fine. Source port is any, destination port is 80, yes 80. So they will allow this packet. But one primary challenge with packet filtering firewall, it doesn't inspect the content. Second is it does not track the session from where it is coming, no. And if A want to send the data back to the client, we need to create a manual rule in the firewall. So it's a very simplest type of firewall that we install on the border of the network. Now to maintain the session, I will install the circuit level proxy. With the packet filtering firewall, we install the circuit level proxy. So now what happened, the connection come by packet filtering firewall and then circuit level proxy maintain the information about the connection from which we basically access the B. So that's why circuit level firewall works on the layer 5 of the OSI model, session layer. But again, the challenge is it unable to inspect the content. It track the session but unable to inspect the content. That's why here we install another firewall which is called as an application level firewall. So now the connection come by the packet filtering. Then from there it go to circuit level and then it terminate here, because application level proxy has to inspect a new connection initiate from this point to B. Now B send back the information to proxy and then from proxy we take the connection to the user. So by this way we are adding the internal network from external. So you tell me in the comment box which one basically slow down the process, circuit level or application level. I'm waiting. So answer is basically application level. It slow down the process because it terminate, inspect and you reinitiate the connection. Then we introduce another firewall which is called stateful firewall, works on the layer 4. And it basically the thin line difference in packet filtering and stateful maintain the information about the state from where it is coming to where it is going. And we don't need to create a rule for reverse side. But today we don't do all this, we use a next generation firewall which work from layer 3 to layer 7 of the OSM model. It inspects the source IP, destination IP, source port, destination port, and everything. Now, if you want to stop the video for a second and take a screenshot, you can take, because it gives you more clarity. Packet filtering firewall based on the IP address, works on the layer 3, only do the header. High performance because it doesn't do much inspection. Basic traffic, simple attack, simple and fast to implement, cannot inspect the application. Cisco ACL IP tables is the best example. Circuit firewall work at the session layer to monitor TCP UDP. Session layer, session level, moderate performance, filtering based on a sessions, session hijacking, invalid connections, validate the sessions, limited to session level, and checkpoint firewall is example. Application level works on layer 7 only, do the deep inspection data. Lower performance because it's a resource intensive. It can also block the SQL injections. Performance bottleneck, squid proxy, Zscaler is an example. Stateful firewall track the state of active connections. Layer 3, layer 4 deep track connections, moderates, protect the enterprise, monitor the attacks, track the session states, offering the enhanced security, and more important, more complex and resource intensive. So these are some of the solutions we have which is used. Hope you got the visibility on this area.
Private network. This session is covered in such a manner that it can help you for your exam preparations and interview preparations. If you're new to my YouTube channel, click on the subscribe button and bell icon to make sure you should not miss my future videos. My name is Prab Nair. For more information, you can refer my LinkedIn profile. Without wasting a time, let's start with the first part. Thank you. Okay, so if you go by the definition of VPN, it is clearly say that VPN extend a private network or corporate network across a public network and enable a user to send and receive data across shared or public network to other branches. Let me give an example of that. So suppose we have a system A based out in India, connected with the internet, and we have a branch office in suppose US. Okay, so there are some resources we have in US like file servers and all that. So file server 1, file server 2, file server 3. Now this user who based out in India want to access his enterprise network, and through the enterprise network he want to access to the resources. So with the help of VPN tunnel, he will create a VPN connection. Okay, over the WAN. So this is basically my internet connection, generic internet connection. If he's sending a request on the internet directly, there is a possibility that we have a multiple attackers. Okay, there are some multiple attackers, attacker 1, attacker 2, attacker 3. So they will try to intercept the data. So VPN providing them opportunity to create a secure tunnel. Okay, it creating a secure tunnel. And then through this particular tunnel, we basically send the data. So A just feel like that he is a part of an enterprise, and by this he can able to access the resource 1, resource 2, and resource 3. Same like we have a other branch. So this is the branch. Instead of a system, we have a branch in India and branch in UK, head office in US. Okay, so now what happened? With the help of VPN, my internal user can able to access the other location resources. My internal user with the help of internet can able to access the other branches resources. So by this way, this private network was extended with the help of VPN over the public to connect with their branch. So this is what is VPN. So VPN extend a private corporate network or private or corporate network across the public network, enable the user to send and receive data across a shared or public network to the other branch. One more example, like in India, we have a metros. In US also, we have a private train. So it was created over the public traffics. And if you go by the train, we can able to reach from one location to the location as early as possible because they have a separate route. They have a separate channel by which it basically travel. And that basically save our time. Same like we have a VPN, which was introduced initially with this purpose. Okay. So when you're talking about the VPN implementation, VPN is basically implemented by two way. One is called as a site-to-site VPN and second is called as a remote access VPN. As I said, we have a branch office in India, we have a branch office in Bangladesh, and we have a branch office in Sri Lanka. Okay, so they are connected with the internet, and this is my head office. So with the help of VPN, this is the VPN connection, this is the VPN connection, this is the VPN connection, this is the VPN connection. So with the help of VPN connection, one branch can able to communicate with other head office, one branch communicate with this head office, one branch can communicate with this head office, or one branch communicate with another branch seamlessly. It doesn't feel like, okay, they are communicating on the internet. So that is what is called as a site-to-site VPN. But if there is a one user from his home trying to connect only with that office using a VPN connect with the head office, that is part of the remote access VPN. Simple, like I am at home and I'm connecting with my branch office, I'm connecting with my enterprise, so that is a remote access VPN. Or we have a multiple branches, they are sharing a data on a regular basis. With the help of VPN, they can able to build the network seamlessly, they can able to communicate across the network. So that is basically called as a site-to-site VPN. Now in a layman, I can explain you how the VPN works. So we have a system A, okay, and this is my head office. So we have a VPN server here, imagine. Let me draw it more effectively. So we have a use system A, and this is basically my branch office. Okay, so we have a VPN server here. Okay, so we have a VPN server. Now user is basically first dial the IP. They dial the IP. Example 1.1.1.1. This request is basically carry on the PPP. You know why? Because the devices which is configured on the internet, they are the DT DC devices. DT DC devices. They don't understand the IP packet and all that. So that the dial-up request is carried by the PPP protocol, which is called as a point-to-point protocol. So the DT-DC device can able to understand, and by this way they able to pass the information to VPN server. Now VPN server is basically ask for the username and password. So this kind of a pop-up we get. Enter the username and enter the password. So there's a username and password we basically enter. When we enter the username and password, default here we use mostly CHAP authentication. Okay, that's why you can see some kind of a blue pop-up when you connect with any server, which asks for the credential called as a username and password. So we enter username, we enter the password. When we enter the username and password, that information sent to VPN. And then we basically create a tunnel. This is the tunnel has been created. So over the WAN, this is the tunnel we created, and through this particular tunnel, we transfer the data. Now your tunnel creating between the user to the location, then it is a remote access VPN. The tunnel created between the two branch, that is called as a site-to-site VPN. Okay, so this is how the VPN basically works. So it established the secure channel over the internet by which they can able to send the data without any issues and everything. And by this way, we have a faster sending of the data. So now we're going to discuss about the different type of tunnel. But before that, in VPN, we also need to understand the security model. So when we're going for the VPN, it offers three important things. First is called as a confidentiality. So confidentiality means it creating a separate tunnel through which it send the data so it can protect against sniffing and all that. So that is the best thing about VPN. Second is it offered the authentication, which prevent unauthorized user from accessing the VPN. Definitely when you're connecting with any branch office and all that, it need a username and password. Until unless you don't have a username and password, you can't able to connect with them. So by this way, we ensure only the authorized users to be part of or connect to the branch office. They also use the hashing and all that by which they ensure that, okay, message should not be altered. That is a VPN is rely on the external solution, which is called as IPSec. Okay. So these are the three important security models are used in a VPN. Okay, protection against unauthorized disclosure. Okay, make sure only authorized user can able to connect. And third, protect against the unauthorized modification. Now we're going to discuss about the VPN tunnel. Okay, so next part is VPN tunnel types. We have a two type of tunnels, PPTP and L2TP. We also have a third which is called SSL VPN and all that. As we're covering more from an interview and exam preparation, so I thought I will limit it to two only because these are the base. So in this section, we're going to discuss what PPTP, L2TP, because when you're talking about tunnel we create in the site to site and tunnel we create in the remote user. So the first part we're going to discuss about PPTP. Okay, so first we're going to discuss about PPTP. If you go by the description of PPTP, it's saying it's Microsoft point-to-point tunneling protocol. You are absolutely right. It is basically developed by Microsoft. So that's why it is called as a Microsoft point-to-point tunneling protocol, which is designed to provide tunnel encrypted communication. Okay, so it is used to connect client across the dial switch point-to-point network to the internet and then to the private enterprise network to the MS servers on such networks. If we're talking about the packet structure of the PPTP, before going to discuss about the packet structure, let me explain you the process. So we have a user here connected with the internet. So we have a router 1, router 2, router 3. So we have our routers here. And here we have a VPN server. This is the Microsoft RAS server, you can say. And then from there, we connected with the system A, system B, system C. So this is basically my enterprise. You can see like that. Okay. So user wish to be connect with the enterprise network so he can able to access the resources. So user does the dial up. Definitely when you're doing dial up, these protocols only understand layer 2. So by this, the information carry to the Microsoft RAS server. Now when this is basically carried by the PPP. On top of it, we also add the PPTP protocol because Microsoft will not able to understand the layer 2 communication. We need something like a layer 3 communication protocol. So Microsoft will not able to understand PPP. So we basically carry PPTP request with PPP. Then Microsoft, when it receive the request, it basically asks for the username and password. Microsoft is using a PAP and CHAP. Primarily it uses CHAP, which is called as a challenge handshake authentication protocol, where the Microsoft will send the nonce value. So when they send the username password, it has a nonce value. That's why, sometimes you notice you get a login pop-up. So you enter the username, you enter the password. That password is used to encrypt the nonce and it send it back to the Microsoft server. Microsoft basically verify, validate by decrypting with the same key. If it decrypts successfully, there is a tunnel has been created. And then through the tunnel, we transfer the data. And this is the packet format we have when you're talking about tunnel. So we have a IP datagram, PPP payload, which is purely encrypted. So in PPTP, we use one encryption which is called as a MPP, Microsoft point-to-point encryption, which is used to encrypt this data. And this protocol is use the RC4 algorithm to encrypt the data, which is a symmetric encryption. Then we add the PPP header, which is understood by the layer 2, DT device and DC device. Then we have a GRE header, which is for the routing, and then we have a IP header for the network layer information. So this is how the PPTP is basically work. So PPTP tunnel established a connection on the TCP port number 1723. In most cases, the interviewer will basically ask this question. PPTP use GRE and TCP to encapsulate the PPP packet. This is what we happen and extend the PPP connection through the IP network because IP will not understand the PPP. So that's why we encapsulate that into PPTP so that IP network, which is a Microsoft gateways, will understand. Default PPTP use MPP encryption, which is called as a Microsoft point-to-point encryption, and MPP use one algorithm which is called as a RC4. So that is basically all about the PPTP. Now let's discuss about the L2TP. So when you're talking about the L2TP, L2TP is a tunnel which is, so Microsoft has some limitation that it can support above layer 3 communications and everything, layer 3 communications and everything. What about the internet is configured on X.25, internet is configured on the ATM, internet is configured on the layer 2 communications, layer 2 technologies and all that, because PPTP only work on the Microsoft IP networks and all that. So we are looking for such solution. There the Cisco come into the picture and Cisco basically introduced the L2TP, layer 2 tunnel protocol. So L2TP take PPP authentication and combine with IPSec to offer the secrecy, integrity, and additional layer of authentication. I covered the dedicated IPSec topic in my YouTube video. You can check that. So yes, L2TP default does not have any encryption. Like the way PPTP at least have a MPP, L2TP does not have a default encryption. He has to rely on IPSec for that. So with the help of IPsec, it can offer the confidentiality, authentication, and integrity. If you're talking about a high level IPsec, let me share the mind map of IPsec. So IPsec is the protocol suite which is used to protect the IP packets. So it has a modes, it has a protocol, and it has a key management. So when you're talking about the modes, we have a two modes here. So we have a transport mode and we have a tunnel mode. Then we have a protocol which is basically called AH and ESP. First we introduced AH which offer only authenticity and integrity. Later on ESP was introduced which address both confidentiality, authenticity, integrity. For the key management we have a IKE, Internet Key Exchange, which basically sum of ISAKMP and Oakley. IPsec default use AES for the encryption and for the hashing it use SHA. Okay, so that is the function of IPsec. For a digital signature key exchange, they use Diffie-Hellman. So that is a function of IPsec. So I'm planning to cover in a separate module about IPsec. So here we're talking about L2TP. So L2TP use IPsec by which it protect the IP packets. So L2TP use UDP. So UDP datagram contain the whole L2TP packet, which include the content of L2TP header. And L2TP use register UDP port number 1701. Okay, 1701. Now in L2TP, we have a two type of message. One is called as a control message and one is called as a data message. When you're talking about the control message, it passes control and data message over the separate control and data channel. So L2TP passes control and data message over the separate controls and data channel, and the inbound control channel pass the sequence controls, connection management, call management, error reporting, session control message, and everything. Okay. And when you're talking about data message used to encapsulate the PPP frame that are sent into the L2TP tunnel. That is basically the two type of message we have. So if you ask me the overall hierarchy of VPN, radius, IPsec, so let me explain that also, and then we'll discuss some coffee shots. Now, if you take a scenario here, okay, so we have a user one based out in India. We have a user two which is based out in Bangladesh, and we have a user 3 which is based out in Sri Lanka. They are basically connected with the internet. So this is my internet. Okay, I'm going to cover radius and TACAS plus in a separate module, but I thought I will cover very high level here. Okay, as we're covering the VPN. Now this is my router. Let me configure. So this is my router. And now what we did, this is basically my enterprise network. This is my enterprise network. Okay. Now what I did here is we have a VPN server which listen IP. We have a dial-up server which understand number, and then we have another VPN. They all are basically connected with the radius. And radius basically connected with the Active Directory or certificate authority. You can say AD as a LA also, LDAPs. So process is, now we have a user. So user basically with the help of internet do the dial up, do the IP dial, because here the client need to select the connection also, whether he need to go for PPTP or whether he need to go for L2TP. He select the PPTP L2TP from this pointer, and by this he send the request to VPN. So this is basically there is a possibility of using a dial-up protocol here, which is called PPP. And then on PPP we basically have a L2TP or we have a PPTP. Now VPN basically ask for the username and password. Username and password. This time either using CHAP. If using Microsoft, then Microsoft version is called as a MS CHAP. Or we have a PAP, which is more concern. Then he enter the username and password and he send the information to the VPN. Now VPN itself will not do the authentication because we also receiving a request from dial-up, we receiving from VPN. We also have an access point here who receiving a request from multiple users. So what I need here is I want a centralized identification, authentication, authorization. I'm looking for a centralized identification, authentication, authorization. So in that case, they will forward the information to Radius. Radius is act like a intermediate agent. To Radius, this request is carried by the protocol which is called as a EAP, Extensible Authentication Protocol. So because so far the packet does not have a IP, so it passed the information to Radius, so it is carried by the EAP protocol which work on the layer 2. Radius will pass this information to AD. Radius is just act like an intermediate agent. Radius pass this information to AD. AD will authorize and verify, and then he authorize the Radius. Radius will forward this information to VPN. And VPN is basically help us to create a tunnel between these two systems. And through this system, it basically transfer the data. So this is how it works. Radius has a limitation. It work on the UDP protocol, and the information which is basically exchanged from Radius to AD in a plain text. So in order to secure that, we basically introduce the TechAs Plus. Okay, TechAs is basically from a Cisco proprietary. So this is how the overall things works in the systems. I'm planning to cover the Radius in a separate module. So if you understand this topic well, let's have a coffee with Prab. Okay, so which type of tunneling protocol is supported for Microsoft environment? The keyword is Microsoft environment or MS gateway. So definitely directly we remove the L2TP for the Cisco. SSL VPN is also work, but SSL VPN is a vendor agnostic. It means it can work on the browser base and all that. And from exam point of view, remember that SSL VPN doesn't require any kind of a configuration. Open the browser and connect. So when we looking from the point of view of a least configuration, less tedious task and all that, we can go for SSL VPN. IPSec VPN, there's nothing called as IPSec VPN. VPN is work with L2TP and all that, so that is removed. So only option is basically left is A, PPTP. That's why the answer is A for alpha. Let's move to the next coffee shot. What is the primary limitation with PPTP? PPTP support layer 3, that is the advantage, that is not a limitation. PPT doesn't support the layer 2 WAN protocols, that is true. PPT do support layer 2 WAN protocol, it is a wrong statement itself. PPP send the data in plain text, which is a wrong statement. So only option which is very close is B. PPTP does not support layer 2 WAN protocol. That is why we introduce the L2TP. PPTP support from a layer 3 onwards for the Microsoft understanding. Okay. So which type of VPN implementation allow organization to establish VPN tunnel between two or more branches? Option A, site-to-site VPN. Option B, remote access VPN. Option C, HTTP, and option D, telnet. C and D is not there, so we're left with A and B. The keyword talking about here, two more branches. So answer is basically site-to-site VPN. Which VPN type inherit PPP authentication, integrate with the IPSec to provide confidentiality, integrity, potentially another layer of authentication? We know that the answer is basically L2TP because PPTP has their limitations. So let's move to the next part. Which type of VPN tunnel PV traffic cover various network type ATM, IP, and X.25. So answer PPTP doesn't support because these are work on the layer 2. There's nothing called as IPSec VPN. Telnet is for remote administration. So only option is basically left is L2TP.
Today we're going to discuss about SIEM. SIEM is a most frequent topic which is asked for L1, L2, L3 SOC interviews. It was also asked for the other job interviews, so I thought I will make one video on SIEM. If you're new to my channel, do subscribe to my YouTube channel and click on the bell icon to make sure you should not miss my future videos. My name is Prab Nair. For more information, you can refer my LinkedIn profile. So without wasting a time, let's start with the first part. So what is SIEM? SIEM stands for Security Information and Event Management, and it basically provides the organization with the next generation detection, analytics, and response. Before going to understand detail, let me first understand why we need SIEM. So example, like we have a firewall. Okay, and this is basically a switch. We have a system A, we have a system B, and we have a system C, and all are basically connected with the log management. So any activity, suppose there is an IP called 1.1.1.1. Okay, so we have a IP 1.1.1 which is able to bypass the firewall, and then it basically reaches system A, it compromises system B, it compromises system C. So it is difficult for the administrator to go to each and every system to collect the logs. At least they have a storage to maintain the logs, but in the case of firewall, routers, and all that, it is difficult to maintain the logs. So they need some kind of a delegated database to keep the logs. So all these logs are basically recorded in the centralized log server. The later challenge was, how to review those logs, how to manage those logs, how to read those logs, because storing the log in a one particular server is a one thing, and reviewing and responding according to that is a different thing. So it involved a lot of efforts and everything. So we understood these gaps, we understood the challenge, and then we basically introduced the SIEM function, which collect these logs, correlate, and respond to the incident according to the requirement. So that is why everywhere nowadays we use SIEM. So SIEM combines the security information management and security event management, which basically provide the real-time analysis of the security alerts generated by the applications and network hardware. So question here is, what is the key feature of SIEM? It provides the real-time visibility. Definitely whatever is happening in the organization, it gives the clear visibility. And we can basically consolidate the logs from the multiple source. The correlation of event is also happening from a different logs or the security sources. And the best thing is that when it correlate the information in one location, based on the threshold, it basically notify the security people. So if you want to know more in detail, let me discuss in detail each and every function of SIEM so you get a better visibility. And trust me, this information is not frequently available, or it's not much available in the websites. And problem is that it is asked for the interview parameters. So let's discuss that pointer now. So when we're talking about SIEM, the first thing is called as a device. Now it can be anything. Okay, it can be my router, it can be my switch, it can be my server, okay, it can be my database. Example, so we have a device. The first part of SIEM is the source device, okay, that feed information into the SIEM, and the source device can be anything, which we discussed. The second important thing is called as a log collection. So next step in the device or application log flow is somehow to get all the different logs from their native device to the SIEM. Okay, so that's why we need the function called log collection. But one thing we need to understand here, the log collection process is broken down into two fundamental methods. Okay, two fundamental methods. So any activity happen in the device, Okay, it basically send the logs to the log server. So we have a two way to collect the logs. One is basically called as a push method, and one is basically called as a one is push method, and second is basically called as a pull method. This is asked in the interview also. What is push and pull? So either source device send its log to the SIM, which is called as a push method, or SIM reaches out to the device and retrieve the log from the source, which is called as a pull method. Each of these method has a positive and negatives when used in your environment, but they both succeed in getting the data from a source device into the SIM. So that is the second feature of the SIM. It means the second function of the log collection. Then what happened? We basically normalize. So now that logs from the multitude of device and application in your environment have been forwarded to the SIM, what is happened next? At this point, the logs are still in their native format. If it's generated from Windows has their own format of generating a log. Linux has their own way of generating a log. Router has their own way of generating log. Okay, so they are in native format, so you have not really gained anything other than the centralized repository for your logs. So what need to be happen in order to make these logs useful in the SIM is to reformat them into a single standard format that is usable by the SIM. And the act of changing all these different type of logs into a single format is called as a normalization. Example, like if I say Windows, Microsoft Window. So in the case of Microsoft Window, it starts with IP example. Then it asks with the file name. But in the router, it starts with file and then it asks for the IP. Then in the Linux example, it starts with date, then it asks file, and then it asks for the other parameters. So we have to consolidate into one thing, that first we need a IP, then we need a file, and we need date. So this is called as a normalization. So each type of SIM will handle the act of normalization in a different way, but the end result is to have all the logs, no matter what type of device or a manufacturer, look the same in the SIM. So normalizing the event not only make it simple to read these logs, but also make it easier and allow for the standard rule of generation. Now normalization has been done. We consolidate and correlate the things. Next is basically called as a correlation of the engine. So rule engine expand upon the normalization of event from a different source in order to trigger the alert within the SIM due to the specific condition in these logs. And the method of writing the SIM rule is usually start of fairly is very simple. So that is something is called as a correlation of the engine. Okay. Then we basically have a log storage. To work with the volume of logs that combine into SIM, you need a way to store them for the retention purpose and for the historical queries. And these are typically three ways the SIM can store the logs. This is also asked in the interview. So we have a three way to store the logs. One, it is basically stored in a form of database. One is basically stored in a form of text file. And one, it is basically stored in a form of binary file. So database is there, text file is there, binary file is there. Okay, so that is basically done. Then this correlation engine and log data is going to be monitored. So final stage of SIM is the method of interacting with the logs, which is stored in the SIM. So once you have all the logs in the SIM and the event has been processed, you need a way to do something useful with the information. Otherwise, logs are just SIM for a storage purpose. So it is very important how you basically interacting with that. Okay, so we'll review the logs for the monitoring. So this is how it works. So one live example I can take. So we have a system A, we have a system B, we have a system C, and we have a system D. So this is basically the log storage, and this is basically the SIM. Okay, so we have a firewall here. And now what happened is we have an IP called 1.1.1.1. It was able to bypass the firewall, reach system A, reach B, reach C, reach D. At 7:10, it basically attacked the system A, and 8:10 it attacked the system B. At 9:10 it attacked the system C, and at 10:10 it attacked the system D. All these logs are basically stored in the log storage. Now in this case, what we did, we collect the logs from all the systems. Then what we did, we normalized the logs, okay, to form the one event.
Okay, and then with the help of correlation, we try to create the event, and that give the report to the security administrator or security analyst, and according to that they respond to the information. One thing you need to remember, whenever you're building SIEM or placement of SIEM, the most important thing, it should be mapped with the timestamp, because with the help of timestamp only you can able to create the events in a sequence, and NTP protocol play a very important role. Okay, so final stage in the SIEM is the method of interacting with the logs, which is stored in a SIEM. Okay, so once you have all the logs in the SIEM, the event has processed, and you need to wait to do something useful with the information. Okay, and SIEM will have an interface console, which will be either be web-based or application-based or loaded on your workstation. Both interface will allow you to interact with the data stored in your SIEM, and the console, be it will be web-based or application-based, it will be used to manage your SIEM. So this is the high-level thing we have in the SIEM function. Now let's discuss about the use cases. So SIEM is used in a compliance. Okay, so tighter compliance regulation are pushing business to invest more heavily in the IT security and SIEM. And that is why SIEM play a very important there, because with the help of SIEM, it helps the organization to be comply with the PCI DSS, GDPR, HIPAA and SOC standard. Now just imagine you operating your service, you're operating your entity in Europe. You're very concerned about GDPR. So SIEM will monitor your organization data for all these compliance reasons. If you don't have a SIEM, we are unable to do the monitoring. And then what happened? We might face the consequences of the compliance issues. Okay, so such compliance or mandate are becoming more prevalent and place increased pressure on detecting and reporting the breaches. So while SIEM was initially used mainly by the large enterprise, due to the growing emphasis on the compliance and keeping the business secure, it may be required for the small and medium-sized business, because regulations such as GDPR, PCI DSS, HIPAA, and PIPDA are applicable to the organization irrespective of the size. Second use case of SIEM is used for the insider threats. External threats are not only things that make the organization vulnerable, but insider threats pose the considerable risk, especially considering with the ease of access. According to the insider threat statistics of Verizon data breach investigation report, 3 of the top 5 causes of security breaches was related to the insider threats. So integrating with the UBI and all that, we can able to monitor the behavior of the employee. And SIEM basically help us with the granular monitoring on those cases. So by this way, we can able to identify all those attempts, like installing of the software, disabling of the security software. The third use case where the SIEM can be more effective is the high privilege access abuse. See, privilege access abuse is a complex problem which is stemming from a gaps in access control at the organization, and user with the access to IT systems are able to perform the undesirable action. And because they have more rights, they can need to do more jobs. So SIEM basically monitor that, and you will be surprised to know that according to Verizon report, the privilege access abuse was the third largest cause of data breach and second largest cause of security incidents. And recently, SIEM became a great use case for the IoT also. Even the Gartner predicted that there will be 26 billion connected devices by 2021. But with the progress come risk, as more connected devices offer more point of entity through which the target business, because as soon as hacker is one of the network through the connected device, they can access to the rest of it easily. And most IoT solution vendors provide their APIs and external data repository that can be easily integrated into the SIEM solution. And this make the SIEM software an essential part of a business cybersecurity, as it can mitigate the IoT threats such as DOS attacks, flag at risk, and compromised device. So these are some of the use cases we have. Now question is, what are the leaders of SIEM? So we have a Splunk, we have IBM QRadar, we have a Logarithm, we have a RSA ArcSight, and we have a McAfee. So these are the important review we have for the SIEM. If you find this video useful, do share in your network, and do share your comments about how you find this video. And do let me know, as per your opinion, what is the best SIEM tool. Thank you for watching my video. If you're new to my channel, do subscribe to my YouTube channel and click on the bell icon to make sure you should not miss my future video. Thank you.